dignitaries, participants, authors, and delegates to the 9th International Conference on Cable, Wire and Accessories. We request all the dignitaries to please move forward for the lighting of the lamp. Mr. Rohit Pathak, Senior Vice President IEEMA. Mr. Vijay Karia, Chairman and Managing Director, Raveen Group. Mr. Shri Gopal Kabra, Managing Director and Group President, RR Global. Mrs. Sonal Gariba, Chairperson, IEEMA Cable Division and Executive Director, Raveen Group. Mr. Reshu Madan, Vice Chairman, IEEMA Cable Division and Head Infrastructure Business, Sterlite Power. And Mrs. Charu Mathur, Director General, IEEMA. Thank you. Shri Gopal Kabra, sir. Now I request all the dignitaries to please take their seats on the dais. May I now request Mrs. Sonal Gariba, Chairperson, IEEMA Cable Division and Executive Director, Raveen Group, to please take the mic and give the open remarks.
That's it. Good morning, ladies and gentlemen, and a warm welcome to all the dignitaries on the stage, my seniors, Mr. Vijay Karia, Mr. Gopal Kabra, Mr. Rohit Pathak, Reshu Madan, and Ms. Charu Mathur. I welcome you all to the 9th edition of International Cablewire Conference. My sincere appreciation to this elite gathering and for joining us here today. Welcome to the dawn of the new era of infrastructure development. The world today is moving towards infrastructure in a manner where the fulcrum is electricity. The mantra of electricity being TAAA, which means technology which is available, accessible, and affordable. And today, we are on the cusp of this technological changes, where now it is not only entails new products, but also reorganizing the product portfolio, making application-specific products. So from one cable for all applications to specialized cables for each application. The trend is moving towards customization of cables. At the same time, we have not forgotten the concern for the environment, nor the safety of the lives of our people. With the focus of safe deliverance of electricity, the quality and reliability assumes the paramount importance. Our innovations in safety will build the confidence that our loved ones can be safe in high-rise buildings as well as in metros and public places. As the world turns to electricity to help tide over energy and environmental crisis, India has been leading from the forefront in terms of renewable energy. With the development of infra projects and the government investment in driving the growth, Indian wire and cable industry has the potential to grow by $1.65 billion in the next 5 years. And this can only happen if we technologically upgrade ourselves. We need to keep in mind that whether it is fossil fuel, solar, green hydrogen, or whatever form of electricity it is generated, there is only one way to deliver it, that is wires and cables. At such a time, the wire and cable industry in India recognizes its commitments not just to the country, but the world at large. Keeping this in mind, and to ensure that the industry keeps pace with the fast-changing, exciting developments in the industry, this conference has been curated on the themes Innovations and Beyond, focusing on transitioning from energy into electricity. In this 2-day conference, there will be 24 technical papers and interesting case studies covering all aspects dealing in upcoming materials, diagnostics, technological trends, amongst others. To add to this, there are 2 exclusive discussions which will touch upon innovative materials and safety and sustainability. Coming to public accessibility, to charging points for EVs put an added responsibility on the wire and cable industry with a need for upgradation of technology. Keeping this in mind, we have a special address on day 2 touching upon EV infrastructure from a cables perspective. Friends, I'm very happy to inform that we have received an overwhelming response with more than 400 plus delegates from more than 160 organizations registering for this event. I'm thankful to the state and central utilities, the consultants, the cable wire manufacturers, raw material suppliers, R&D and testing laboratories, academia, for their participation in this 2-day conference. I'm sure this conference will bring a lot of knowledge and new insights to the industry and provide us with the way forward approach to be future ready and bring a revolution in the country. So please feel free to engage and help carve the path towards a sustainable and safe ecosystem. Thank you. I'll call Ms. Charu Mathur now to please come and take the stage.
Thank you, everybody. Thank you, Sonal. Our chief guest, Mr. Ghanshyam Prasad, is also on his way. So I'll take this time very quickly to just make a few points. First of all, I want to acknowledge the leadership of Ms. Sonal Gareba for the cable division for helming this wonderful conference which has got a fantastic response from the cable industry. So hats off to you, Sonal. Thank you so much. I also want to acknowledge the presence of 2 doyens of the cable industry, Shri Gopal Kabra ji and Vijay Karya, who have been leaders, thought leaders of the industry. So and they're also IEEMA members, but yet I think we're very privileged to have them with us. Rohit Pathak, Senior Vice President IEEMA, thank you for your presence and your encouragement to us. As Rohit will, I think, probably take you through one of the, the vision exercise that IEEMA has done. So I will probably just very quickly touch upon it. I think we've got, the industry has got great potential in being able to count for 3 to 5% of the country's GDP by 2047, and the electrical consumption increasing to 10,000 units. There is possibility for India to be leaders in green hydrogen and storage. One of the things that the industry will probably have to focus on is quality and safety, which I think you will hear the leaders of the industry talk about. I will quickly take you through IEEMA, which is an event which is familiar to all of you. It is the flagship event of IEEMA. It is the flagship event of the electrical industry. And the 15th edition of IEEMA is due in February in NCR at the IEEMA. We already did an analysis. Most of you have booked the space, but for those of you who are still waiting and watching, I'll just quickly give a quick overview. Can I just have the presentation, please? Quickly. Okay. So, do we have a changer? Okay. Yeah, thank you. Do I have a changer? I can just, okay. The theme for ELECRAMA 2023 is Reimagine Energy for Sustainable Future. You will see the difference from electricity to energy because that's the future the world is moving towards, and that's where India's journey is. Next one, please. Do note the dates, 18 to 22nd February 2023. We've already got a fantastic response to ELECRAMA. More than 75% of the space was already booked within 10 days of us opening the booking, right? So already 28,000 square meters of space has been booked. We are in very serious conversations with Germany for a partner country. They're promising a huge space already. We have very serious interest from France, who's looking at very key partnerships, including nuclear energy with India, with UK, with Canada, with Romania, and several other European countries. So you will see a significant international participation in ELECRAMA 2023. We will have sustainability, safety, and quality and innovation as some of the sub-themes, along with the focus on new energy, right? Germany has already come in for our co-located events like World Utility Summit. Germany and USAID have already come in as partners, and they will, as you can see, charging infrastructure, components, battery storage, value systems, green hydrogen will be focus areas. Just a short, brief comparative, we are looking at a much larger ELECRAMA this year with 100,000 square meters of space, with 1,500 plus exhibitors, with about 18 odd country pavilions. The last ELECRAMA edition, 2020, saw business inquiries worth 4.6 billion. We expect 6 billion this year. This is not just some projections. We are seeing the trend in any business meeting that IEEMA has been organizing in the past 1 year, including E3, where the response to B2B meetings has been tremendous. Where we have a very, very serious business visitor footfall plan underway, which I will take you through. The co-located shows eTechnex in a new avatar, which will focus on new energies, which will focus on green hydrogen technology, which the government of India and the rest of the world also has on its mind map. Nuclear energy storage. We will be talking about capital, raising capital for investments into this new energy area. Net zero, which is also the government of India's focus, which you heard the Prime Minister talk about, will be a big focus. We are already in conversations with ISRE and IGBC, and they will come on board as key stakeholders as well. The World Utility Summit will see, as usual, utilities from across the world come and share best practices. The reverse bioseller meet, we've had very fruitful meetings with the Commerce Ministry, with the MEA and the Power Ministry. They're very, very keen and excited to support the reverse bioseller meet. So we will get 700 serious buyers from across geographies. So the Ministry of Commerce has recently opened Europe also under the MAI scheme. So we are expecting a huge business delegation from these countries as well. The domestic bioseller meet you're all familiar with. We will have utilities, but this time, under guidance from the OC and some of our senior members who are present here, we will be looking at non-utility buyers as well. So you will see utility buyers, but you will also see non-utility buyers like smart cities, metros, defense. We are already working on that. A sample was already presented in the E3, where we had large non-utility buyers present their procurement requirement. Rail Urja, we are already in conversation with the Railway Ministry. So all in all, I think ELECRAMA 2023 has great opportunities to offer. If I was to sum up, you will see a very clear, sharp focus on new business opportunities in ELECRAMA 2023. So while we are going to strengthen the core of transmission and distribution, we will also, in line with the vision which Rohil will outline, focus on new business opportunities for our members. We will focus on sustainability and net zero in line with the country's vision in this platform. There will be a platform for innovations and startups. We are also in serious conversations with the Fraunhofer Institute of Germany, who have confirmed their participation to us for the presence and curating an innovation showcase hub for ELECRAMA. This is an outcome of the visit that we had to Hanover. We've been having meetings with Fraunhofer Institute for the past 6 months, but they have confirmed verbally to us that they will be putting up a showcase. Green hydrogen, AI, IoT, storage will be other areas that we will be looking at. As I also mentioned, we are, our business visitor promotion is a little different from last year. We're not just going to be on mailers, we are going out in the rest of the country. We are talking to various local industry associations. We will be strategically tying up with them. We will be effectively using social media to get the domestic participation, especially business visitors. So stall openings are reopening very, very soon. Please note the dates, 18 to 23rd February in Greater Noida. For those of you who have not booked your stalls as yet, please look out for this opportunity and this window and book your stalls now. Thank you. I'll now request Mr. Shrigopal Kabra to kind of address us. Thank you.
On the dais, Mr. Rohit Pathak, Vijay Karyaji, Sonal, Charu, the last gentleman is Vice Chairman. And dear friends, ladies and gentlemen, I welcome Sri Ghanshyamji Prasad, Chairman CEA, on the We all know that wire and cable industry is the most valuable product in terms of electric industries. And India, in a global market share, we are just 4% of world industries. India is only 60,000 crore business we do wire and cable, and entire global is around 15 lakh crores. So we should have a goal that as the India, how can we achieve a 15% market share of the world? See, our government is looking that we should have a $5 trillion economy, $2 trillion exports, and we are lagging much behind. But before we want to be a global player, are we really quality player in India? It's a big question mark. Ghanshyamji, I would like to have your attention because I talk always on the safety, and it's a really bad part to talk on this platform, being an IEEMA past president and a manufacturer also, that India got the lowest electrical standard in electrical product. और वायर एंड केबल की थोड़ी कहानी आपको सुना दूँ हिंदी में तो क्या शायद सबको अच्छे समझ में आ जाएगी कि जो आग लगती है पूरी दुनिया में ये गवर्नमेंट के स्टैटिक्स है, मेरे नहीं है, जो हमने IEEMA के जो मैं प्रेसिडेंट था तो इलेक्ट्रिकल फायर सेफ्टी एक कॉन्क्लेव किया था जो इंडिया में पहली बार हुआ था. तो गवर्नमेंट ऑफ इंडिया की तरफ से जो ऑफिसर्स आए थे उन्होंने आंकड़े दिए थे कि रोज़ के 52 लोग आग से मरते हैं. रोड एक्सीडेंट के बाद सबसे हाईएस्ट अगर किसी चीज़ से मरते हैं तो आग से मरते हैं. और जितनी भी आग लगती है दुनिया में उसकी 75% इलेक्ट्रिकल के कारण से होती है, शॉर्ट सर्किट से होती है. वो जो 75% होता है उसका 70% जो होता है वायर एंड केबल या स्विच गियर के कारण से होता है. इसलिए वायर एंड केबल जो सेफ्टी के हिसाब से ये सबसे महत्वपूर्ण प्रोडक्ट है. सबसे पहले ज़रूरत है कि हम सब जानते हैं कि यूरोप इलेक्ट्रिकल इंडस्ट्रीज़ में सबसे टॉप में है. चाहे हम स्विच गियर की बात करें, चाहे वायर एंड केबल की बात करें, जितनी भी बड़ी कंपनियां हैं वर्ल्ड में, वर्ल्ड की जो नंबर 1 नंबर 2 कंपनी है, प्रेसमैन, नेक्सन्स, या जो भी इलेक्ट्रिकल इनोवेशन होता है दुनिया में यूरोप से होता है. तो सबसे पहला काम ये है कि हम लोग, मैं रिक्वेस्ट करूँगा CEA से और IEEMA से, चारों से, और रोहित पाठक जो इनकमिंग प्रेसिडेंट हमारे होने वाले हैं, कि बीडी और बासेक और बीआईएस के स्टैंडर्ड को कंपेयर किया जाए। घनश्याम जी, मैंने बहुत कोशिश की मैन्युफैक्चरिंग को इकट्ठा करके कि हम लोग इसको ठीक किया जाए। हाँ भी बोलते हैं, जब मीटिंग होती है तब पीछे हट जाते हैं। और पूरी दुनिया में आज जो पीवीसी वायर है वो धीरे धीरे बंद हो रहा है। आपको मैं कुछ आंकड़े देना चाहता हूँ। मैं भी डेनमार्क में था, डेनमार्क से स्वीडन एकदम बाजू में है। स्वीडन में अगर आप एक माले के ऊपर बिल्डिंग बनाते हैं और उसमें कुछ बेचते हैं तो आप पीवीसी वायर यूज़ नहीं कर सकते। इट हैज़ टू बी हेलोजन फ्री फ्लेम रिटार्डेंट, जिसको लो स्मोक जीरो हेलोजन बोलते हैं। और पूरी दुनिया में जितनी भी कमर्शियल बिल्डिंग होती है या हाई राइज बिल्डिंग होती है उसमें पीवीसी वायर नहीं यूज़ कर सकते हैं, ये होना चाहिए। और इसमें भी 90 डिग्री होना चाहिए क्रॉस लिंक। हमारे इंडिया में हमारे दोस्त लोगों ने इसको 70 डिग्री वाला भी बना दिया, जिसको मैं बड़े मजाक में बोलता हूँ एक डुप्लीकेट हेलोजन फ्री वायर है, ओरिजिनल हेलोजन फ्री वायर है एक। अभी सर, वी आर द लार्जेस्ट केबल एक्सपोर्टर ऑफ इंडिया। वी आर द ओनली कंपनी इन द वर्ल्ड विच गॉट 33 इंटरनेशनल अप्रूवल सिंगल फैक्ट्री, ओनली कंपनी इन द वर्ल्ड सर। तो ये करने के पीछे कारण क्या है? लेकिन आपको बता दूं सर, सेंट्रल विस्टा जो देश का एक मॉन्यूमेंट है, जिसको ये सेंचुरी का मॉन्यूमेंट है, उसके भी आप इलेक्ट्रिकल प्रोडक्ट चेक करवा लीजिए कोई ग्लोबल एजेंसी से। आई गिव चैलेंज कि कोई भी ग्लोबल स्टैंडर्ड के हिसाब से उसमें प्रोडक्ट यूज़ नहीं किया गया है। उसमें पहले हेलोजन फ्री वायर था, बाद में चेंज हुआ सर, एफआरएस वायर यूज़ हो रहा है। एक मज़े की बात और बताना चाहता हूँ कि एफआरएस वायर नाम की चीज़ पूरी दुनिया में भारत को छोड़ के कहीं नहीं है। एकमात्र देश है जिसमें एफआरएस वायर होता है। तो मैं बीआईएस में भी गया था सर, सीए में भी गया था, और बाकी मैंने कि एफआरएस वायर नाम की इंडिया में होना ही नहीं चाहिए, बीआईएस से निकाल देना चाहिए, नंबर 1। नंबर 2, जो हाउस वायर जिसको बिल्डिंग वायर बोलते हैं, उसमें सब जगह 7 स्टैंड है। हमको इतिहास में जाना पड़ेगा सर। हमारे आज़ादी का अमृत महोत्सव में बहुत सारे कानून सुप्रीम कोर्ट भी कैंसिल कर रहा है, गवर्नमेंट भी कैंसिल कर रही है। तो ये फ्लेक्सिबल वायर आया कैसे, इसकी एक कहानी जानना बहुत ज़रूरी है। कि कोई गलती की शुरुआत भी होती है तो उसको कहीं ना कहीं तो ठीक करेंगे सर, क्योंकि हाउस वायर जो है वो स्मॉल स्केल इंडस्ट्रीज के लिए रिजर्व था। 7 स्टैंड वायर जो अपने जो कुलतोड़ राज की बात करता हूँ, ये मेरे को ज्ञान विजय भाई ने दिया हुआ, इसलिए बता रहा हूँ विजय भाई के सामने। और उसके बाद फिनलेक्स कंपनी ने इसको चालू किया फ्लेक्सिबल वायर एज ए इंडस्ट्रियल वायर। इसलिए दुनिया में आपको 100 मीटर की पैकिंग मिलेगी, 100 यार्ड की पैकिंग मिलेगी। इंडिया में हाउस वायर से 90 मीटर में बिकता है, वो भी एकमात्र देश है हम, और ये फ्लेक्सिबल वायर बिकता है। तो पहली बात तो फ्लेक्सिबल वायर हाउस वायर में होना इटसेल्फ इज रॉन्ग प्रोडक्ट। इसके बाद सर बीआईएस ने एक और गलती की कि पैनल वायर और जो हाउस वायर है दोनों को IS 694 कर दिया। पूरे दुनिया में कहीं भी अगर आप बासेक में जाएंगे, यूके सर आपको बताता हूँ कि यूके में खाली केबल के लिए एक एसोसिएशन है गवर्नमेंट की, जिसके अंदर 42 आदमी की टीम है। हमारे बीआईएस में मेरे को लगता नहीं, ईटीडी डिवीजन जो इलेक्ट्रिकल डिवीजन उसमें 42 आदमी है। तो पूरे बासेक में आपको पैनल वायर के लिए BS 6231 होता है, अपना इसके लिए हाउस वायर के लिए 6004 होता है। तो सर उसके चक्कर में क्या हुआ कि क्लास 2 कंडक्टर के बदले एक कंपनी ने सर क्लास 5 कंडक्टर चालू किया, जिसके कारण से आपकी आग लगने के डर, पावर के बिल ज़्यादा, ये दोनों बहुत ही खतरे की बात हमारे यहाँ चल रही है। अब चूंकि एक ने किया, सबका मार्केट लूज होने लगा, धीरे धीरे करके सर सबने करने लगा। तो आज इंडिया में हालत हो गई है कि 80% वायर सर क्लास 5 कंडक्टर है। ये बहुत बड़ी चैलेंजिंग सब्जेक्ट है, बहुत दुख है, बहुत दर्द है इस बात का। एक तरफ हम सेफ्टी की बात करते हैं, हम ग्रोथ की बात करते हैं, लेकिन क्योंकि हम सर 140 करोड़ इसलिए क्या सर थोड़े लोग मर जाए तो फ़र्क नहीं पड़ता है, कोई बात नहीं है सर। लेकिन आज इतनी होटलें बन रही है, इतना सेंट्रल विस्टा पार्लियामेंट बन रहा है सर, इतना बढ़िया, जहाँ प्रधानमंत्री आगे चल के 1000 MP हो जाएंगे, वहाँ बैठने वाले हैं सर, वही सुरक्षित नहीं है आपका। हमने बहुत मेहनत की जाके कि सर ये हेलोजन फ्री वायर होना चाहिए, सर क्लास 2 कंडक्टर होना चाहिए, लेकिन कुछ न कुछ कारण से सर आप जानते हैं कि क्या हुआ है। तो लेकिन जो रूल आपको बनाना चाहिए कि कोई भी कमर्शियल बिल्डिंग हो, चाहे रेस्टोरेंट हो, चाहे बैंक हो, चाहे छोटे जहाँ भी हो, वहाँ पे PVC वायर नहीं होना चाहिए कोई भी हालत में। कंडक्टर का जो विषय है क्लास 5 क्लास 2 का, सर आप अगर मैन्युफैक्चर को साथ में लेंगे, ETD कमेटी को साथ में लेंगे, कभी नहीं होगा, क्योंकि उसमें अलग तरह के लोग ज़्यादा है मेंबर और इस तरह के लोग कम है। आपको वीडी और बासेक के स्टैंडर्ड को कंपेयर करिए, या तो वो समझदार नहीं है या हम बहुत समझदार हैं, क्वेश्चन ये आ रहा है। अगर आप देखेंगे वर्ल्ड वाइड, आज यूके में हम लोग वी आर द लार्जेस्ट एक्सपोर्टर फॉर यूके। आज 45% वायर हेलोजन फ्री हो गया है और 55% ये बचा है, और अभी जो नई जो टेक्नोलॉजी चल रही है सर, उसमें हम लोग 60% हो गए। जब ये हमने सर 99 में चालू किया, आपको सरप्राइज होगा सर, मेरे को BIS मिलने के लिए 19 साल लगे, क्योंकि BIS के पास टेस्टिंग फैसिलिटी नहीं थी। तो BIS के पास भी टेस्टिंग फैसिलिटी होना ये हमारे लिए बहुत ज़रूरी है। HRPVC मिनिमम होना चाहिए सर, रीच कंप्लायंस होना चाहिए। कहीं ना कहीं हमारे पास सिर्फ क्या लोग, हम क्या आर वी हियर टू जस्ट मेक मनी और पीपल सेफ्टी? ऐसा पैसा भी क्या काम कर सकता है जिससे हम लोगों को नुकसान कर रहे हैं? आखिर ये हमारे देश की सुरक्षा का सवाल है सर। आज आपको बताता हूँ, इंडिया कैन बिकम हब फॉर केबल मैन्युफैक्चरिंग। सर हमको गोल होना चाहिए कि हम वर्ल्ड का 15% केबल यहाँ बना के पूरी दुनिया को सप्लाई करें। आज हम सिर्फ 4% पे 15 लाख करोड़ की इंडस्ट्रीज में वी आर जस्ट 60,000 करोड़ इन इंडिया। आज इंडियन कॉर्पोरेट हिंडाल्को है, अपना वेदांता है, अभी अडानी आ रहा है सर, सब कॉपर और अपना एल्यूमिनियम में इतना इन्वेस्टमेंट कर रहे हैं। तो इन्वेस्टमेंट अगर ये खाली रोड सप्लाई करके तो क्या लेबर जॉब मिलेगा हमको, क्या वैल्यूएशन मिलेगा? गवर्नमेंट की PLA सर इलेक्ट्रॉनिक में हो रही है, दैट विल गिव टॉप लाइन, लेकिन इसमें हम लोग लेबर भी देंगे, इंडस्ट्री भी चलेगी, हमारा ट्रांसपोर्ट चलेगा, और हम एक मेक इन इंडिया को जो बढ़ावा दे रहे हैं उसका एक कारण बनेगा। तो हमको कहीं ना कहीं सेफ्टी फर्स्ट ये होना बहुत ज़रूरी है। आज हमारे एक प्रोडक्ट सर, आपको सोलार केबल के बारे में बताना चाहता हूँ। विजय भाई उसके बारे में ज़्यादा बताएंगे। सोलार केबल में सर HFFR कंपाउंड होना कंपलसरी है, TVU अप्रूव होना कंपलसरी है। मैं आपसे रिक्वेस्ट करता हूँ, आई विल फंड मनी 100 करोड़ तक मैं खुद मेरा फंड करने को तैयार हूँ। आप सारे जितने सोलार प्रोजेक्ट लगे आप चेक करवाइए, कितने में सोलार केबल सही लगा हुआ मेरे को बताइए आप। क्योंकि अगर सोलार केबल सही नहीं है तो जो ओरिजिनल सोलार केबल बोलते हैं, जो HFFR इंसुलेशन बनता है, TVU अप्रूव होता है, उस केबल की लाइफ 25 साल है। बाकी जो XLP इंसुलेशन से जो बनते हैं सर, उसकी लाइफ 5 से 7 साल है। कॉन्ट्रैक्टर की गारंटी 5 साल की होती है, कॉन्ट्रैक्टर चला जाता है। आपके L1 की बीमारी में भाव कम होते होते इतने कम हो गए कि कॉन्ट्रैक्टर कॉन्ट्रैक्ट लेता है और बाद में कॉम्प्रोमाइज़ करता है। पर हमारे पास कोई सेफ्टी नॉर्म्स नहीं है, हमारे पास चेकिंग नॉर्म्स नहीं सर किया जाए। ये बहुत बड़ी चैलेंज है, आप चेक करवाइए। मैं बोलता हूँ सर, आपको एक रिपोर्ट चाहिए तो मैं आपको प्रिंट आउट भी दे सकता हूँ। अभी इंटरनेशनल कॉपर एसोसिएशन है हमारा, इट्स अ ग्लोबल ऑर्गेनाइजेशन, उसने 50 हाउस वायर टेस्ट कराए। ये मेरी रिपोर्ट नहीं सर, इट्स इंडिपेंडेंट एसोसिएशन। उसमें 36 हाउस वायर्स फेल हुए, आउट ऑफ 36 फेल, और अच्छी अच्छी कंपनियों के। इसमें कोई भी अनब्रांडेड कंपनियों के सैंपल्स नहीं है, सब ब्रांडेड कंपनी के सैंपल से बता रहा हूँ आपको कि ये क्लास 5 कंडक्टर के कारण से, और सारे के सारे सैंपल जो फेल हुए वो क्लास 5 कंडक्टर के फेल हुए। पहली बात तो सर जो क्लास 2 फ्लेक्सिबल है वो टेक्निकल गलत है, उसके बाद हम एक कदम और आगे चले गए सर, क्लास 5 गलत हो गया। तो ये इतनी बड़ी समस्या है सर। मैं CA ऑफिस में 3-3 घंटा बैठ के गया हूँ, BIS में खुद जाके गया हूँ। मेरी चिंता नहीं सर, मेरी कंपनी डूइंग वेरी वेल सर। 22 साल में फ्रॉम जीरो टुडे वी आर द 4th लार्जेस्ट इन इंडिया एंड वेरी सून विल बिकम सेकंड लार्जेस्ट बाय डूइंग एक्सपोर्ट्स। वैसी सर केबल में समस्या है। कल मेरे लोग बैठे थे मेरे साथ, मेरे CFO डायरेक्टर सब बैठे, सर बोला अपनी कंपनी प्रॉफिट आ ही नहीं सकता है। बोले कैसे? सर जो केबल के भाव है आज, मैं गारंटी देता हूँ अगर वो परफेक्ट माल है सर, कोई भी आदमी 1 या आधा टका प्रॉफिट नहीं कमा सकता है, और सबकी बैलेंस शीट में 7-8 टका 8 टका प्रॉफिट है। आ कैसे रहा है? केबल की साइज भी चोरी है। आप जो पावर केबल, जो इंडिया में इतना बड़ा इंफ्रा में इन्वेस्टमेंट आ रहा है, करोड़ अरबों रुपए इंडिया में, चाहे आप रेलवे करेगी चाहे हाईवे करेगा सर। सरपंच ये मौका है, क्योंकि ये इलेक्ट्रिक इंडस्ट्रीज की ज़रूरत है सर, क्योंकि आप लोग का समय मिलता नहीं और ये प्लेटफॉर्म भी नहीं मिलता नहीं है। लेकिन आपको एक रिक्वेस्ट है सर कि केबल की क्वालिटी के ऊपर ध्यान दीजिए, बहुत ही भयंकर मामला गड़बड़ है, आप लोग ध्यान दीजिए। थैंक यू वेरी मच।
Thank you, Kabraji. I'll now request Mr. Vijay Karya to address us.
Thank you, Charu. Warm welcome once again to Mr. Ghanshyam Prasad and my friends and colleagues on the dais. Shri Gopal Kabra ji has on electrical wire and cable thrown a very big bucket of ice cold water to wake us all up. And I can say for sure that everything that he said stands true, unfortunately. And he's shown ourselves a mirror, and I think very honestly and very transparently, being part of the industry, it is also very important that we are honest, not just with ourselves, but with the entire stakeholders of the industry. Yes, I mean, I would move on and say that there are lots of flaws that need correction, and I'm sure Mr. Ghanshyam Prasad is making notes of this. And I think knowing the government, knowing their propensity to act quickly, and especially two things which augur very well for the industry, for the wire and cable industry, because of the entire segment of the electrical industry. The wire and cable industry in IEEMA holds the largest share, nearly about 30%. And therefore, we have either much to lose or much to gain. But as I said, two things which augur very well for the industry is, number one, a few days ago, the Prime Minister talked about the losses of the DISCOMs, and one of the things which we need to understand is that if the DISCOMs are making money, then they can honestly pay more money, because as Sonal said, affordability is one of the issues of the industry. But I think with the first time we have the focus on the power sector, not just in the central government, but also across various state governments, and that's auguring very well for the industry. Just yesterday and today he sent it to me, my friend Mr. Suresh Prabhu was the organizer or the initiator of the reforms of the power sector right in 2000, has written a very nice article on what needs to be done for the DISCOMs, because if we continue in the same manner, like if you keep planting mango seeds in the ground, you will only get mangoes, but you are expecting pineapples, you are expecting apples. So I think there has to be a fundamental change in the outlook of the industry. We people need to do it. Another point which came up and was very justified is that we had one product. For railways, this product. For airports, the same product. For power stations, the same product. And therefore, the industry was not moving towards research and development, and therefore, I am very pleased that this wire and cable conference that we are having has chosen a subject which is innovations and beyond. Now, I think 2-3 things, sir, Mr. Ghanshyam Prasad, I would like to highlight, which we as an industry would request that we partner with the government, we partner with the various stakeholders. So the first and foremost aspect, and again, Mr. Gopal Kabra touched on it. Sir, number of lives lost every day is 73, not 53. Okay. You were referring to some old data, and unfortunately, this number keeps going up every year. Therefore, the first issue that I have to bring about is safety, and we people being part of this industry need to focus on how we can make our products safe. And of course, when we talk about safety, quality goes hand in hand with safety. The other aspect that we need to talk about is standardization. And this is where there is a little bit of anomaly in maybe within ourselves. As part of the industry, I believe we are all colleagues, or either most of the people are very large stakeholders in the cable industry, either manufacturers themselves or big users, or even consultants, contractors, etc. So the second part is standardization. And as I was saying, it's an anomaly. Why? Because anomalies are that on one side we offer too many products for the same wire, like we have a PVC wire, we have an HR PVC wire, we have an FRLS PVC wire, we have a low smoke zero halogen low smoke zero halogen LSZH wire, we have electron beam cured wires. So we have a plethora of wires. Why so many specifications? Why should you offer so many different specifications? Because the moment you have various choices, and people who have many clothes or many cars always in the morning have to think what to wear today. Should I wear this clothes or should I wear that? Should I use this car or should I use that car? And this is where a problem occurs. When you offer a plethora of choices, it can be easily mismatched. You can have a PVC wire put into a box of FRLS wire and sell it off. The poor user does not know. Therefore, standardization of specifications and standardization of specifications across the country. This is one very important thing. The third thing, and I think all of you all will agree, that our industry is pathetically small. And why it is small? Because sir, इंडिया में जुगाड़ चलता है. हम लोग जहाँ तक खींच सकते हैं वो प्रोडक्ट को खींच के यूज़ करते हैं. अगर टॉवल फट गया, टॉवल को यूज़ कर दिया तो हम लोग उसको फाड़ के पोछा बना देते हैं. पोछा बनाने के बाद उसका और कुछ करते हैं, कपड़े को थैली में बदली कर लेते हैं. सो वी हैव द प्रोपेंसिटी टू मैक्सिमाइज द यूजेज ऑफ प्रोडक्ट्स. And the same thing is happening in the wire and cable industry across the world. Within a period of 25 years, the products are replaced. I was talking with Rohit and Kabraji some time ago, and if they replace those products, जो आज aluminium और copper का price है, they will recover more than the cost of the initial cable itself, and your safety aspect increases. The other thing is that, of course, there is no other way of transmission, and we have huge amount of T&D losses, more of D losses, the distribution losses. Now, again, with the rapid urbanization of the country, we are yet talking about overhead conductors, bare conductors, or at the most we are talking about why have bare conductors, let us insulate them and put them overhead. Why can't we go underground? That's a much safer and much more cost-effective way, because ultimately you should not look at the cost of the product at that face value, that this is the cost. You should look at the life cycle cost of the product, and this is something that we people as an industry need to understand and incorporate first within ourselves and then within the minds of our customers. Sir, forget wires and cables. We are talking about the Central Vista project, and we are closely associated with it in more ways than one. We are talking about this project because it's a project which is very prestigious, and therefore there has to be a lot of focus on the quality of the product. But if you go across the country, and we are witness to this, that wire is one small part, that is the consumer part, and that directly affects people. But even the cables, the underground cables, the HV, the EHV cables are subjected to, unfortunately, to admit, a lot of theft in the quality and perhaps also the quantity of the product. And this is something as an industry we need to sit back and ask ourselves that what is the motto of this industry? On one side, we say we are very large exporters of cables and therefore we compete in the world in quality markets. But the second thing is that is the product that you are manufacturing in the country equivalent to the product that you are exporting outside the country? And therefore, there needs to be a standardization of both these products. Sir, I know Mr. Ghanshyam Prasad is in a hurry, so I will not take too much of time. But sir, the plea out here from our industry is that we should partner with the various factions of the government, and not just the central government, but also the state governments. I can tell you for sure that this industry is keen to rectify a lot of things that are wrong with the industry. But sir, first, the government has to remove this aspect of L1. We have been at IEEMA propagating this continuously, that L1 concept, please sit with us and let's work out what we should do. The second thing, sir, as a CEA, and I would say that there should be some kind of pricing guidelines, that this is what should be the base price of this product. It cannot be lower than this. If it is lower, check it out. I'm not saying necessarily chuck it out, but check it out, check the quality of that product. It's not difficult to do so, sir. This will help in also regulating the industry. The last part which I say is that please keep stringent rules for safety, and therefore what happens in a fire, sir, is that a lot of wrongs also get burnt. You are not able to identify why that fire took place. 27,000 lives lost in 1 year in India. The next highest is somewhere in Russia, which is 3,200. Yes, we are 140 crore people, 135, 140 crore people, but lives are not expendable. And especially with the high rises coming up today, it makes a lot of difference. And sir, again, standardization, we are supplying to a lot of metro railways, to railways around the country. Every separate railway, even within the city, a separate line has got a separate set of specifications. So my request is that let's sit together, let's chalk a way forward, because ultimately, unless and until we as an industry and the government as a concerned portion of the safety and security of the citizens and there to safeguard the cost that we put in, if we do not come together and work hand in hand, we will never get anywhere. So sir, we are willing from our side. Now the ball is in your court to get us in and start playing with us. Thank you very much, sir. We look forward with keen interest to hear from you. Thank you very much.
Thanks, Vijay. Rohit?
Good morning, and I'll try and keep it very short so that we can have enough time for Ghanshyam ji to share his views. Privileged to address all of you. Great to be back in the physical form and meeting everyone in person. It's always much more interesting and insightful if you meet in person. On behalf of IEEMA, a very warm welcome to all my friends and colleagues on the stage and in the audience. A special welcome to Mr. Ghanshyam Prasad. He's been a strong supporter of the industry. He's played multiple roles, seen us from very different angles, and glad to see him take on this new role as chairperson at CA. It's very heartening to see almost 400 plus delegates register for this event. Also, I think the topics that have been chosen for the 2-day conference are very apt. So look forward to some very interesting, insightful discussions and actually key takeaways for us as an industry to build on from there. Cable and wire industry is, like I think Vijay said, almost 35% of our industry, which is a very large portion. And I do see that this industry has a huge potential to grow in the coming years. I think 3 mega trends that are very apparent is, which will drive this growth. One is the acceleration in urbanization and digitalization. Everything that we do today is digital.
and hence electric. The move towards green energy and electricity as the primary source of energy is only going to put more and more emphasis on this industry and this sector for us, including mobility, where a huge new market is getting created with products which will require to be specially catered for the e-mobility type applications from a charging and use perspective. And I think finally for us, the global geopolitics has created a very interesting opportunity and window for us, where we can grow and become globally or take our rightful place in the global markets. I think like Kabraji was saying, we are not even 4% of the global market. There is no reason why we cannot be 15-20% of the global market with the scale that we have in our own domestic market. And I think that has to be our goal. I think the government at the same time over the last few years has taken a lot of steps which are in the right direction. Whether we talk about Make in India and of late this very nicely targeted PLI schemes for encouraging Indian manufacturing. I think these are very, very strong steps to help create an ecosystem where we can scale up our manufacturing. The massive infrastructure initiatives, whether it is the smart cities, new airports, railway electrification, redevelopment, the metros, the Gati Shakti, the housing electrification efforts that have been taken on, I think these are at a scale which we have never seen before, and it's impacting every part of India, which is and creating opportunities for each one of us to participate in this large growth journey that we are on. And I think finally, while we've been talking about this for some time, I think the big efforts or reforms on the improvement of health of the industry. The Minister, Shri R.K. Singh ji, has been talking about this over the last 2 years, and very happy to see some of the steps being taken, whether it's the RDSS or the Electricity Act amendment. Parallelly, the ease of doing business, national single window clearance, which is going to go live very shortly. I think these are very, very good steps. I think even the way the government is negotiating FTAs provide a very good opportunity for us to create a level playing opportunity for us to export and not just be targeted for imports from outside India. So I think some very good fundamentals globally in the economic side, as well as the support from the government. At the same time, I think if we as an industry have to take this opportunity and actually get to our potential, I'll sort of share 3 things that I think will be very important. I think both Kabraji and Vijay have shared on similar lines, but I'll articulate it in my way. One, I think, is this focus on quality. Electricity, 24/7 electricity is no longer a luxury, right? It's a right. All of us have grown up where 8-10 hour power cuts were normal, we lived with it. Today, 1 minute the light goes, the Wi-Fi goes out, everyone is panicking, what's happening to my life, right? So I think quality and reliability of electricity is very, very important. The second and probably an even more important element is safety, as I think both my speakers earlier have said. And I think this is one area where there is a lot of things for us to do, both as an industry as well as the government and the regulatory body. We are still very weak, and if we miss this opportunity, we will miss the opportunity to export, we will miss an opportunity to be a global player. The second aspect, I think, is we have to focus on pushing to grow the pie versus continue to fight in splitting the pie. And that creates a very different industry dynamic. When you're just fighting for share, you end up compromising and you keep going down on quality and compromises that you do in your business. Whereas if you're growing, you have a very different mindset. And as an industry, I think that is one area, especially with the global opportunity that we have to move towards. We cannot focus on just trying to split and compete with each other on things like where we end up compromising on quality. And I think the third element is innovate. It's a theme of the conference too. I think innovate not just on the product, but on the solutions and the services that we offer to our customers and the end users. Half-lives of successful companies have dropped significantly. companies that have that are successful 20, 30 years are a minority today, right? And hence, leaders of tomorrow will be people who will innovate and people who will have interdisciplinary collaboration. You don't have to have all the answers yourself, but how you network with startups, with the younger educational institutes and other parts of the industry is what is going to define whether you will be successful in the future or no. So as leaders of the cables and wire industry, I encourage all of you to lead the way for the industry in these three areas and do hope that Bharat once again regains its rightful position in the global economic landscape. A 15 to 20% share of the global cable and wire industry is something that is within our reach, and we should go and strive for that. So wish you all the best and look forward to hearing from you, Ghanshyamji. Thank you.
Thank you, Rohit. And now for our chief guest, I know, sir, you have juggled your diary quite a bit to be here with us, so thank you so much. Please welcome Mr. Ghanshyam Prasad, Chairperson, CEO.
Very, very warm good morning to everyone. And let me at the outset thank IEEMA for inviting me to this, one of the most important aspects of the industry, particularly the electrical industry. And I has been briefed that it still commands a good amount of share, particularly in the IEEMA sector. But still a long way to go. Could be from 4% what you are targeting to go up to 15%. But I was really thrilled to listen to some of my earlier speakers, Mr. Kubba, Mr. Bijay and Rohit, for giving the heart of the industry, presenting the heart of the industry fearlessly. And what is the truth? Most of the time in such conferences, we do project good things. We try to hide our weaknesses. But good to hear the very first speaker highlighting the weaknesses of the industry. See, we might have done a number of good things in past. Probably that has given you a good rise in your career. But if you really lose the foresight of what you are really going to do forward, probably you are gone. The day you think that you have achieved a lot, probably that's the end of your journey and you will lose the foresight. And the very theme of this conference being innovations, I think innovations never dies. It multiplies and multiplies exponentially. So, I mean, maybe my predecessors or maybe all the good people in the industry earlier, they might have done their bit in their own way. Had we been satisfied that, okay, they are my seniors, they have done whatever they could do it, and I did not take it forward, then probably we are not moving forward, but we are stagnating or coming down. So my first message to you all would be that we need to look forward. Whatever has been done is done, a past, which we call in the industry or in any investment as a sunk cost. So whatever is sunk is sunk. Let's forget about it. Let's think what we should do next, where we should aim at. The good concerns that were being raised is about quality, safety, and other aspects. I think it's not a new topic which we are discussing. Safety had been a concern, quality had been a concern, which I think ever since I joined industry for last 30 years at least, in power sector I had been in for 31 years now. I had been hearing this, even during our college days also, being from electrical background. So I know our professors also used to tell us that, look, from education you will be going to the industries, and industry try to focus on quality and safety aspects of it. This is a continuous process. I'll not say that whatever we have done in safety or in terms of quality, there had been improvements, and every day people are thinking of improvements, and it will continue to be in that direction. But what is more important is how quickly we adopt or we modify our standards. That point is very well taken, Mr. Kuba, and I think we need to work together to realign the standards. And once we have a vision of to be a global leader, you can't be a global leader unless you are the best. No second best, I mean, that compromise cannot be thought of. Unless you be at the top, your standards are at the top level. You have one of the best testing labs in India. If you don't have the good standards or world level standards, probably you will not be able to achieve that. And for that matter, definitely all of us, all the key players, whether it is the testing labs, whether it is the industry, who need to modify their products, who need to think how best they can meet the challenges of the industry, not only in India, but globally. I think that's the key focus which we all of us need to work together. And I'll be more than happy to assist the industry from CA perspective as a policy maker. Of course, my policy exposure is limited. For last few years, I was pushed to policy making side in ministry. And for last roughly 2.5 to 3 years, I had been in the business of making policies. And I can say that whatever best I could do in that front from ministry side, as a general policy for the power sector, the teething problems, the problems with the industry, power industry, I'll say, power sector as such, was facing, we had tried to mitigate most of it, but number of problems are huge. It cannot be mitigated at one go. It has to be done in steps, and that is what we are targeting on. I think last 2.5 years, we had done a number of reforms. Very soon you will find on the ministry's website, we will be linking all the reforms that we had done during the last 5 years, particularly in the power sector. And they will be all linked to the orders and the policies which we have carried out. And most important of it was, these were targeted to improve the power sector industry, to see that how consumers can get 24/7 electricity, how do we reach to each and every consumer of the country. And I think somebody mentioned rightly that we need to now ensure quality 24/7 electricity to all consumers. And that should be our key goal. It had been quite long since we have achieved our independence, and we keep on talking so and so, so and so. Of course, with all mission, we have been able to provide electricity to each and every households. But again, the quality still remains a key concern. And for reaching to the quality, definitely wire, whether it is open wire or a cable or whatever, I think that plays a very, very important role. Losses or reliability of the wire definitely plays a very, very important role in the entire gamut. Coming back to the second aspect of it, what I still feel, please don't worry about the demand aspect of it. Demand will automatically come. And what I see in future, particularly for this particular sector of the industry, particularly cables and wires, since we have a huge target to go, particularly in terms of renewables, if we have to add more than 400 gigawatt of capacity, that will require wires. Going forward, definitely, the wires that will be required at the distribution side of it, because of urbanization, we may not be able to put overhead transmission lines. In that event, we will have no option but to go for underground cables. The second major aspect, if you see from the renewable perspective, I think somebody told about the solar as well, and probably we are not able to meet still the standards what is required for the cables which is supposed to be placed with the solar or wind or any other renewable industry. Since we are going for a very big way in solar industry as well. So what will be required is definitely a huge amount of cables that will go there as well. Another challenging area would be the offshore wind. And the moment we have a very large and huge coastal lines, some study have been conducted only for the Gujarat and Tamil Nadu coast area. We will be very soon moving for some pilot projects for the offshore wind. And anything that we take in the offshore, that will definitely, the power has to be evacuated through the cables. And these cables would be a specialized cables, which probably we have not yet experimented in India. Of course, there are places in the world where such cables have been experimented and they have used undersea cables. We had been planning to connect Sri Lanka with undersea cables long back. So far, we have not yet succeeded because of some reason or the other. But definitely offshore wind, which is inherent to the Indian conditions and inherent to the demand of India, we will be able to do that. We already have some plans in place. If we become successful in this, which we are planning, and I hope that that will become a success, it will get replicated at a much larger pace than what we have thought of just now. So, the quality, safety and the demand, I think if these three things are ensured, definitely I do not see any reason why you cannot go to meeting the requirement of, why to talk about of only 15%, probably you can reach much higher, because the domestic demand itself will go up, and not only the domestic, and if you really improve your quality to the world standards, probably your export potential and export margins will definitely go up. So, with this I wish you all the success, and because the industry is young and growing and dynamic, I would like to see a good innovative products also coming from this particular section of the people. All the best. Thank you so much.
Thank you, sir. I assure you that we will, as industry, do our best. I'd like now request Rohit, our Senior Vice President, to present a memento to the Chief Guest. Okay. Sonal, could you go for the photograph? I want a photograph there, so please be there. Guys, will you take a good photograph, please? Yeah? Thanks. I'm also going to ask Rohit to do the same honors for our industry doyens, Sri Gopal Kabra ji and Vijay Karya. You are family, but you are also industry doyens. Sonal, could you present to Rohit? Sonal will present to Rohit. Thank you. Thank you, people. Thank you so much. While the chief guest has to leave a little early, so he's gone to the exhibition. Mr. Reshu Madan, could you please propose a vote of thanks?
Yeah. Good morning once again to everyone. So just now our chief guest has left, but I wish my extend thanks to him for his presence over here from his busy schedule. And I must mention our deep sense of appreciation for the chief guest of honor, Shri Kabra ji, and also Shri Vijay, Shri Kabra ji, for their illuminating addresses. A big thanks to Mr. Rohit Pathak, Vice President IEEMA, and Ms. Charu for their support, guidance, and all the addresses. We would like to express our gratitude to all the participants, especially Indian utilities, industries, and delegates for accepting our invitation, and to all the co-host organizations who liberally contributed to meet the expense of the conference. Our thanks to all the delegates who gathered in the large number for attending this conference. We assure you we will provide you the value for the money. A special thanks to all our service providers to this conference. We would like to thank to all known and unknown hands that contributed for the success of this program. Last but not the least, I would like to express our deep sense of gratitude to the IEEMA operation team for their hard work in planning and executing this conference. So once again, I thank you all for being here. Wish you a great session and a great day ahead. Thank you very much. Thanks a lot.
Thank you, sir, for this word of thanks. Now we break for tea, and we'll start the session 1 by 12:30 sharp. Thank you. Good afternoon, everyone. After the inaugural session, now we are going to start with our technical paper sessions. So for session number 1, may I call upon the session chairman, Mr. S. Rama Prasad. Mr. S. Rama Prasad did BSc from Bangalore University and a graduate of Institution of Electronics and Telecommunication Engineering, New Delhi. Mr. Prasad has an experience of 36 years in testing and evaluation of low voltage, medium voltage, and high voltage cables and accessories from 1.1 kilovolt to 220 kilovolt, failure analysis of power cable and power cable accessories. He has also been checking the feasibility for carrying out pre-commissioning test for extra high voltage cable network before charging the cable and carried out the pre-commissioning test at the various sites, etc. He had been delivering lectures to engineers working in power cable plants at Malaysia. Mr. Prasad presented 30 technical papers in national and international seminars, workshops, tutorials on power cable and accessories and power capacitor. We welcome you, sir. Now, time for session authors. Mrs. R. Arun Jyoti. Mrs. R. Arun Jyoti, presently working as Joint Director in Cables Lab, Central Power Research Institute, Bangalore. She has graduated in Electrical and Electronics from Bharatiya University during 1997 and Master of Engineering Power System from Bangalore University during 2013. She has an experience of 24 years of in testing, certification and evaluation of cables and special cable sheathing materials such as fire retardant, low smoke and zero halogen material as per relevant international standards. She has about 30 technical papers to her credit in both national and international conferences. Welcome, ma'am. Our next author is Mr. Ramakant Madane. Mr. Ramakant Madane received his Bachelor in Engineering from Instrumentation degree and Masters in Information System Management degree in 2010 from A.C. Patil College of Engineering, Navi Mumbai, and Jamnalal Bajaj Institute of Management from Mumbai University. Currently, he is working in Technical Services, Mumbai, as Group Head in Automation Engineering and Operation and Maintenance at Tata Power and has over 20 years of experience in the field of substation automation, system and SCADA control center. He has vast knowledge and experience in SAS communication, in transmission and distribution, operation and maintenance, and automation engineering. His special interest includes exploring and implementation of new technologies in the field of substation automation, cybersecurity, and business continuity. We welcome you, sir. Our next author is Mr. Ashish Neema. Mr. Ashish Neema is a BE in Electrical Engineering from VNIT Nagpur. Currently, he is working as Assistant Vice President at Adani Electricity Mumbai Limited, Mumbai Distribution. He has an experience of more than 22 years. His expertise includes engineering, product, design, validation, and specification, preparation of high voltage equipment cable and their accessories, technical evaluation of products and services, SCADA operation, SAP process, automation and maintenance strategies, failure analysis of electrical equipment, etc. We welcome you, sir. The final author for today's session is Dr. Nitin Shingne. Dr. Nitin Shingne received his PhD in polymer physics jointly from Max Planck Institute of Microstructure Physics and Martin Luther University, Halle, Germany in 2011. During his PhD, he has worked on ferroelectric polymer nanostructures. Currently, his research activities are focused on electrically insulating material and nanodielectrics. His current area of expertise in electrical insulation material, composite polymer, long rod insulators, cable, and material characterization. He is working on XLPE, epoxy, and silicon rubber nanocomposites. He is also involved in root cause analysis of insulation failure in various products such as composite insulator, cable, and transformers. He has published several papers in peer-reviewed journals and contributed in SIGRE conferences. We welcome you, sir. Now I hand over mic to S. Ramaprasad, sir, to take over the session. Thank you, sir.
Good afternoon to all the delegates. At the outset, I would like to thank IEEMA for selecting me as a chairman for this session. I don't call myself an expert. I can just say I am just a drop in the ocean. Because today I'm going to learn a lot of things from the experienced people. So we are going to have this session. And a small request to the delegates, in case you get a call, mobile call, please go outside and attend the call, because when author is presenting, it gets distracts the author, okay? Now we have got 4 sessions. And for this session, we have got 4 papers. And the first paper is smoke emission of cables and visibility with respect to cable configuration. In fact, this importance of this paper is already spoken in the inaugural session by Mr. Shipal Kabre and Mr. Vijay. So today, if you see, a lot of accidents are taking place, especially fire accidents. If you see, and most important is, it is emanating a lot of smoke. The firefighter is not able to see anything because of smoke emission. That is something which is very, very vital. So today we need to give importance, as it was told, that how to develop some material which is going to be less smoke at the same, less toxic, because many people die by inhaling the toxic gases, not by physical injuries, but inhaling the toxic gases. So we are going to have this paper, which is going to be presented by Madam Arunjyoti. I just call upon the speaker to present this paper, 15 minutes. I'll give a time, after 12 minutes, I'll give a buzzer call, so that I request the speaker to keep and try to give more valid points, so that it will give importance to the subject. And I request all delegates to ask the question answers in the end of this session. Okay, thank you to Madam Arunjyoti.
Thank you, sir. A very good afternoon to one and all. Myself Arunjyoti from CPRI. The topic of my paper is smoke emission of cables and visibility with respect to cable configuration. The special sheathing materials like FRLS and HFFR materials needs assessment for flame retardancy and as well as the emission of smoke before the installation of that particular special type of sheathed cables. Especially when there is an accident, the smoke emission of toxic gases hinders the visibility for the trapped people, and evacuation of the trapped people also becomes difficult because of the dense smoke emission. So smoke emission assessment is an important topic for all the special sheathed cables. And there are different testing methods are there. Some test methods only analyzes the outer sheath, that is material property for the smoke emission is analyzed. There are some other test methods which analyzes the entire cable for its smoke emission. So in this particular entire cable smoke emission, not only the outer sheath material, the other inner components also play an important role in the emission of smoke. So these are all the standards like IEC 61034 BSCN and IS 10810 part 63, which is used to analyze the entire cable for its smoke emission. There is a room-like structure, room-like chamber will be there, like with a dimension of 3 meter, 3 meter, 3 meter. That is 27 meter cube volume. In that, cables of 1 meter length is tested with alcohol as a fuel. So how much the light is being obscured by the emission of smoke, that will give the smoke density of that particular cable. So smoke density is assessed by means of obscuration of light. So here the test duration is like 40 minutes is the test duration. So and the property which we need to look for is the minimum transmittance during the entire 40 minutes of the duration of the test. So the requirement is 60% is the minimum transmittance. Now there is recently there is a revision in the standard like IEC 61034. There is a revision in the standard. They have introduced the concept of normalization. The observed minimum transmittance is normalized, so that unacceptable value or which is not acceptable, that value is converted to the acceptable limit. Normalization process is introduced. That process I am going to discuss. Like in this particular standard, the number of cables are selected depending upon the diameter of the cable. So earlier in the previous version, when the cable diameter is above 80 mm, then only the normalization process is applied, and the multiplication factor is D by 80. So the observed minimum transmittance will be multiplied by the D by 80. That normalized value will be considered for the compliance. But now, as per the recent standard, the normalization formula given is IT by I naught, that is IT is the final transmitted transmittance and I naught is incident transmittance. That is normalized by the multiplying factor of 40 by ND in the power. So this is applicable now for the diameter above 20 mm. It is applicable for all the cables tested as per IEC 61034 for the diameter of above 20 mm. So whatever minimum transmittance we are observing, that has to be normalized using this formula, and that value will be considered for the compliance determination. Here N is the number of cables and D is the diameter of the cable. Just I have considered artificially some different diameters of the cables, and by considering the minimum transmittance may vary from 0 to 100%. The graph is plotted how the normalization affecting the observed minimum transmittance value. So when you see here, when the diameter lies between 20 to 40 mm, the graph whichever it follows, it's similar that of 2 times that of the diameter. That is diameter of 21 mm and 42 mm, the graph will be the similar one. Because the formula is ND by 40, number of cables for the diameter 20 to 40 mm is 2 cables, and for 10 to 20 it is 3 numbers, and greater than 40 mm is the number of cable 1 meter will be tested. Number of cable 1 meter, each length is of like 1 meter only. So when you see the graph, when the diameter keeps on increasing, the normalization is also increasing the observed transmittance value. When you see for the 100 mm diameter, the observed value, actual observed value is of 20% transmittance. However, the normalized transmittance goes up to 53%. And the normalization is in such a way it is formulated, when the observed transmittance is above 90%, it is not affecting the actual observed transmittance to that extent. Maybe it may go to 92, 93, only to that extent only it will be changing. So this is as per IEC only, from the incident light transmittance and as well as the transmitted light transmittance, we can calculate so many derived parameters, like that is smoke extinction coefficient, optical density, then extinction area of smoke, visibility. All these parameters can be calculated using the dimension of the chamber and as well as the incident and transmitted light transmittance observed during the particular test. So when we, for various transmittance from 0 to 100%, the extinction coefficient is calculated using the formula, and this is the graph which shows the extinction coefficient, which is inversely proportional to the transmittance. So when the transmittance comes down, the extinction coefficient will be keep on increasing. They both are inversely proportional, and visibility is also inversely proportional to the optical smoke density. So visibility, there is a formula like visibility equal to 1 by D naught, that is optical smoke density. So when you calculate this visibility versus transmittance, when the transmittance increases, visibility is in terms of meter, the visibility also increases. So considering 60% as the limit value, we will be having 13.5 meter visibility for any person to escape from the particular fire accident. Like these are all the results for the smoke density test of power cables having the diameter of more than 40 mm. Like here, first two, when the diameter is of 41 mm, the minimum transmittance and the normalized transmittance, there is not much change. From 95 to 95.5 only, the normalization increased the minimum transmittance. But when the diameter increases for 57 mm, the minimum transmittance, like from 48 to 60, almost 60, the normalization has increased the minimum observed transmittance. But when the observed transmittance is of 90 and 94, the normalization is not much affecting the observed transmittance, like it has gone to up to 95 only. This is, then the smoke extinction coefficient, optical density, and extinction area of smoke, all are proportional to each other, and they are inversely proportional to transmittance. So when the smoke increases, these optical density and smoke extinction area will be keep on increasing, and the visibility will be coming down. Next, this table shows the results of 20 to 40 mm. Here also normalization is applicable. And when you see the same way, like when the transmittance is above 90%, the normalization is not changing the observed transmittance much. But for other 10 to 90%, when the observed transmittance is there, it is changing the observed transmittance. So finally, we are going to consider the normalized value for compliance determination. This is the table shows the 10 to 20 mm. Here there is no normalization, only the observed values are given in the table for various cables. Like all the three tables values are plotted against transmittance, the smoke area and visibility. So when the transmittance keeps on increasing, the smoke area is coming down. Smoke area is coming down and the visibility is keep on increasing with respect to transmittance. And transmittance is more, the visibility is also more. Like coming to comparison of IS and IEC standard, there is a difference in the selection of number of cables. And as per IS, there is no selection for less than 10 diameter. That cable selection is still under consideration only. So this particular test, when we are doing for as per IES, it is applicable for the cables of diameter above 10 mm only. And there is no normalization formula is also introduced in the IS standard. Like in IS 694 also, the smoke density is applicable only for outer sheath, not for the complete cable, and it is performed as per IS 13360 standard. But however, coming to IS 17048 for HFFR cables, the smoke density method given as per this particular standard is the entire cable. But here also, the number of cable selection is not available when the cable is of less than 10 mm for HFFR cables. Here the minimum requirement as per IS 17048 is 70% for HFFR cables. In the similar way, like IS 1554 part 1 and 7098 part 1, the smoke density test method is given as per IS 10810 part 63, but however the requirement is still not given in the standard. Requirements are still under consideration. So when we do the type test, this as per IS 1554 and 7098 part 1, without doing the smoke density, we are giving the type test certificate for FRless cables. Because requirements still it is under consideration. Requirements are not given. So IS 10810 needs amendment in respect to the number of cable selection for less than 10 mm diameter cable, and as well as the normalization process for the cables of diameter greater than 20 mm. This is the final conclusion. IS needs the revision in terms of normalization and as well as the number of cable selection for even less than 10 mm diameter cables also. And any one of the smoke density methods, either that outer sheath method or the complete cable, needs to be introduced for the other standards, type test standards like IS 1554 part 1 and part 2. And recently it has been introduced for IS 7098 part 2. Amendment has come only for the outer sheath, that smoke density property is assessed. That's all. Thank you, sir. Thanks. I would like to thank the organizer IEEMA also for giving me such a wonderful opportunity to present my paper. Thank you.
Thank you, Madam Ranjyoti. It was a good presentation. So we are going to have a second paper, which is the title of the paper is Monitoring of Transmission EHA Cables Using Distributed Acoustic Sensing Systems. The paper is being presented by Mr. Ramkant Madani. So in addition to what is if you see in only EHA cables, we have normally, they have the route markers. So we need to incorporate the route marking even for medium voltage cables. So we are going to have a presentation by Mr. Ramkant Madani. Please.
It's on.
Yeah.
Thank you, sir. Thank you for the introduction. Good afternoon, everyone. Myself, Ramakant Madne from Tata Power. As an author, there are different authors included in this. So I am from automation team, and along with them, we had co-authors from different backgrounds. For example, we had from engineering, cable team, and communication, which is a major topic of our project. To start with, as you all know, there are different challenges faced by utilities, which is not only applicable to power utilities, but other utilities in terms of telecommunication, oil and gas. So what challenges we face in terms of petroling, because we have around 1200 kilometers of overhead section, and plus we also have 200 square kilometers, circuit kilometers of cables, which are scattered across Mumbai area. And especially when we talk about Mumbai, there is a lot of underground cable because of the non-availability of the right of way. So when we talk about Mumbai, especially the South Mumbai part, all the EHV cables, right from 220 to 110 kV, those are laid underground, which provides a lot of challenges from utilities perspective in terms of availability of the and the reliability of the power supply. The first monitoring part becomes very difficult in terms of encroachment or any digging or drilling activity being taking place, especially with this metro project in process. It has created a lot of challenges, which has forced us to go for some innovative solution. And it also encourages us to optimize the cost in terms of petroling. Although the petroling activity is a mandatory activity from any utility point of view regarding the asset standardization or maintaining the assets, but there are from that point of view we need to take some measures. So these are some measures which are taken in-house. So when that this is regarding the petrolmen who take care of this application. So there are different applications developed by in-house by our team, taking the advantage of Office 365, where we are using the BI applications for tracking. That application is given or it is a part of the mobile, where the operator or the petrolman goes there and he takes around all the readings as a scheduled activity. Apart from that, there are QR codes, especially out of this 200 circuit kilometer cables, 30% of are oil filled cables in the span of 220 and 110 kV. So in that case, there are oil pressure monitoring is to be done by the petrolman on daily basis. So through this QR code, we do that kind of application where it enables the petrolman to go there and get the readings on daily basis. And these are all standalone methods, and there are ceiling points wherein the overhead to underground cable sections are there, where actually the line overhead lines becomes a cable. So those are the only points where we can have a CCTV interference available, where we can monitor the ceiling points only. And apart from this, as I said, oil filled cables requires monitoring. So for that, current provision we have it in terms of analog parameters, where we are monitoring the this pressure, oil pressure, for any leakages through a transmitter, and wherever it is not possible, then there are binary inputs being monitored through the pressure switches. So the previous things, whatever I said, it was all based on the standalone system, where we are not getting the real-time view of the cables to 220 kV and 110 kV if we talk about. So for that, real-time application was a need of from our application, considering the reliability aspect from Tata Power point of view. And also, having said that, monitoring also was available, the need of the monitoring part also, that it should provide proactive alarms. So that also was missing. So we had a solution called distributed acoustic sensing, wherein it's an innovative technology wherein we have an advantage of using this optical cable along with the overhead, along with the underground cables. We also lay these fiber optic cables, which is used for different applications, right from the protection, communication, and other SCADA applications. So what we do, this DAS system detects the vibration and measures the acoustic energy of a core. So the core represents any defect in that particular cable. So what does DAS acoustic sensing, distributed acoustic sensing means? It has an interrogator which normally sends a pulse, and that pulse detects the vibration, and those vibrations, based on the nonlinearity of the cables, it provides refractive index. Thus refractive index is getting captured in the interrogator as a feedback, and then based on that feedback, some complex detection and classification algorithms are carried out in the interrogator unit, and those are then passed on to a unit where it provides a user interface for the system for the operator to take action. And basically it operates on a simple philosophy of coherent optical time domain reflectivity, where it utilizes Rayleigh scattering, allowing acoustic frequency signals to be detected. These are some potential impact of DAS, which, as I said, this patrolling has significantly improved, and we have reduced the cost of patrolling. Also, it provides safety aspects also, which is normally embedded as a part of Tata Power philosophy. In terms of excavation being carried out, there had been instances in the past wherein while digging there were some flashovers. So this aspect also is being taken care through proactive monitoring of these cables. And apart from that, it also provides a lot of data, wherein that data can be used prior and post facto analysis of any cable. For example, normal digging process can be identified through this. Even excavation part also can be identified, but fault becomes a major part. So based on these triggers which are taking place as a part of the system, we can carry out the post facto and pre facto analysis, and based on that we can take the necessary decision. And the best factor is it does not require any sensor, because the fiber optic cable itself is used as a sensor. So as a part of our implementation in South Mumbai especially, we have covered around there are two sections covered, one is shown under red and other is under green. So we are currently implemented around 10 kilometers out of this 34 kilometers, and the red section is to be scheduled. So currently out of 34, we have implemented successfully around 10 kilometers of the system where it is being monitored, or under which there are 3 circuits, cable circuits are being monitored. And the same things can be implemented at other places also. We have DAS for cables. We also have the DAS for transmission lines, wherein it also monitors the interference in the transmission line network, because we have a transmission lines scattered right from Raigad districts, wherein our generating stations are there. So from there, it is passing through different terrain. So from that point of view, it becomes very difficult to monitor, because patrolling is not possible there. So in same line, it can be replicated for the same thing, and we have done that. So this is in short how that mimic looks. The interrogator comprises of this mimics, wherein there are 3 mimics involved. On the top, you can see the map is projected. It shows the map, so wherein we can map the assets, whatever cable joint box are there, or in case of overhead line, the transmission lines, we can map it on this particular. And based on the scattering, or based on the defect, it shows the intensity of the location, and it is also evident on the waterfall diagram, which is at the bottom. And it also provides seamless integration in terms of what I said, asset views. We get an asset view, closer asset view of all the assets, whatever we have mapped. Then the best feature is that it provides a real-time monitoring through SCADA interface. Data handling storage I have already dealt with. So this is in short a schematic of what we have implemented. There are 3 circuits: Kopoli, Kopoli 1, Kopoli 2, Amarnath, which are basically the overhead line sections, wherein the detector part is done. And apart from this, 10-kilometer line, what I said, circuits, it is underground monitoring. That is also integrated to a common interface, so that we have a visibility of the entire station, right from overhead transmission line and underground cable, whichever is taken in service. So this in short a small video where we normally capture the signatures for pinpointing that particular location. Either it can, this is an excavation wherein, if you can see the diagram which I showed, these are all the simulation activities, because it requires lot of simulation to capture the actual refraction index and the actual pinpointing actual location, which can be then replicated on the map. So this is one of the example of this excavation. Similarly, if you see mechanical digging part, the location, you come to know the exact location based on this man is just trying to have that simulation of the digging near the joint box of the cable, and which is getting displayed through this intensity of that, and same it is available on the waterfall diagram at the bottom. These are some rationales of the project. The investment is around 2 crore. For each interrogator supports around, depends upon the requirement. So we have gone for 50 kilometer interrogator, 2 channel interrogator. So one channel supports 50 kilometer. So the investment is around 2 crore. And there is an annual cost, saving cost of around 21.6 lakhs for the petroling aspect, which we told. And lastly, there is this utilization of the existing fiber. We did not have to invest in any other additional requirement. We had used our own cable network. So to conclude, normal conventional practices of monitoring and control of these assets, underground cables, petroling aspects can be more streamlined by real-time monitoring of this cable part through implementation of the distributed acoustic sensing. Thank you, thanks all.
15 minutes. Actually, this presentation was so apt, because actually it was complete and just in 12 minutes, because the timer was just showing 12 minutes. Now we are going to change it to 15 minutes. So the paper was very good. Actually, this simulates, the presentation was very good, and it also simulated the actual vibrations that was actually seen in this, in the actual site. So next paper is on design, installation, condition experience of 11 kV hybrid cables. I'm just talking about some 40 years back. Probably Mr. Yogendra Tiwari knows. EHA cables, they used to remove one armor, put a fiber optic cable. But the biggest challenge was in case a cable damaged, the fiber optic cable used to get damaged. Then they started incorporating a fiber optic cable inside a conduit pipe, and that was put just over the cable. So this paper is going to be presented by Mr. Ashish Nema, and we are going to have the presentation in 15 minutes. We will give it bell after 12 minutes. Yes, you can start.
Good afternoon, everyone over here. I am going to share my experience of design considerations and installation and commissioning experience that we have gained in deploying fiber embedded HT cables in our network. This study has been done jointly with Mr. Sachin Nallavade, who is from KEC RPG. Mrs. KEC RPG has supplied us, designed and supplied the cable to us, and they have also assisted in termination and jointing activities. The flow of presentation would be as follows. Starting from introduction, we will brief upon the design of the cables and accessories and the site identification process, then the field challenges that have been faced during cable laying, jointing and termination activity, and finally the learnings from the presentation. I'll focus more on the field inputs. So this is the introduction, where AEML is Adani Electricity Mumbai Limited is engaged in generation, transmission and distribution of power supply of electricity. AEML Mumbai distribution spreads from in an area of around 400 square kilometer, with serving around 3 million customers through its HT and LT cable network of 4,700 kilometers and 18,000 kilometers. KEC International is a leading manufacturer of power and telecommunication cable with a manufacturing capacity as per the statistics given.
Please skip the company, please.
Okay.
Sorry.
Briefing about AEML network, power is received at 33 kV level or 22 kV level at large power stations called distribution substations, and at 11 kV and the power is fed to the smaller substations called consumer substations, which is located near the load. We have around 118 numbers of distribution substations, large substations, and around 8,000 numbers of the consumer substations. All the distribution substations and 50% of the consumer substations are connected through centralized control center for operation and monitoring purpose. For fiber optic cable network, which is laid underground, is the backbone of communication of distribution substation. The left one over here, just one. This one, and the challenge that is faced in laying the fiber optic cable is the huge infusion of capex and opex charges. This is required for operating and maintaining the network. Similarly, the consumer substations are also connected to centralized control center, but the mode of transmission is through GPRS via SIM based network. The challenge faced in operating this communication substation automation is signal drop issues in GPRS, which is wireless. So, our management, AML management, has decided and asked us to explore the possibility of embedding the fiber optic cable inside the power cable, so that it can be laid between the consumer substations and distribution substations, and all the remote operations can be taken on fiber optic network. So, engineering department has worked on that, and they jointly with KEC, they have partnered, and this kind of design of cable has come, in which the fiber is embedded between the cores of power cores of this cable as one of the fillers, and the entire cable is jacketed with SDP outer sheath as well as inner sheath. The project was commissioned in March 2022. This is the construction of the cable, as you can see, where the fiber is embedded over here. As per manufacturer, the challenges that has been faced is in placing the fiber optic cable between the cores, as they have to take care, and the multiple trials only they can pinpoint the exact location of the fiber optic cable, so that it will not get damaged. They have also studied the thermal and magnetic effect on the fiber optic cable when the cable is operating at full load, and concluded that the temperature which is reached at the filler position is around 60 degrees centigrade. So, they have chosen the optical fiber cable in that manner, which is suitable for the operating temperature. There was no electromagnetic interference have been concluded. Now, the hybrid joint and termination design, this joint is similar to a conventional power cable joint, except one change, that the branch of clip has been introduced at the point where the fiber optic cable emanates from, shoots out from the cable for the formation of joint. The termination is a 4-finger breakout instead of 3-finger breakout for a 3-core cable. Site identification method, the site identification has to be done in such a way that cable should start from a substation which already has a fiber network in it, and which is communicating to control center through fiber. So, we have selected a distribution substation and laid 2 sections of 550 meters and 650 meters respectively. Some challenges have been faced in laying the cable. I will share you one by one. There was no specific challenge due to the presence of fiber optic cable in power cable. However, HDP outer sheath, which we have introduced, had a mixed performance. Earlier we have been using PVC, now this time, first time we have introduced HDP in HT cable. Following are the properties of HDP, which has favored or not favored during cable laying or cable gap bending process. First is coefficient of friction, which is 1.6 times less than that of PVC. This is suitable for this property is suitable for pulling the cables in the ducts, but however, the same property creates an issue when there is a manual intervention of the laborers to handle the cable, to lift the cable, and to put it inside the trench after the cable has been unreeled on the ground. Then second is flex modulus. The flex modulus decides the force required to bend the cable. Basically, the flex modulus of HDP is very high, as represented in red over here, and the flex modulus of PVC is represented in green, which is low. So, bending has certain challenges. Then abrasion resistance property, the shore hardness property of the HDPE decides the abrasion resistance property of HDPE. It basically also decides the scratch resistance and the termite resistance properties. So both these properties have favored in laying as well as in long term performance, it will do good for us. Now density of this cable with HDPE sheet, density of polyethylene is 1.5 times less than that of PVC, which has reduced the overall weight of the cable. Second, coming to hybrid cable jointing. Sorry. When fiber optic cable is procured separately, it comes in a cable reel of 1 kilometer. That 1 kilometer cable can be laid from one substation to another substation without introduction of a joint. However, when it comes embedded in the form of an embedded within the power cable, then the length is restricted by the length of the HT cable. In AEML, we use an HT cable of length 300 meter in one drum, and when the cable when laid between the substations requires jointing process in power cable. Similarly, the joints for optical fiber cables are also introduced because it is embedded fiber design now, and average distance of substations is around 500 to 800 meters, and therefore 1 to 2 number of joints, fiber joints comes in between each section. So more the number of joints, the lower is the signal quality. That is, everybody knows, as the joint introduces 2 dB of losses, one joint of fiber optic introduces 2 dB of losses in the system. Secondly, as per the conventional practice, whenever a fiber optic joint is made, some part of the fiber optic cable is extended beyond the joint portion and laid in the form of a loop inside the chamber, which is openable and it is for future maintenance. So following the same convention over here, around 6 meters of fiber optic cable has to be removed from the cable course. So once you are removing the fiber optic cable from the cable course, you are actually wasting the power core. And 6 meters of power has around 4.7 meter has been wasted, and remaining 1.3 meter have been utilized for jointing process. Now, as these both the joints are kept as close to each other as possible to reduce the wastage of power cable basically. So here when you are keeping it so close, both the jointers cannot work together. So only after preparation of power cable jointing of fiber optic cable has been undertaken, which has increased the overall commissioning time by 3 hours. Coming next to hybrid cable termination, we have already explained the property of HDPE, which created issues in bending, and with the present design of cable trenches as per IS 1855, which is suitable for actually PVC sheet cable, that's what we found. And for HDPE cable, we have to increase the depth of the trenches to affect the bending of the cable. When the power cable is terminated, this is an RMU inside the consumer substations. Power cable is terminated in this cable box, and the FRTU is placed at a certain distance from the cable box. So the laying length between this cable box and the FRTU switch is around 7 meters, which means that you have to expose again 7 meters of fiber optic cable, and there is a wastage of around 6 meters and a cable preparation time of 20 minutes involved in it. And also you have to take the fiber optic cable out of this cable box to put it into the switch, which again requires a retrofitting of the cable box RMU enclosure. That is again retrofitting means weakening the enclosure basically. And this wastage of 6 meters over here and timing of 20 meters increases when the substation size increases, and because this is a bigger distribution substation wherein the power cable is terminated over here and the RTU room is placed somewhere else, means around 25 meters from this position. So this wastage is increased. In repair process in future, this is a requirement of the future. Whenever there is a fault in the power cable, hybrid cable, then you will need to dig the cable trench, a pit. You have to form a pit for it. Basically, this pit length is 8 meters in conventional cable, and the jointing repair time is 4 hours. But when it is a case of hybrid power cable, the calculated excavated length is around 14 meters, and the joint repair time increases by 3 hours due to requirement of non-simultaneous preparation of both the joints. So there will be an overall increase in RI charges of 54,000 per fault. The wastage of cable 6 meters, and one fault repair means introduction of 2 number of optical fiber joints, which leads to signal losses. Summarizing the field experience, poor grip in HDP, this can be addressed through usage of proper tools while manual cable pulling. Reduced ease of bending of HDP can be addressed in multiple ways, like redesigning the trench for higher depth in future cases, raising the RME installation height in conventional substations wherever possible. Basically, it's not possible everywhere. Then changing the design of the cable outer sheath. We are conducting a pilot with a double outer sheath cable, in which the inner one is PVC and the outer one is HDPE. Wherever there is a critical bending issue, then that HDPE would be removed and only PVC will be utilized till the termination or wherever the critical bending is there. So that is a pilot, that is in a pilot stage basically. Then there is an appeal to BIS to revise the IS 1255 guideline, which is talking about only insulation of the cable and the bending radius. It is not talking about integrated cable, which consists of armor as well as the outer sheath material. Then the wastage of cable, as explained, and additional time for cable preparation is an inherent requirement of this process. Then there is an increase in the process time of jointing. This is also a process requirement with a hybrid cable. Then threefold increase in the number of joints. It leads to poor signal quality. We should try to increase the drum length as far as possible with such kind of cables. Whenever the utility tries to experience these kind of cables in their system, distribution system, and DTS will have a restriction of distance between power cable and fiber optic cable, so accurate sensing will be limited. No provision of optical fiber routing from the switchgear cable box is a design change in the switchgear. Conclusion, conclusion is in 2 parts, basically usage of HDP, which AEML is going ahead. There is a need for revision in IS 1255 guideline, and the deployment plan is for AEML is like for new substations with the revised trench depth, and for the legacy substation will continue with PVC sheath till the new design is explored. For fiber optic embedded power cable, it's a good design for implementing the cable diagnostics such as DTS and DAS. However, the usage is beneficial for large projects and for utilities. Actually, this design needs to be reviewed again for addressing the challenges as explained. So AEML is currently reviewing its decision on expanding the network with hybrid cable. Thank you.
XLP nano composites for XLP cable system. This paper is going to be presented by Dr. Nitin Shinghane from ERDA. Please.
Yeah, thank you. Good afternoon, everyone. My name is Nitin Shinghane, and I am from ERDA. I am going to present this paper on synthesis and development of XLP nano composite for HV cable insulation. We know that polymer nanocomposites are expected to play an important role in advanced electrical insulation. So the first question comes, what is the nanocomposite and how it plays a role in improving the properties of insulating material? Now, just a minute. I want it. Okay. I wanted a pointer here. It's okay. So if I consider a polymer matrix, we are for nanocomposite preparation, we are adding some nanoparticles, and these nanoparticles, yeah, that's fine. So these nanoparticles have large surface area compared to microparticles normally which we add, and due to this large surface area, you are selecting these particular nanoparticles. They interact with your polymer matrix, and this interaction leads to a interphase layer. This interphase layer is few nanometers thick, and this layer has different properties. They have different polymer chain conformation, different mobility, and different rigidity. Therefore, the properties of this interface are different than the bulk polymer, and you are changing the properties of this composite due to this interfacial effects. So the interface plays an important role in this nanocomposite preparation, and to prepare, to go forward with this nanocomposite preparation, we choose XLPs as it is used widely in electrical insulation. And it is expected that this nanocomposite can improve the dielectric properties, dielectric strength, PD resistance, and water tree resistance growth. So to first prepare the nanocomposite, we synthesize the XLP in our laboratory. You know that XLP is a thermoset polymer. So the polymeric chains are interlinked with covalent bonds, and it is a three-dimensional structure. When you heat it, it will not melt, it will stay stable, and therefore it is using, due to these thermal properties, it is widely used for this cable insulation. So if you heat it, it is stable, and whenever there is a fault occurs, the stability is not reduced, and insulation is provided in the cable. So the preparation starts with the thermoplastic LDP. Normally LDP, if you heat it up, it will start flowing around 80 degrees Celsius. So these polymeric chains of thermoplastic material can slide over each other, therefore they can flow. To prepare this thermoset, we added peroxides and antioxidants, and due to this cross-linking reaction, the covalent bonds are formed between these different chains, and 3D structures forms in these thermoset materials. And this compounding is taking place in a twin screw extruder, and finally this compound is taken out and cured in a hydraulic press at elevated temperature. Now this is the second step of preparing XLP nanocomposite. The nanocomposite particle we use has a large surface area. It has about surface area of 370 to 420 meters square per gram. Now, to give you a context, what is the surface area is and how large it is. If you consider a typical 2 BHK or 3 BHK flat in Indian society, you say it is around 1,000 square foot, and it is roughly around 100 square meters. So the carpet area I'm talking about. So 400 meters square is a huge surface area due to the nano-size particles. Now, this surface area is important for improving the properties of your nanocomposite, but this also creates problem for preparation of this nanocomposite, because large surface area is not energetically stable. Nature always wants to go towards lower energy, and therefore these nanoparticles always like to come to each other, and they agglomerate, and separating them and distributing them in a good in a polymer matrix is a difficult task. If they agglomerate, the properties of your nanocomposites are going to decrease, and instead of improving the properties, you will have lower dielectric strength or mechanical properties. So going toward this good dispersion stage is most important task in preparation of nanocomposite materials. So, and second thing I have already discussed is about interface. Interface plays a role giving the final properties. So, interaction between these nanoparticles and your matrix is important. So, you have to select the nanoparticles accordingly. And second task is, so how do you achieve this, both the properties dispersion and second is interaction between them, the polymeric matrix and the nanoparticles, so the interface is good. The first is we modified the nanoparticles with chemical groups. So these chemical groups aid in the dispersion as well as they form a bonding with the polymeric matrix to improve the interface. And for dispersion, you have to add lot of energy to disperse these nanoparticles in polymeric matrix. So we have used intermeshing twin screw extruder to disperse this nanoparticle in the XLP. So initially we prepared this compound with LDP and then the cross-linking and nanoparticles were added, they were dispersed, and then the additional peroxide cross-linking agents were added to finally obtain the XLP compound after curing it at elevated temperatures. So we prepared 3 types of samples. One is pure XLP, no particles were added in that. And second is XLP nanocomposite. These nanoparticles were not chemically treated, so they are bare nanoparticles. And third is surface functionalized XLP nanocomposite, where these nanoparticles were chemically treated for better interaction with XLP compound. Now, if I prepared XLP, how do I know that it is XLP and it is not a thermoplastic? So there is a gel content method to analyze how much percentage of XLP is actually cross-linked, right? So I take a small sample near about 1 gram and put it here in a thimble, and there is a solvent here. Normally it is xylene because polyethylene dissolves in xylene at elevated temperature, so it is heated up, it vaporizes and the drops are dropping on the polymeric material. So whatever uncured portion is there in the nanocomposite, it will get dissolved in xylene and it will come back. So after 8 hours of this process, if it is not cross-linked, for example in thermoplastic, LDP, it is all gone. But in XLP, after 8 hours, if you can see, it is stable because it has a 3-dimensional network and it is swelling in the solvent. So our polymer is cross-linked, and if I compare the gel content, pure XLP, what we prepared in the lab has a gel content of 80%. Compared to the gel content of maximum we got is around 90% for surface functionalized nanoparticles. Then we analyze the thermal properties. This is a DSC melting temperature of base LDP, and this is for XLP and XLP with surface functionalized nanocomposite. The melting temperature is little bit distributed because the polymer crystals cannot grow in large size due to cross-linking of the polymeric chains compared to LDP. And thermal degradation temperature was analyzed using TGA, which is little bit improved in XLP with nanoparticles. Thermal conductivity is also an important part of electrical insulation because low thermal conductivity results in bad dissipation of heat. Heat accumulates, and the power you can transfer through this insulation, it gives the limitations. If you can improve the thermal conductivity of electrically insulating material, it is better for the insulation. So when we analyze this thermal conductivity with this MTPS-based sensor, we observe that the thermal conductivity is improving in XLP with this surface functionalized nanoparticle. Near about 18% of thermal conductivity was improved in these nanoparticles. Dielectric strength is the next properties. As you can see, the pure XLP has around 20-21 kV per mm, and it is improved in the XLP with surface functionalized nanocomposite, and it is reduced when the functionalization of this nanoparticle was not done. That means the poor interface is playing a role here. Next is dielectric dissipation. This result was also surprising for me. Lower tan delta is better for insulating material. Normally, if I consider a nanocomposite material, when we are adding nanoparticles, the interface layer normally immobilizes the surface charges, and therefore, in nanocomposite material, the tan delta is decreasing compared to in comparison to the microparticles if you are adding. But in this case, there is a sharp increase in tan delta for this XLP nanocomposite. And the reasons may be there are problems in sample preparation, poor interface may have played a role, or there is also a increasing polarization in XLP due to these functionalized nanoparticles. So when we are functionalizing these nanoparticles, we are adding some additional groups, and they are giving some additional polarity to the sample. And therefore, this tan delta is sharply increased in XLP with surface functionalized nanocomposite compared to the base XLP. Therefore, the second part was that if there are agglomerates and if they are playing also a role, and we analyzed the sample using SEM, and we found some large agglomerates of nanoparticles in this SEM image, and this can also play a role in increasing the tan delta of the material. So I will come to the conclusion. We have prepared the XLP nanocomposite and showed that the gel content is better than the base XLP composite. Some properties are improved, like thermal degradation, temperature, thermal conductivity, and dielectric strength. But the challenges are also with tan delta, which showed a large increase in nanocomposites. So if we want to overcome this problem, we have to work. There are these challenges we have to work. We have to modify some chemistry, and hopefully we can have better tan delta also if some modifications are done in this nanocomposite preparation. Thank you to all.
Thank you, Dr. Nitin Shinde. So, though we have the fifth paper given in the booklet, the fifth paper is not being presented. The fifth paper was PVC voice and conductor class. I came to know that it is not being presented. So, we have 4 papers in the first session. So, the first session, in the first paper was smoke emission of cables and visibility with respect to cable configuration. I would just like to sum up the 4 papers. So, this paper, it gives test methods for smoke density, and the test to be revised, and it needs to be amended. So in line with IEC 61034-2, which is called the measurement of smoke density of cables being under different conditions, we need to amend this standard. So that we try to take care, because as it was told in the morning session, a lot of cables are failing, especially due to fire resistance, due to fire. So we need to develop some new materials which will retard the fire. Coming to paper 2, that is monitoring of transmission of EHV cable using distribution acoustic sensing systems. That was presented very well. And we have, I have seen some places today for EHV cables 220 kV, they use IoT. They fix IoT sensors so that from sitting on the laptop, we can see where exactly the cable routing. So this will help in the route tracing easily. We can try to do it very easily. So we can have the contact system, the infrared system that can be incorporated. So we have to, as it was told that one joint creates 2 dB losses, no? That is what. That was in that system. So now coming to the third paper was design, installation, commissioning, experience of 11 kV hybrid cable systems. So here we have, this is incorporates a fiber optic cable embedded in a cable. So practically, as he explained, the different challenges that was faced by incorporating this type of fiber optic cables. But what we need to do is, not only we do the installation commissioning, that we forget about it, but we forget the condition monitoring. Today, if you see condition monitoring is the last subject, many people don't bother. So let us take example, let us say, normally we use a condition monitoring using what type of tests we have normally. Today we have high voltage DC test for medium voltage cables. There are many contractors, they follow the procedure of doing high voltage DC test. But high voltage DC test is not to be incorporated to be carried out for XLP cables. Well, IS 1255, that is code of practice for cables up to 33 kV, clearly specifies that we have to do HVDC test for the cables. But that standard needs to be updated, because what happens, there was a case which I came to know, for 66 kV cable, it was route length was more than about, I think, 10 kilometers. They applied 50 kV DC for 15 minutes. After that, disconnected, they charged 11 system, 66 kV cable, 66 kV. They found lot of flaws. As they were charging the cable, now multiple flaws were there. So we need make sure, why I'm trying to say again, this is, in this podium, I just want to make a very clear comment that please do not carry out high voltage DC test for XLP cables. Okay, this has been removed in IEC 60840, that is cable rating more than 30 kV up to 150 kV, and even IEC 62067 more than 150 up to 500 kV has been removed. But still IS 1255 follows this. Then people will ask, where is the solution? We have a solution, IEC 6050 part 2. Very clearly, see, if you see class number 20.2.2, installation test, page 43, 44 gives very clearly. He gives 4 options. Either you do a line voltage 15 minutes, or you apply U0 for 24 hours. That means it's called soak test you apply. The option may not be available, power supply may not be available. The next option is you can do VLF testing, 3 U0 for 15 minutes, you can do this test. Or the standard also gives one more option, you do 4 U0 DC test for 15 minutes. But standard IEC very clearly gives that when you do a high voltage DC test, you are reducing the life of the cable. You are trying to kill a healthy cable. So that is to be avoided. So we need to make sure that no HVDC test to be carried out on HVDC cables. Why? The reason being, as many of you know, that it is due to space charge accumulation. How long do we earth the cable after doing the HVDC test? Can anybody answer? How long do you need to earth the cable after doing the HVDC test? Any answers from the experts? 1 hour. Anybody else? We are talking about high voltage DC test we are carried out, we have to discharge it. How long do you discharge it? Okay. We need to, yeah. Yeah? Yeah, thanks you. I really appreciate you, because why? People just charge and discharge and take it out. That's the space charge accumulation. We need to do lot of, you need to discharge really that space charge. We need to discharge it for 24 hours. Then you say, what is the thumb rule? The thumb rule is actually, if you see IEEE 400.2, 2013, there's a table. If you see, there's a table 4, which gives table 4. In that IEEE standard 400.2/2013, table 4, it gives a historical figure of merit for condition assessment of service aged PE-based cables, that is polyethylene, XLP and TR-XLP using VLF system. It clearly says what you should do. If the tan delta is this much, what is that you should do? If tan delta is more, what is that? It clearly gives a good data. So why I'm trying to say this is, many times I come across a lot of people Because they say I have to follow the procedure. They do a high voltage DC test and then forget about documentation is done. Afterwards the cable fails. So please try to see that we don't do high voltage DC test for especially XLP cables. Okay. Then the next thing is there was a mention that IS 1255 to be we need to revise the standard because the standard is only up to 33 kV. We need to revise the standard, at least give an amendment. Of course, if somebody, I think Madam Meena is representing BS committee. I just want to make a recommendation. Please, we have to make sure, at least try to make sure, give an amendment, see that from the standard, remove the high voltage DC test from the standard. Because many people say, I got a document, it very clearly says that we have to follow HVDC test. Please do see that that amendment is given so that the DC test is removed from the standard. One more thing which I want to make a mention is, let's say we have got some guests in the night, and suddenly the power supply goes off. So what do we do? We need to call an electrician. Can I ask you one question? How many of you have got engineering stethoscope, multimeter in the house? Really? Please raise your hands. Yeah, good, thank you. Why I'm asking this question is, we even know with CPRI, we are doing the pre-commissioning test CPRI, they are doing it pre-commissioning test for all cables above 6 kV, where one simple parameter, multimeter, it gives a parameter called capacitance. The capacitance, it will be more in case the cable absorbs moisture, because permittivity XLP is 2.3, while permittivity water is 72. So once the capacitance increases, that is indicated by a simple multimeter. So just a simple methodology we can try to incorporate by checking now and then when you do the maintenance of the cable, even 1.1 kV you can try to measure using a multimeter. Okay. Next, coming to the paper 4, that is synthesis development of XLP and nanocomposites for HV cable insulation. So we need to develop a new material. But today if you see, we got big challenge, ABC cables. ABC cables has got outer sheet is polyethylene, which is UV resistance. But if you try to use PVC, it is not UV resistance, but is fire resistance. We need to develop a material. Why I'm trying to mention this in the forum is a lot of manufacturers are there. They need to develop new material, not only develop material, incorporate in the standard IS 5831. Because unless only then you can use it for manufacturing, so the standard needs to be upgraded. So I just want to make a mention and I think we come to the any question answers session now. We can start from session 1, any question answers. How much time we have? I think, yeah.
Hi.
We can have question session, yeah.
My name is Bishwanath Bhattacharya and I have a question for Mr.
Paper 1, can we start from paper 1?
No, it's paper 2.
Paper 2, okay, just 1 minute, please. Any questions? Yeah, please.
Yeah, my name is Mustafa Khan. I'm from Siemens Limited. The question is for paper 1 regarding the fire performance for rolling stock cables, because we have very large rolling stock tenders coming in the railway domain. And for the fire performance, we don't see a lot of maturity in the cables especially for rolling stock domain, where we have HL1, HL2 levels, hazardous level 1 and 2, because rolling stock is always a moving commodity. So any research or anything that has been done, especially regarding the fire performance for rolling stock cables?
No, we have not done any tests for rolling stock cables. I don't know whether any specification is available for that. I don't have any idea about it.
Fair enough. Okay.
So you go to paper 2. Yeah, please.
Hi. This is meant for Mr. Madane. Yeah. I understand like you have implemented a DAS system for your 110 to 20 kV. Does this network also have a DTS there?
We do have that DTS system implemented.
So you have two separate systems, one for DTS and DAS. Right. Any specific reason for that when the market offers an integrated system?
No, actually we are planning to have that integration along with DTS also.
No, I'm saying like when the market offers a controller in an integrated manner with a DTS and a DAS put in a single box, why you opted to go for separates, like a separate DTS and a separate, any specific reasons?
No, there was no specific reason. Actually, it started with the initiation of the technologies we need to implement it. So as long as we were going along with the implementation, so initially it was thought that we'll cover short distance because DTS requires some additional multi-mode cabling, separate cabling is required.
No. DTS can also run on SM.
So what we have done, the implemented project at Tata Power, we have laid a separate multi-mode cable for the DTS application.
So you have two separate cables, one multi-mode, one single mode.
Yeah, that is only for, means it is not covering the entire geography. We have we have just covered only around 8 to 9 kilometers for DTS.
And what is your experience on the false alarms?
Regarding?
The DAS.
No, actually, frankly speaking, initially it creates a problem because it requires lots of simulation. So unless and until that simulations are done and shared across the OEM for carrying out the required fine tuning of the parameters, it provides some false alarms. That is for sure.
So after the initial stabilization period, the false alarms is almost zero.
Right.
That's a good experience.
Actually, the entire activity takes around 2 to 3 months, wherein we actually handhold with the OEMs and then get it simulated for the entire patch. Including the mapping of the whatever overhead lines or cables. And based on that, we get an idea. Means how much part. As you might have seen in the video that there were even during the excavation activities, there were cars passing around the nearby highway only. So that gives a clear idea about how much fine tuning we need to give.
Yeah, I fully agree with you. If I may ask, can I ask one question to Mr. Nema? It was a great experience to see that 11 kV experimentation. And there you have a DTS system, am I right?
No, it is in transmission actually. We are representing.
You are having a 11 kV cable.
11. It is there in 220 kV cable.
Okay, but you are not integrating the DAS DTS on that fiber which you have already incorporated.
See, we have recently commissioned and we have a plan to take experimental.
This third party digging is the menace for the 11 kV circuits more in terms of, I think that's one part.
Right. It is
and
more.
Have you done any cost benefit analysis? Like you talked about the negatives, like the challenges, but the benefits part of it.
The benefit is like I have explained, the CAPEX.
No, in terms of cost, like.
In terms of cost, the CAPEX expenditure, which is separately done for fiber optic link, will not be there in our case.
But any comparative data, like the benefits in terms of values and.
Means the CAPEX expenditure of 9,500 per kilometer. That's what I have written in the specific this presentation also.
But that doesn't suffice for the losses, no? The number of the length of cables that you are wasting, the space requirement and other points that you narrated. But is it advantages are more or disadvantages are more?
See, this cost comparison will come when the practicality of laying the cable comes in the forefront. Means basically we have to make it more practical to be laid in the network. Like distance is a constraint. Longer the distance, then we can think of going about this. Like in projects I have said, where there is a measured length, we can directly procure that measured length and lay it between the switch gears. We can lay the section. So joint is avoided. Once you introduce a joint, then the practicality is.
It
you
adds
cannot
so
go
many challenges with
down the line. You cannot go up beyond 1 or 2 sections. Third, fourth section, you may start experiencing.
But it's a very novel way, I think.
I think you can deliberate during lunch session. Sorry. Okay. Any questions?
Good afternoon. My name is Hemant Keti from Zycon International. Question to Mr. Nima. Have you not thought of going in single core cables instead of using a 3-core cable and embedding it into it? You could possibly have taken a longer length of probably 1 kilometer, 2 kilometer as well. The CSE, I think, to my knowledge, has used a single core circuits, and they have been beneficial to them in the. So you could possibly have a 3 single cores together along with this, and you could lay the cable along with it.
we can think about it. Actually, I can reply it to you later on, but currently, as per the convention, we are using 3-core cables for the ease of means operators. This is the conventional method of laying. We have never gone for long distances in single core at this voltage level.
You can try maybe.
Yeah. Okay.
Hello. I have one question for Tata Power.
Good afternoon. I'm Yogendra Tiwari from Universal Cables, and my question is from Mr. Madane. Mr. Madane, thank you for your nice presentation. I have just a simple question. In your DAS system, what is the distance at which some mechanical activity is happening, and this DAS system will sense?
The coverage of the DAS system.
Coverage of real system. Suppose, I mean, along vertical clearance from the cable route. So what is the distance up to which this DAS system?
I mean, you are talking about any excavation activities going on, how much coverage it can?
Yeah, correct.
It is around 5 to 10 meters. Within that, we get that simulation done, and we can get that signature captured. So that does happen.
And this DAS system does not include any PD measurement and all?
No. Currently
it is just for any mechanical activity happening?
Mechanical activity, excavation activity. Electrical faults, actually, we have tried simulating on the, but it is restricted to only overhead cables. Cable, still EHV cable failure rates as such are not much. So as long as that faults happens, so at that time we can have that signatures available during fault pinpointing, and then that can be incorporated. It is a open loop system. So every time whenever you want to do any addition, new, suppose if you are laying a new cable, which is the limit actually is of 50 kilometers. Up to 50 kilometers, you can expand. You can use an interrogator, which is used for the sensing.
So what do you do? Suppose some activity is happening, you get alarm. What do? You send your team to stop them, or what do you do?
Actually, this has a SCADA interface availability. The feature, whatever interrogator is having, it has got a feature of reporting into the SCADA system. And we have a centralized monitoring system. SCADA system is being monitored at the centralized location. All all generating stations, all transmission receiving stations are monitoring from a single point of location. We call it as a power system control center. So the moment that alarm gets generated, the concerned person at the power system control center, the operator, he informs depending upon the fault. If it is for transmission, it is maintained by the transmission team, and if it is for cable team, it is diverted to the cable team. Accordingly, there is a provision for the individual stakeholders to view that at their own office also through client communication.
So means, I mean, basically this activity has to physically stop. Somebody has to rush to that spot where this activity is happening.
But currently, based on the patrolling, the frequency of the patrolling, and there are some limitation of patrolling, because of which there are certain faults which are happening post patrolling. Patrolman has visited.
I think we can have interaction. Last question, I think. Yeah, sorry, we are running out of time. This is the last question for this session.
Myself, Rajni Pandey from KEC International. Sir, this question is for Tata Power. Is it monitoring hotspot in this with the DA system?
No. Basically, DA system is just acoustic based. For hotspot, what sir said, we are using a DTS system.
Okay.
So it is not covered under DA system.
So you are thinking of that for?
Yeah, means there is a we are going for we are planning for this integrated approach. What sir said, having this DTS and DS in a single interrogator. That is surely in our pipeline.
Yeah. Okay. Thank you.
Thank you.
I think we have no more questions. We will hand over to IEEMA, please. Thank you so much. Very interactive questions from the audience. Thank you so much.
Thank you, sir. After a wonderful session with comprising of smoke emission cables and telling about the standards part as well, and a lot of discussions happen on nanocomposite of HV cables. Now may I take this opportunity that S. Rama Prasad sir can hand over a memento to all the dignitaries and the members available. Please. May I now request Mr. Manjeet Sethi to please come on stage and hand over a token of gratitude to S. Rama Prasad, sir. Can we please assemble after the table for a group photograph, please? Thank you. Now we'll break for lunch. We request OC and TC members and the session chairs to please move forward to Alamgir Hall. And the delegates are requested to take their lunch here itself in this hall and the Roshnara Hall. Thank you. We'll meet at 2:30 p.m. Thank you. Good afternoon, everyone. Let's settle down. May we request all the delegates to please take their seats so that we may proceed to session number 2. Now may I call upon Mr. Dr. Anil Khopkar. Dr. Anil Khopkar received his MS in Electrical Engineering from University of Vadodara. Currently, he is working as Head of Division High Voltage Laboratory at Electrical Research and Development Association. He has more than 27 years of experience. Dr. Khopkar has presented 18 technical papers in national, international journal and conferences. He is having wide experience of testing of electrical products like transformer, cable, current transformers, potential transformers, bushing, capacitors, insulators, and switchgears, etc. We welcome you, sir. Our session author is Mr. P.C. Gururani. Mr. P.C. Gururani presently working as GM Technical at Universal Cables Limited, Satna, and having an experience of more than 26 years. Prior to that, Mr. Gururani worked with LS Cables and System India as Head Design, Development and Quality Assurance. Mr. Gururani is having a vast experience for high voltage and extra high voltage cable design, development and quality assurance. He is providing complete turnkey solutions for extra high voltage cable system as per project and site requirement. Mr. Gururani has published and presented papers in national and international seminars and workshops. We welcome you, sir. The next author for the session number 2 is Mr. Ashwani Kumar Jain. Mr. Ashwani Kumar Jain is an Assistant Vice President at Adani Electricity Mumbai Limited, heading the Equipment Diagnostic Cell. Mr. Jain has earned a Bachelor in Engineering degree in Electrical from CTAE Udaipur and did PD Diploma in Thermal Power Plant Engineering from NPTI Nagpur. Mr. Jain is certified Six Sigma Black Belt with IMS Lead Auditor. He has worked in HT Industrial Metering and Product Engineering. Earlier and since January 2020 has been taking care of equipment diagnostic function at Adani Electricity Mumbai Limited. Mr. Jain is responsible for maintenance planning, failure analysis and introducing new diagnostic practice. We welcome you, sir. The next author is Mrs. K.P. Meena. Mrs. K.P. Meena presently working as Joint Director and Head of the Department in Cable and Diagnostics Division, Central Power Research Institute, Bangalore. She has received her degree in Electrical Engineering from University of Kerala in 1989 and Master of Engineering Power System from Madurai Kamarajar University in 1991. She joined CPRI in 1992 and working in the field of power cable technology for the past 30 years. Her experiences involve testing and evaluation of power cable and system of voltage rating from 1.1 kilovolt up to 400 kilovolt rating. Partial discharge measurement on current transformers, insulators, and surge arresters. Her area of interest in high voltage insulation and evaluation techniques. She has about 30 technical papers to her credit in both national and international conferences. We welcome you, ma'am. The next author for this session is Ms. Mithila Ethagani. Mrs. Mithila Ethagani received a master's degree in Power System Engineering in 2021 from Sardar Vallabhbhai National Institute of Technology and a bachelor's degree in Electrical and Electronics Engineering in 2018 from Andhra University. Currently, she is working in design and NPD team of KC International Limited Cable Division. And the final author for this particular session is Mr. Zander. Mr. Zander Parik is the Application Marketing Manager for Broge Energy Products in Asia South region. He is an alumni of the University of Georgia, the Netherlands, and completed a postgraduate program at the Bocconi University in Italy. Moreover, he is a member of Sigre community in Malaysia. Prior to Broge, Zander worked for Prismian Group and process engineer and regional sales manager in the Netherlands, Italy, and Dubai. We welcome you all the authors and the session chairman. Handing over to Dr. Khopkar. Thank you.
Thank you. And good afternoon, ladies and gentlemen.
I once again welcome you to 9th International Conference on Cable, Wire and Accessories. Particularly, this is the after lunch session. But I am sure that authors and our session, we will keep the session live so that you will not feel little sleepy. So let us begin the session 2. In this session, total 5 technical paper would be presented over here. And time allotted is 1 hour 15 minutes, so almost 75 minutes is given to us. So I request all the authors to present their paper within 14 to 15 minutes time, so that we will have a reasonable time at the end for the question and answer session. Let us begin with the first paper. The first paper is from Universal Cables Limited, which is titled as Smooth Aluminum Sheath Innovative Trends in EHV Cable. Authors of this paper are Mr. Yogendra S. Tiwari, Mr. C. S. Mohanty, and Mr. P. C. Guru Rani. This paper describes about use of smooth aluminum sheath in the manufacturing of EHV cable, manufacturing process and benefits of smooth aluminum sheath, technical comparison of corrugated aluminum sheath and smooth aluminum sheath with product validation is discussed in detail in this technical paper. This paper will be presented by Mr. P. C. Guru Rani from Universal Cables Limited. So I request Mr. P. C. Guru Rani to present his paper. Over to Mr. P. C. Guru Rani.
Good afternoon, all of you. Myself, P.C. Gorani from Universal Cables. I especially thanks to IEEMA to give me the opportunity to present the very interesting paper. The title of the paper is Smooth Aluminum Sheath, Innovative Trend in EHV Cable. In the first slide, we'll discuss about the smooth aluminum sheath introduction, type of metallic sheath, aluminum sheath current practice and need to innovation, smooth aluminum sheath manufacturing process, analysis of current rating of corrugated aluminum sheath versus smooth aluminum sheath, benefit of smooth aluminum sheath, and finally the summary. So first we will discuss about the metallic sheath. EHV cable are mostly XLP insulated cable. It is globally accepted practice of having a radial water barrier in EHV cable for long service performance. Metallic sheath are provided as radial water barrier. Metallic sheath also act as a metallic screen to drain the capacitive charging current and the path for earth fault current. So here we will discuss about the kind of metallic sheath. This first one is lead sheath type cable, and this one is corrugated aluminum sheet type, and this third one is polyol laminated sheet type cable. Aluminum sheet, basically in our Indian market or in our country, this corrugated aluminum sheet is widely used. So current practice of aluminum sheet is corrugated aluminum sheet. Corrugated aluminum sheet is an effective radial water barrier, and its good mechanical properties, but it has some limitation, like its higher diameter of cable. Due to that, the delivery length is shorter and large bending radius is required. So corrugated aluminum sheet having some wavy finish. If you see here, this is corrugated aluminum sheet type cable, and below one is shown as smooth aluminum sheet type cable. So we have shown here typical sketch of corrugated aluminum sheet and a smooth aluminum sheet. if you see this is the corrugated aluminum sheet type. And here we have shown smooth aluminum sheet. So basic difference, if you see here, only the height of the corrugation. And if you make the cable smooth type, so then we can cut down this overall diameter by 10 to 15 mm. If the diameter goes down, then the delivery length will be large and the weight will be less, and this we can transport more delivery length, so transportation is also easier. Now, in this slide, we'll discuss about this manufacturing process of the smooth aluminum sheet. Aluminum sheet, making the smooth aluminum sheet, basically aluminum sheet and the PE sheet is done in tandem process. The two sketch diagrams shown below, a firm bonding is ensured between metallic sheet and the PE sheet with use of the suitable adhesive material in between that. And for making this smooth aluminum sheet, some forming rollers are required for the sizing of the cable diameter as well as making the cable circular, and there should not be any kind of wrinkles in this cable. So this arrangement is especially required for making the smooth aluminum sheet. Now discuss about the manufacturing process. Here we have shown seamless smooth aluminum sheet process as well as seam welded type. In case of seamless type, the aluminum extrusion is required. Here this aluminum rod, and this is the cable core, insulated core, and that goes to up to this aluminum extrusion. And here is the, after this aluminum extrusion, this one arrangement is here. That is the forming arrangement, so that the cable will be circular before this dual extrusion. So here dual extrusion is required. One is the adhesive layer. That adhesive layer bond between this aluminum sheath as well as the PE sheath. And after that, finally this cable goes to the take-up. So by the naked eye, we can see that after making the cable, the PE sheathing, if there should not be any kind of wrinkles or any kind of deformation in this cable, so we can say that this cable will be perfectly we have made. So second sketch diagram of the seam welded type. Mostly, I think in India, this smooth seam welded type arrangement is here. So in this case, here is the aluminum tape, and this is the cable core, and this arrangement is coming here and making the cable circular, and after that the dual extrusion, and finally the cable made and goes through the take-up stand. So these are this basic requirement of making the smooth aluminum sheath. One is the adhesive layer is required, and the second one is the forming roller. Only if these two kind of arrangement we can add in our cables, our manufacturing process, we can make the smooth aluminum sheet type cable. Now the comparison between smooth aluminum sheet cable and the corrugated aluminum sheet cable. Here we have taken this 2500 square mm Millikan conductor and 220 kV grade cable, and this insulation thickness taken similar for both as per the norms of IC 27 millimeter, and aluminum sheet thickness also taken the similar 2.3 millimeter, and outer jagged thickness also taken 4 millimeter, same for both the cable. So if you see here, the diameter of the corrugated aluminum sheath is 152 millimeter. And in case of this smooth aluminum sheath, this is 139 millimeter. So difference between the diameter is 13 millimeter. And also the cable weight is 36.5 kg per meter, and corrugated smooth aluminum sheath 36 kg per meter. So 0.5 kg, this weight is also goes down. So third one important thing is the bending radius. So here is required 3 meter barrel diameter of the drum in case of corrugated aluminum sheet type, but in case of smooth aluminum sheet type, this is only 2.8 millimeter. So you can say that this cable we can deliver more length as well as less weight and easy for the transportation. So this is the special test required for the smooth aluminum sheath. As per IEC 62067, the important test is bending test, and this new IEC 62067 2022 version, this requirement is 20 D plus D. Small capital D is the overall diameter and the small d is the conductor diameter. Second one is the resistance of the cable sheath for mechanical impact test as per prescribed in IEC TR 61901. So after this test, there should not be any kind of deformation in the cable. Third one is important longitudinal water penetration test as per IEC 62067. So in case of corrugated aluminum sheath type, the requirement is same for this longitudinal water penetration, but in case of this smooth aluminum sheath type, result is much better in comparison of the corrugated aluminum sheath type. And finally, this adhesion test, that is called peel stain test as per the IEC 62067. In new IEC 2022 version, there will be requirement is especially mentioned is there. So here we will the 200 mm long and 10 meter wide piece cut up to the metallic sheath, and that fix in the jaw of the tensile machine and then do the tensile test, and that value should not be less than 1.5 Newton per meter. That also specified in the IEC 62067. And finally, the current carrying capacity. The current carrying capacity compare with this same cable cross-section area 2500 square mm. We have taken installation condition, air temperature 40, ground temperature 30 degree, thermal resistivity 1.5, depth of line laying 1.5, and in case of flat formation, the axial spacing between the phases is 2D, and a single and oblique cross bonding. So if you see here, this is the red one is the smooth aluminum sheet type, and this is the blue one is the corrugated aluminum sheet type. In case of trefoil ground, the current 960 ampere, and in case of smooth aluminum, this is 965. Similarly, in flat ground, this is 1275 and 1300, trefoil layer 1830 and 1850. So we can say that the current is also increased by approximately 1% in case of smooth aluminum sheet. And last one, this comparison of short circuit current carrying capacity. Short circuit current capacity also better in case of this smooth aluminum sheet type when we will consider by the non-adiabatic method. And finally, benefit of the smooth aluminum sheath over corrugated aluminum sheath. Smooth aluminum sheath cable has a smaller diameter, consequently we can deliver more length, and smooth aluminum sheath cable having lighter in weight, easy in handling, reduced cost of transportation. Smooth aluminum sheath cable having improved cable circularity with in case of smooth aluminum sheath, and in case of this corrugated aluminum sheath, this is the heavy in shape, so that pulling is easier in case of smooth aluminum sheath type because of the outer surface, outer diameter is very circular and smooth. So possibility of reduction number of joint in case of smooth aluminum sheet type, because we can consider more length, so we can cut down the number of joint. So the overall system will be healthy, and we can say system is more reliable. And easy installation due to reduced bending radius. So bending radius less, so in case of sharp bending, this smooth aluminum sheet is much better. So also the better corrosion resistant, because the sheath firm bonding between aluminum and the PE. So this is the corrosion resistance is much better in case of smooth aluminum sheet type. Finally, what we have discussed in the summary, that smooth aluminum sheath is much better because the current carrying capacity increase. Mechanical property also we can say that increase because of the firm bonding between aluminum sheath and the PE jacket. And also delivery length we can consider more. So finally, in this forum we request to the utilities and this electricity board and EPC to just consider this aluminum sheet in their specification, so that we can serve our country better and our system will be more reliable. So thank you very much.
Thank you, sir. Very much timely presented. We will have the question and answer at the end of all the 5 papers. So let us move to the second paper, which is from Adani Electricity Mumbai Limited, Mumbai. The title of the paper is Evolution of Transition Joint Components Using Different Techniques and AEML Experience and Methodology. Author of these papers are Mr. Ashwini Kumar Jain and Ms. Hemanta Chandure. In this paper, field experience of transition joint between PILC and XLPE joint, cable joint, with its methodology, practical constraint in type testing of transition joint is discussed. Investigation of material property of 311 kV transition joints of different make of these joints is carried out, which is also discussed in this in detail in this technical paper. Based on the study findings, required revision in the specification is represented in this technical paper. This paper will be presented by Mr. Ashwini Kumar Jain from Adani Electricity Mumbai Limited. Over to Mr. Jain.
Yeah, ladies and gentlemen, very good afternoon. It's always been a pleasure and privilege to come in forums, this kind of forum. And as sir has already told about what is my topic. So before I start the presentation, I would like to know if you guys can raise your hand, how many are from the power utility? Yeah, so good number. So guys, I'm your man. I'm here to represent you. So I'm from the Adani Electricity. This is a vertically integrated company. Those who don't know what kind of joints we use in power utility, so this is just a glimpse. So there are XLP straight joints wherein both sides there's a XLP cable and different sizes you join. And then there are transition joints wherein PILC and XLP cables you join. These are the difficult joints, and these are the challenges which we are presenting through this case study. And obviously there are some legacy network wherein PILC straight joints you have to make. Just as this is a pictorial view, you can see different layers, different components are being used in XLP as well as in the PILC joints. These are the main joint function. So most of us, those from power utility as well as from the manufacturers, they know what is the function of different component and what are their properties as per the different IEC and IS standards. So coming to the transition joints, the PILC XLP transition joint, what are the issues that is being faced by different utilities like AEML, I think some part is there in CSC also. So it requires the jointer expertise. You see jointers, those are very well conversant with the XLP jointing. They are not able to put these joints in field because there are many other components, many other processes, those are required. Then there's a possibility to damage PILC cable joints. So these PILC cables, you can say it is like a aged member of my electrical network. You touch it and it gives a problem. The third one is the time taken in jointing. So since there are multiple components and different kind of processes that need to be followed, so there's a lot of time, more than an hour and half an hour, so that is as compared to the XLP jointing. Then obviously there are quality issues of the component. So we are taking joints from OEMs, but certain components, those are outsourced. So sometimes we do face these kind of problem wherein from the local manufacturers, they are not able to maintain the quality. Then adherence to legacy design. So the design that we have been following, it's been, I would say, for more than 15, 20 years. We try to change it. We have tried to use different tubes, shear bolt connector, but there are issues related to cost as well as while putting the joints in the field. And shorter service life, obviously. So because of the heterogeneous insulation, interfacial field distribution vary, and the stresses are developed over the boundaries, and this is having the shorter service life. So I would say 95% of joint failures in AEMLD are these transition joints. So what are the practice that we follow for joint design validation? So obviously vendor pre-qualification, only OEMs are permitted. We don't allow the traders to come and offer the joints. Then field trials. So anytime a new OEM is coming, so it's not like that we are taking directly the joints. We are putting that to field test. About a year or so, we observe how's the behavior, then only the design is approved. Then the type testing. So yes, only type tested designs are taken. Those who were not able to offer type tested design during the tendering, so we gave them a permission that, okay, you come with your type tested design when your supply would be initiated. Then witnessing of type testing. So our people are going with OEM teams and they are witnessing test in CPRI, ERD or wherever that type testing is being done. So checks and balance, even post-order, quality assurance plan is there for each and every joint, every kind of joint. We are doing this, as well as the store and inspection also. Every component is tested and checked. So these are the relevant standards and the incongruities. So you see there are 3 standards mainly which we follow for straight joint as well as the transition joint. So IS 13705, this is for transition joint. It is quite an old standard. So this is putting some stringent requirement as compared to polymeric joints. Then there is IEC 60055 for the paper insulated metal sheathed cables and the relevant accessories. So there is one mismatch that for a transition joint in IS it is specified there should be 120 numbers of thermal load cycles, while in IEC they are saying okay 63 thermal cycles okay. So we have taken this issue many times with BIS as well as with CPRI. I believe through this forum again we would be highlighting and it would be taken appropriately. And obviously it's for XLP joint, it is IS 13573 part 2. And these are the component testing that's been as per the table, as per the clause 6, IS 13573 part 2. So joint type testing. So what I expect when the joint is type tested, I would say that the design is perfect for the field installation and everything, creep page, HV withstand, etc. Sealing arrangement is okay. It would last long. Laboratory aging testing versus field performances are sync. When I have tested the type tested design, I have taken it. So it would be held good in the field as well as once the type tested design is there. So there would not be a change in the BOQ frequently. But obviously expectations are different from what we experience. So what we have seen, even type tested joints fail in field due to less design margin for external factors. OEM, they design it as per the offshore condition and they are not conversant with the field issues in India being a tropical country. And the second one, even when we are putting these joints in field, so there are frequent BOQ revisions, just as OEMs are not able to understand what are the field challenges. So when we were doing the type testing of transition joint, we faced these challenges. So first one was a fresh PLC cable. Now nobody is manufacturing. So how we did it, how we mitigated the challenge that from the field, we extracted out a piece of PLC cable, good PLC cable, we tested, and then we put it for the type testing. Then different cable sizes from loop requirement, what IS 13705, it says the XLP size has to be one size lower, but in our system, the XLP size is one size higher. So it's 120, 240 square mm PLC, then it is the 300 square mm XLP. Then challenges in design validation as per the site condition. So you see in Mumbai, the water table is quite there, so water ingresses everywhere, as well as there are minerals, different minerals, there are frequent disturbances which are affecting the cables and joints. And reluctance of vendors, so people are coming to us, you have limited PLC cable with you, why you are again putting a stress on type testing. So we say to them, boss, whatever that comes to our system that need to be type tested, so you have to go for it. So at a time, even we have seen, even some of the OEMs, they have refused that they will not do the type testing. Then the validation of joint design instead of component properties. So I would cover rather in detail in the next slides. So this is our approach. So as we see that the conventional type testing, it is the conformance of joint design and the whole component as well as the behavior, but the factors that are there in field, people are not able to factor in. So let it be the temperature, the water, the minerals, or the external excavation. So we have taken following steps. So identification of jointing components for evaluation of properties. So for our transition joint, some special components like oil barrier tubes, stress control tube is, yes, there with the other joints as well as. So we have identified for which jointing components we need to do the special testing, then the identification of suitable technical standard. So we have chosen ESI 09-2013, which is quite elaborative, and it puts more clarity on the component performance. And then the selection of reputed institute for conducting the measurements. So we have taken help from IIT Roper. I think Dr. Reddy is not there. So he's been quite supportive in this complete exercise. So what are the salient points of this joint evaluation study that we have done? So measurement of relative permittivity at different temperature. These are the tests that otherwise were not available in the conventional type testing. And electric field up to 10 kV per mm and duration of thermal aging for OBT. So, and compliance of measurement results with the relevant standards and the defined values, as well as the simulation of the electric field and resultant field distribution and the interfacial charge estimation. So there are test procedure, sample preparation that is as per ESI 09-2013, as well as the applicable ASTM standards. So we discussed and finalized with IIT Roper, and then we went ahead. So what were the findings and the interpretations? So permittivity and loss tangent measurement. So we did this for 3 OEMs, those approved OEMs for their component, different component like insulating tube, stress control tube, oil barrier tube, and the fresh sample as well as the aged sample. The aged sample, the aging is done at 120-degree continuous for 500 hours. Then we measured the permittivity and the loss tangent. So you would see that 2 of the OEM oil barrier tubes, they came up with some issues. One sample did not withstand the test itself. And the findings that we saw that lower permittivity lead to higher field enhancement, whereas higher loss tangent leads to higher dielectric loss. So increase in temperature and field enhancement. So these kind of conditions, those we are encountering in the field installation also. So based on that, 2 OEMs, deterioration in OBT tubes were observed during measurement itself, post-aging. The other parameter that we did a evaluation of volume resistivity as per ASTM D257. And again, we have seen that for 2 of the OEMs, there were issues post-aging. And decrease in volume resistivity implies increase in conductivity, which leads to increase in dielectric loss. This is an important parameter that need to be observed in field also. So this is kind of insight that we have got from it. This is another finding related to the permittivity characteristic. So this is related to the negative as well as the positive temperature coefficient. So with temperature and the field, how the permittivity is varying. So as the temperature is rising, even the permittivity is coming down, and because of which the electrical stresses are getting bigger and bigger over the interface boundaries. So one desirable OBT would be the one with the positive temperature coefficient of permittivity. That is the insight that we have got from this test. So peak electric field in joint for seasonal temperature variations. So obviously this is a kind of validation that we have put into, and for all three OEMs we have observed. So as the ambient temperatures are rising, the peak electric stress across the interfaces, even it is on the rise. So at 45 degree even you can see what is the peak electric field that is appearing over there. So this is even the space charge simulation that we have done. So we have created the 2 electrodes, and a sample is put for paper as well as the oil barrier tube. So for OEM 1 you can see there's a big spike, so it represents that that interface is encountering a major stress, and because of which the deterioration is happening quite fast. And we have seen in field also that these OEM 1 joints, they are aging fast and they are filling fast. So conclusion and forward path, the composition of OBT oil barrier tubes to be chosen in a way that it has the positive temperature coefficient and high degree of cross-linking, not only for OBT, for all kind of tubes that is required, and obviously thickness of OBT as well as other tubes that need to be optimized, and OBT material to have optimum permittivity. We have discussed, we have taken the finding with the OEMs also. We had a great discussion with them, and some of the OEMs, they are ready to change the specification as well. So just a point to take forward with all the other utilities, guys, don't just rely on the type testing. You can have your own kind of validation. You can devise your own strategy to test the joint performance. And that would be a better proposition for your joint performance and the field performance. This is all. Thank you from my side. Thank you very much.
Thank you, sir. Once again, presentation within the time. So let us move on the third paper. This paper is from Central Power Research Institute, CPRI, Bangalore. Title of the paper is Effect of Improper Grounding on Integrity of 66 kV Cable System. Authors of this paper are Ms. K.P. Meena, Mr. Thirumurthy, Ms. R. Arun Jyoti, Mr. G.K. Raja, and Mr. P.V. Satish Kumar. In this paper, failure analysis of a middle point bonded 66 kV cable system with simulation study and analysis is presented in detail. This paper will be presented by Ms. K.P. Meena from Central Power Research Institute, Bangalore. Over to Madam.
Thank you, sir. First of all, I thank IEEMA for organizing such a nice conference and giving an opportunity to present this paper. Actually, it is based upon one failure analysis carried out on a 66 kV bonded system. Some salient features or some issues noticed with the bonded cable system, we try to bring it out in this paper. Okay, about the metallic sheath design, actually already our earlier presentation by PC Gurrani has given a nice presentation about the metallic sheath. But still, actually, to have a continuity, I am just starting with that metallic sheath design. Actually, as you know, the design of a metallic sheath plays a very important role in the reliability. Reliability is a function, the basic function of grounding as well as fault current carrying capacity. Everything is provided by the metallic sheath. The design of the metallic sheath plays a very important aspect in the case of a 66 kV cable and above. It's a part of the design. And various designs, various types of sheath used is that lead alloy sheath, polyaluminium laminate sheath, longitudinally applied plain aluminium sheath, corrugated aluminium sheath, and as already he was describing about the plain aluminium sheath. Different types of designs are presently available for the metallic sheath of the cable. And as we know, actually 66 kV cable and above are generally designed with the single core cables. Just recently Tata Power, some utilities have started utilizing 3-core power cables to reduce the sheath losses, but generally it is of single core cable. And in our case, actually the failure analysis was carried out for a single core 66 kV corrugated aluminium sheath cable. And as you know that the main function of the metallic sheath is for the mechanical protection of the cable from the moisture entry, and in addition it gives a the proper grounding of a cable. Actually it is very much mandatory to have equal stress distribution within the insulation. Grounding is a very important aspect for any high voltage equipment to have proper distribution of electrical stress. The metallic sheath, whether it is grounded only at one point or multiple points, the grounding has to be proper so that the stress distribution in the cable insulation will be proper. And here in this case, and why that in addition, actually I wanted to bring it out why the bonding is needed also, because this particular case the cable failure has noticed in a middle point bonded XCC cable system. And why bonding is adopted is actually, as you know, it is the cable for a power cable. Current rating is decided by the losses occurring in the insulation. Okay, when the losses are very high, but actually the current rating, that capacity of the cable also will come down. And the major losses, as you know, is the conductor losses, dielectric loss, as well as the sheath losses. And conductor loss, I square R, we cannot change anything. Dielectric loss also, V square omega acetal, we cannot change anything. The only losses which is in our control is the sheath losses. Why the sheath losses occurring is due to the induction. That when conductor is carrying current, it generates a magnetic field. That magnetic field induces voltages onto the metallic screen, and that induced voltages, if there is a closed path in the circuit, it circulates a circulating current through the sheath, which is causing sheath losses. But the only way to reduce the losses is to reduce sheath losses. Up to the medium voltage cable, the current generally 3-core cables are used, or single core cable, the current rating is also, the current rating may be higher, but in that case most of the time we use both sides, we ground it, there will be sheath circulating current, but accordingly we will reduce the ampacity. But where in the case of 66 kV and above, when you use single core cables, we have to adopt some type of bonding system. That is, we have to interrupt the grounding at the point so that there will not be any closed circuit. To reduce that sheath losses, the bonding techniques are adopted in the case of single core HV cables. That is basically to reduce basically there will not be any circulating current through the sheath, and there is no sheath losses. And this actually, this also, it is just to have an idea what are the different metallic sheath designs available with its general advantages and disadvantages. Based upon your application side, you have to select what type of the sheath it is required for you. Like the polyaluminum sheath cable, that one, what are the factors to be considered is whether how well it is controlling. If you are laying a cable in a water line area, again the longitudinal water penetration of moisture also an important factor to see whether how watertight that cable design is, that one. And again about the earth fault current carrying, your short circuit level is high, the short circuit carrying capacity is also very important. That way, depending upon the application side, you have to design what is the metallic sheath design required. And just to have an idea about the bonding, actually that is the generally adopted ones are single end bonded, that is for a shorter length of cable, one end of the screen only is grounded, the other end of the screen will be kept open. And generally for medium voltage or wherever bonding is not of that important, both sides of the metallic sheath is grounded. In this case, as far as safety is concerned, it is the best system. That is because both sides it is grounded, proper grounding is there, but there will be circulating current that can lead to increased sheath losses and reduced ampacity. But for EHV or higher cross section and 66 kV cable and above, generally single point bonded or cross bonded is adopted. Single point bonded for the small length and cross bonded for a longer length by dividing the cable into sectors and connecting cross connecting RYB, so that due to the 120 phase angle difference in the induced voltages, there will be that induced voltages will get nullified. But that way, when you see that one, single point bonding or cross bonding is adopted basically to increase the ampacity, that is reduce the losses and increase the current rating of the cable. And for that single point bonding, when you are adopting, as the induced voltages is directly proportional to length and directly proportional to the current carried by the cable, we have to see what is the open circuit voltage it see. And generally adopted practices, it should not go beyond 65 watt. That way the length has to, for a single point bond system, has to be limited in such a way that the open point will not see 65 volts or above. And that extended part of single point bonding is middle point bonding, where double length of single point bonding can be adopted. That means center point will be grounded, both ends will be kept open. That open point cannot be kept open because it has to be connected through a surge voltage limiter. Why the surge voltage limiter is required is, that is when you are keeping that one open, any transients or switching or lightning occurs, it will be giving rise to some type of transients. That cable sheathing material should have sufficient strength to withstand that transient. That means there should be some means to ground that transient. There should be, because if you keep that side open, the sheath will be experiencing that transient. That due to transient, that outer sheath will fail. To avoid that one, that open point has to be protected with a surge voltage limiter, which will protect the cable from the transients due to lightning or switching. And in the case of, in addition to that one, all bonded cables, whether it is single point or cross bonding line, it should be provided with an additional ground line, so that the same ground point, even when the surge voltage limiter is there, when a surge occurs, it has to be passed to the ground. But that way, when to that ground should be, there should be the same ground has to be brought to the, even to the open point. Now coming to the CCS cable system which we are analyzing, we analyzed was it is a 630 square mm 38 bar CCS kV system of 1752 meter length, which was in trefoil formation, and middle point bonding was adopted with 3 kV 10 Ka surges on both lines, and actually the rated current was very small, but they designed system for later expecting later higher loads or something, they have gone for the middle point bonding. And the dimensional checks of the cable parameters, everything we checked, it was coming okay, but the system was not provided with additional grounding line. Instead of that one, the same mother earth was provided as the grounding point. And what we have observed is that middle point grounding, where they have provided both ends is source end as well as load end. It is connected through surge voltage limiter, that is open points, and the middle point is grounded. It is throughout in the root length, it is the middle of the root length. And that ground pit, when we measure the ground resistance, it was very high. It was higher than 200 ohms. And this was the visual inspection of the failed piece which we carried out. And actually that in that particular cable, yellow cable was failed, and actually as per the failure history, yellow cable phase has noticed the highest, the yellow phase cable has failed, and short circuit current of 10 Ka was noticed, and differential protection tripped. And that this is the failed cable piece of yellow core. We can see that that when we remove the aluminum sheath, metallic aluminum sheath, actually we could see the presence of moisture, and the water blocking tape was completely burnt, and even it is completely disintegrated, and oxidized aluminum sheath also was oxidized for a certain length, and melting of outer sheath. Actually before removal of that portion we couldn't show in the picture. Before that one we could see that outer sheath, it has been burnt. Melting of outer sheath was observed for a 50% of, that is wherever the trefoil formation has come, all the red, yellow, blue, all the three metal, the outer sheath has 50% of that outer sheath has completely burnt, melted. And the metallic sheath also got completely corroded due to the water. There was water presence also we could have, and more than that we could see the deep indentation of that insulation screen. Very deep indentation we could see that one, even change in color of the red color. Red color actually it shows it is due to PD activities, like we could feel it, and water even semiconducting layer also there was that huge impact, even up to the XLP insulation, that indentation was there, that corrugated aluminum sheath impact was there up to the insulation. But after 300, after certain length of the cable was completely intact. After about 300 MA from the failed portion, it was well intact. This is the nearby cables also, because of this present the red core as well as blue core. This is the cable piece which we have seen, it has almost ash formation was observed to some extent. Outer sheath, discoloration of aluminum sheath was observed with a trace of moisture, and in all cases deep indentation was observed on water soluble tape as well as the core insulation. And water taping gel also observed. Semiconducting water blocking tape was very much adherent. That semiconducting tape in this case it was adherent with we had to pull it out. This the picture shows that how the melting of outer sheath has occurred and the oxidation of aluminum sheath. this is for the other phase, that is blue phase, also the same way. We could see in this case, there was tracking on the outer sheath. Tracking outer sheath, why it happens is there is a potential it is seeing. That's the tracking of outer sheath also we could see at multiple points. Due to that tracking, severe loss of the outer sheath material and moisture in aluminum sheath. In all the cases there was moisture entry also we could observe, because once the sheath damages, there are all possibilities that moisture will enter, and even some portion, even the sand also we could see with the inside the cable. And in this case, what we could feel is system with a ground, because it is both sides, it is not grounded. Middle point was grounded, and the middle point that it is grounded through, middle point was even though it is grounded, that is the only point it is seeing the ground. There the ground resistance was very high. That means it is seeing a floating potential. Metallic sheath is seeing a very high potential, and if we calculate, we can calculate the potential. When we calculate the potential also, it is coming to around 4 kV. It will see between two phases, it was around 6 to 7 kV. We can calculate, it will act like a divider, like that way 38 kV is coming across basic cable insulation and the base sheath, because the ground will be the air, but the ground potential is not seen by the metallic sheath. That high stress along with the contaminants present in the water, it has created the failure of the outer sheath, and the outer sheath failure has once the outer sheath fails, it will just, that what is the purpose of bonding itself, it will be lost, it will cause the circulating current, and that completely due to the, and we know that aluminum resistance is very low. Due to the low resistance of the aluminum, it has caused a heavy current flow through the aluminum, and due to that high temperature has caused deep indentation onto the metallic core, and that what is that happen is with that indentation, any aberration, small aberration on the semiconducting insulation, that one will cause partial discharge. Once partial discharge starts, the failure will be faster. Actually, this cable was failed because of the partial discharge arising due to this high temperature from the metallic sheath, causing the impact onto the cable core, causing the PD, and the failure has started from this side, outside from the cable sheath. That way, what we could analyze, the same thing we could analyze with the MATLAB also, using MATLAB cable parameter, power cable parameter software. Actually, we simulated the cable where actually these are all the cable parameters considered, and this is the way the simulation was conducted. That is the failure we could see at 160 meter. That 160 meter length of cable is one pi circuit, a balance circuit, another pi circuit. And that way, these three blocks actually represent three sections of the cable, and load end as well as source end was adjusted to passage of a current of 26 amps, and middle point bonding we provided through a resistance, and due to that one, the resistance value we varied, and we tried what is the effect of ground resistance on the electrostatic potential on the metallic sheath. This is the graph which we could, electrostatic potential versus the ground resistance. With increase in ground resistance, the electrostatic potential of the metallic sheath also proportionally it is increasing. And coming to the conclusion, bonded cable system, the integrity of the outer sheath is very, very much important, and hence we feel that there should be some method to periodically checking of outer sheath integrity when you are going for a bonded cable system, because otherwise the purpose of bonding itself will be lost, and so bonded cable system means you should have similarly, if instead of giving a ground line, and surge voltage limiter at the open point is very much mandatory to protect the outer sheath from any transients, and similarly if additional ground line is not given, and if you are using the motherer, it is mandatory that you should have periodical measurement of ground resistance. And that's all. Thank you.
Thank you, madam, for the nice presentation on the failure analysis of 66 kV cable. Let us move on the fourth paper, which is from KEC International Limited, Vadodara, based on the case study. The title of the paper is Determination of Life Expectancy for XLPE Insulated Power Cable by Different Methods, a case study. Authors of this paper are Mr. Himanshu Prushti and Ms. Mithila Aithagani. This paper represents comparative case study to calculate the expected life of XLPE insulated cable by two methods. Also, reduction of the life in case cable is not manufactured as per the quality standard is discussed in this paper. This paper will be presented by Ms. Mithila Aithagani from KEC International Limited. Over to you, madam.
Good afternoon all. I'm Mithila Aithagani and I'm from KEC International Limited, and with me is my co-author Himanshu Prusti. So today we are here to describe, we are here to present about determination of life expectancy for XLPE insulated power cable by different methods. It is a case study. So I can see quite a lot of utility companies. I guess this would be a point of interest of you. And coming over to it, so this is our PowerPoint presentation flow, which is a common thing. So here we have, when we have started taking this case study, there are quite a lot of questions which are incurring in our mind also. One question was like, do all power cables serve the design life? The answer may be yes. The answer may be no. The answer may be might be. So because if you take any material or any object, it is upon how you use it, right? How you use it gives the life of it. So one question that incurred in our mind is like, not all power cables will serve the design life. And the second thing is like, I said, like how we use it gives the thing. So if the utilities are able to give how we are loading the cable with, so with that we can see like how it is thermally loaded, and how we can also see like how much stress is generated on it. How you use can make us actually estimate the cable life. It is not the cable life is constant. If you are giving with an AC cable, I can't say it will serve 40 years, right? How you use should be known to us. So this is a variable parameter. And the third is like unethical business practices, like the non-registered cable manufacturers has a drastic effect on this cable life. So for this case study, we have taken two case studies. Both calculates the cable life. So one is 11 kV, single core, 630 square mm XLPE cable is used. So coming into this is named as an Arrhenius model. Basically what Arrhenius is. When you take an Arrhenius model, it is any reaction which is dependent on the temperature change is calculated. So this we basically see about the gaseous things, like in gaseous chemical reactions, we use this Arrhenius model. But today, we have taken this and incorporate into the molecular reactions, like in XLPE. So this Arrhenius model, there is a flow chart. I would like to explain it with a experimentation that we have done in our lab. So for this, we took 3 different type of temperatures as per IEC 60216, and all the 3 different type of temperatures are like an XLPE dumbbell is actually used. So this is an XLPE test dumbbell. We have cut out a portion of it, and as per the standard of IEC 60216, we have taken all the dimension accuracies and created a test dumbbell. After creating that, we have aged it, like as per the standard itself, we have aged the test samples at 120 degrees for 28 days, 135 degrees for 14 days, and 145 degrees for 7 days. So this was kept in an aging oven. After we take out it, we have kept in a desiccator for the conditioning. And then as per this IEC 60216, it was said that we can take any parameter, either a tensile strength or an elongation at break. As per it, it was said that the time taken for 50% elongation at break is considered to be the end of the life of the cable. So we have calculated various things. After aging, we have performed elongation at break. After finding elongation at break, as per this table, we can see we have said we have aged for 145 degrees, and it is for 168. So we have 168 hours. So we need to calculate the elongation break for 50% of elongation break. Here we have achieved 2.86 percent. For 50%, how much time it would take? That was calculated with this Arrhenius. And as per Arrhenius equation, as you go, it almost seems to be similar to a linear line. So ln k is equals to ln A plus e power minus e power RT, e by RT. So most of them is constant. Ln k is what we took for this Arrhenius model is ln of 50% time taken for elongation is equals to whatever the constant parameters and its temperature dependency. As you see in this Arrhenius plot, we said y is equals to 3720x minus 0.5776. So this y is ln of 50% time taken for elongation and break, and x is the temperature. So how did we calculate for the cable life? This is how we extrapolate or estimated the cable life using Arrhenius. And after all this, like we have performed a linear regression line equation for the values we have obtained in the table, and then the calculated life of cable at 90 degrees Celsius, which is deemed to be which is think to be an operating condition for an XLPE insulated cable. So we have arrived at 43.4 years. So remember one thing, it is only the thermal stress we have considered here, or none other factors. So just a precautionary measures, if you also want to conduct this experiment in your lab, please take minimum 5 specimens and also minimum gap of 10 degrees Celsius between any both. And please ensure the conditioning time to be 16 hours, and also a minimum temperature level, as I've said before, is 10 degrees. Now let us go to the next case. So my co-author Himanshu Prushti would present it.
Just now, Aj, we saw that the life expectancy depends upon only the elevated temperature. But it is very surprising that the power insulation degradation not only depends upon the elevated temperature, but also degrades significantly when it is subject to undergo the electrothermal stress and the stress by the cyclic varying load. So hence this case study, Arrhenius IPM model is the analysis of the effect of the load cycle, thermal transient, and the electrothermal stress on life expectancy of XLP insulated power cables. So basically the Arrhenius IPM model says that basically the three models are there. Like the first one is that it deals with the XLP insulations and the analysis of the time, the life analysis of XLP insulation where it is corresponding to the electric field stress without considering the load cycle. The second one is that it deals with the lifetime estimation associated with the thermal stress produced into the insulation due to the load cycle. And the third one is the combining of electrothermal as well as the load cycles. So in the equation, as we found that the Arrhenius IPM model, in that equation, if you see that in the left side, that is written the life of the cable is equals to the time to failure at cable, that is theta cable is equal to theta naught and E is equal to E naught. That means it is absolutely at no stress and no temperature. So this is completely the left side of this equation is shows that the life estimation depends upon only the electrothermal stress. The other parts of the equation, exponential to the power minus b, is described that the life expectancy depends upon the load cycles. So, and in the left side that the time to failure at cable TTF naught E by E naught to the power minus n0 minus b whole into 1 by theta naught minus 1 by theta naught cable. So that describes that it is a synergism effect of both electrothermal stress as well as the load cycles. So by putting all these variables and the constants which have been taken from the various references, we have already depicted in our the complete paper. After calculating this, after putting these values, we found that the life of the cables at 90 degree is very surprising, 9.11 years.
So you can see that there is quite a lot of difference that we have found with Arrhenius and Arrhenius IPM model. This Arrhenius model only takes the temperature dependency, and here surprisingly we have taken the loading cycle and what is the thermal effect on it, and also what is the electrothermal stress on it. So we have quite a lot variation. Now if we see the mathematical calculations of it, I'll just explain for one. So we have compared Arrhenius IPM model and Arrhenius model. So we have taken at 90 degrees Celsius the load to be loading percent should be 100%, and a 9.8 megawatt load, 11 kV, single core 630. So at that, the life, this is the third case, so the life with Arrhenius IPM model is 9.11 years and Arrhenius model is 43.4 years. So this is a quite brainstorming thing, like this actually gave us what Arrhenius, by considering a little factor of electrothermal stress, varying load cycle, this much age difference is there. So the utilities have to think upon, to ask the manufacturers upon which method you are calculating the cable life. Now let us go to the next. So these are the basic comparisons. I said at 90-degree operating temperature, it is 9.1 years with Arrhenius IPM model and 43.4 years with Arrhenius model. And also with Arrhenius IPM model, we could say we didn't take continuous tracking of load cycling. So if we took, the cable is loaded with 90 to 85%, like 90% to 85%, the cable life is observed to be 37 years to 75 years by Arrhenius IPM model. So this is all about cable life. Then what is the effect on unethical practice? So here I have given a statement. However, the cable life calculation is valid only if the manufacturers have followed good standards, because this is all mathematical, right? So mathematical, we didn't conduct any experimentation for Arrhenius IPM model. If it is unethically practiced, so what would be the effect on it?
The unethical practice has a drastic impact on the service life of the cable. Some of the major impacts that premature failure of the cables, cable gets easily burst during the short circuit or overloading conditions, more heating effect results in electrical overloading, early degradation of cable sheath results in the electrical stress, and then for subsequently the failure. So system gets breakdown due to the poor quality of product. Current rating gets also impacted. Basically, mainly the unethical practices are that in the conductor, the reduced area, and the low material grade. Similarly, in the insulations, the reduced thickness and the low grade of materials.
So we can see, like, if we saw that unethical practices with a reduced area, if we consider, even though you give the same load, it gets overheated, right? So according to that, we have calculated without unethical practice, if we give 100% of loading, the temperature is 90 degrees Celsius. But by reducing the area somehow, like if the customer have not seen about it, so with the same loading condition, the conductor might have given the temperature of 94 degrees Celsius, which is more than the rated, right? So that would affect the cable life. So while seeing the comparisons with an unethical practice in the conductor, we can see at 90 degrees Celsius, 100% loading, 9.11 years, only because due to the unethical practice in conductor, we can see it as 6.56, it have reduced. And also with the unethical practice in the insulation, so the minimum stress level below which the cable life is deemed to be negligible. So that we have considered, and that due to if you use a low graded material or if you are reduce the thickness, so it would reduce upon, this is a hypothetical case, we have from 2.5 we have reduced to 2.45, and with that we have calculated the cable life have gone down from 9.11 years to 7 years. Similarly, if there is an unethical practice both in conductor and insulation, the same analysis have been done. There was a change in values in the equation. With that, we saw that it from 9.11 years, it have gone to 5.06 years. So this is basically comparison between unethical practice, without unethical practice in the conductor, unethical practice in the insulation, and cable life due to unethical practice. If you follow this unethical practice, you can see the cable life has drastically gone down. This is not a factor that it can be seen to everyone, but these factors affects in the long run. So to keep a check to an unethical practice, mostly the utility companies, please always use trust NABL accredited lab, and also if in case required, please go for a third-party agency testing, and don't fall for a low cost. It is not always L1, right? And buy the cables from the recognized organizations. Also ask for the past performance records. You shouldn't deceive by spurious brands with similar logo names. Always conduct the conductor resistance on 10-meter or complete cable run, and also seek out for procedure of tests performed during the inspection and ensure all the test equipment are calibrated. So this is our main theme. Basically, we have concluded this. Arrhenius model only takes with thermal stress. Arrhenius IPM model have gone with the overloading conditions, electrothermal stress on it also. And also one last statement is the bitterness of the poor quality remains long after the sweetness of low price is forgotten. Thank you.
Thank you.
Thank you, madam, for the presentation. Now let us move last paper of this session. This is fifth paper. It is from Borok Pte Limited, titled as Improving Medium Voltage Power Cable Performance Through Jacketing Materials. Author of this paper are Mr. Zander William Parikh, Borok Asia South, and Mr. Suresh Kumar Daga, Borok ISC. In this paper, important properties of cable jacketing material which can provide best possible protection is discussed. Basic function, importance, and comparison of properties of various jacketing material is also discussed in this paper. This paper will be presented by Mr. Zander William Parikh from Borok Pte Limited. Over to you, Mr. Zander.
Thank you very much. My name is Xander Pierik. I'm here to present you on behalf of Suresh, my colleague in Baruch, and myself, a presentation on how medium voltage cables and the reliability can be improved by selecting different types of jacketing materials. Baruch is a material supplier based from the UAE. So, in the market for medium voltage cables, we see different drivers for growth, not only in India, but around the whole globe. So on the left-hand side, you can see an illustration of a normal medium voltage cable, where we have the inner jacket and the outer jacket, which is in this case a red one. So we see a couple of drivers for more growth in medium voltage cables. The first one of them is investments in renewable power. The government of India has declared to invest up to 300 gigawatts of renewable power generation by 2030. And we expect to see more demand in medium voltage cables in order to connect the solar farms and the wind farms to the grid. Moreover, rapid urbanization may require to replace overhead lines, medium voltage overhead lines, into underground cable lines. And the same is what we see in the United States, where 3 power utilities now have decided to go fully underground and remove the overhead lines. Industrialization and economic growth is strongly correlated to medium voltage cable demand. So the Indian economy is expected to grow this year about 7.7%, which will require much more energy to be transported and transmitted to the industries, but also to the households. And last but not least, there are investments in electric vehicles and two-wheelers in India. One of them is Ola, producing two-wheelers on a large scale. But also these electric vehicles and two-wheelers require batteries which need to be charged at a certain point of time. So this will require more load in the system. So the main question is, how can jacketing materials make a difference in terms of reliability for the cable systems? So there are 3 main aspects where it makes a significant difference. Starting with the installation. It can support with the ease of installation and prevent damages based on abrasion resistance. Moreover, there can be external environmental impacts, and as an owner of the power cables, you want to reduce the level of maintenance and reduce the number of failures, since these are costly and create outages for the customer. So if we move on to the different features which are important for the installation, environment, protection and maintenance, we can identify that abrasion resistance, the cable weight and coefficient of friction are of key importance during the installation process. For the external environment, environmental stress crack resistance is of high importance, termite and rodent protection, and also UV protection when the underground cable is reaching the substation. On the maintenance side, water ingression is degrading the performance of XLPE and reduces the lifetime and creates failures. So therefore it's important to have a high breakdown strength over the lifetime of the cable. So obviously there are different jacketing materials which can be used for medium voltage cables. The first one of them, we have heard them a couple of times already during today's presentations, is halogen-free flame retardant materials. These are mainly used sometimes in house wires, but also for high voltage cables these days in tunnel applications. Similarly to metro projects, what we see in Singapore, where ST8 is required, and CPR in Europe requires to have categorized different levels for flame retardant properties for the cables. And most of them, buildings that are difficult to evacuate, like hospitals, will require the highest level of flame retardant performance. Secondly, polyethylene, HDPE, MDPE, are different types of jacketing materials that can be used for underground cables and overhead lines. And then as a third, polyvinyl chloride, also called as PVC, is mainly used for a jacketing material in underground cables. However, after seeing all the presentations, I'm pleased to see that Adani is already trialing now the HDPE jacketing solution for improved electrical performance. So moving on to the installation impact. If a medium voltage cable can use different types of jacketing materials, from PVC to HDPE, MDPE, or even LDPE, which is not so common. There's a difference in density when you have compounded PVC, which on average has a density of 1.45. And if you compare this to HDPE or MDPE, there's a difference of about 34 to 36% in density. So as a power utility, you buy the cable based on length and not on weight. So this density will give you an advantage that the cable will be lighter, and that's a big advantage during the installation process because you have to apply less pulling friction and less pulling power. Secondly, the impact on tension and abrasion resistance. To what extent can the material withstand scratches, installation over a hard surface, rocky terrains? And there it shows that HDPE has an abrasion resistance which is up to 7 times better than PVC. So it's more prone to scratches, and the jacket remains to be intact as good as possible. Third one, HDPE, it has been mentioned before, it's a smooth material. It's also heavily used in fiber optic cables as a jacketing material to pull the cables through the ducts. So it's smooth, and therefore it creates a lower pulling force and a lower friction on dry concrete, for example, in trenches. And that's why HDPE jacketing materials are used widely in high voltage power cables, since the cables will be pulled sometimes over the concrete, sometimes in sand, subject to the installation conditions. On the environmental side, in India, there are many rodents and different types of termites, and therefore it's important that the hardness of the jacket will prevent termites to bite into the jacketing and will not create any failures. So hardness is a key player here. The harder the material, it can be calculated based on the D-short technology. So PVC is a much softer material, which allows you to have a slightly better bending radius, where HDPE is harder and which prevents you against termites with a slightly lower bending radius. However, if you go in between, like MDPE, will give you a bit the benefit of both sides. Crack formation is another one. There's a test where you can carry out where you can assess the level of crack formation with 10% IGPAL. So HDPE is being produced in different methodologies. One of them is the first generation, the unimodal technology, and you have the second generation, the bimodal technology, which basically gives you the benefits on the processing side as a cable manufacturer, but it gives you the mechanical advantages of the HDPE. And third, UV protection. The underground cables are reaching the substation eventually. They might be exposed on the last half a meter to sunlight, and therefore their basically two different methodologies what you can use to ensure that your jacket is UV protected. One of them is using carbon black, which is a natural UV protector at 2.5%, or using UV stabilizers in your natural material. So on the right-hand side, you can see a test result from a pre-compounded material, in this case it's black, or an inline mixing material, where you have a natural jacketing material and you mix in the line carbon black. So you can see on the right-hand side, the most right picture, that the carbon black is well dispersed in a pre-compounded solution, and it's not that well dispersed for online mixing. And this is also something you can see during the aging process. On the blue bar, you can see that the UV protection is very strong for the pre-compounded black material, while the inline mixing shows a high level of degradation at 3,000 hours of aging. So pre-compounded materials in that case provide the best mechanical performance after aging. And then we come to the electrical part. If we take the best practices, from example, from the packaging industry, in packaging in a water bottle is using different types of polymers, since the water absorption is very, very low. The water remains to be inside, there's no leakage, and there's no moisture from the inside going to the outside. This best practice is something we can apply to the cable industry as well, since we all agree that water ingression to the core of the cable will reduce the lifetime of the power cable and eventually creates failures. So when we have we have a test done where we compared PVC against MDPE, HDPE, and LLDPE to understand the water barrier level of the different materials. And it has been concluded that the difference is that HDPE provides almost a 7 times better water barrier compared to PVC jacketing. So it will prevent the water to ingress to the core of the cable. And this is especially very important for areas like Mumbai, where the water level under the surface can be very high during the monsoon period, or when cables are installed next to rivers, etc. So the graph in the middle basically shows a research study from NITREC, which is an independent American laboratory. So they have carried out a research study where they produced two exactly the same cables, medium voltage, and one they produced with HDPE as a jacket, the other one with PVC. Both cables have been put in service for 10 years on the same circuit with the same electrical and thermal stress. After 10 years, the cables have been taken out of service, electrical breakdown tests have been carried out, and what came up front is that the cable with HDPE jacket showed a significant better performance in electrical breakdown strength due to the water barrier. So the HDPE cable had an electrical breakdown strength of 20 kilovolt per millimeter against PVC jacket with 11 kilovolt per millimeter. And this is only after 10 years of service. And obviously, when water ingresses to the cable, water trees are appearing. And one thing you know for sure, if the water tree is there, it will not dissolve itself automatically. So the conclusion is pre-compounded black bimodal technology as a HDPE or MDPE material offers many benefits over PVC for underground medium voltage cables. So these are the improved electrical performance, the higher abrasion resistance during the installation, easier installation can be achieved. We can take the best practices from the high voltage to the medium voltage side, where high voltage EPC contractors and cable manufacturers are very well known how to install these cables. And there's a better performance in the external environment when it comes to crack resistance, termite and rodent protection. So There are many utilities around the globe who have decided a few years ago or now to change their specifications from PVC jacket to PE jacket in order to increase the reliability of the electrical system. This is my presentation. Thank you very much.
Thank you, Mr. Zender, for nice presentation and timely presentation. So let me summarize, a quick summarize of the session. So first paper was from the universal cable, which is basically on the use of the smooth aluminum sheath instead of corrugated aluminum sheath. In this paper, they have presented the comparison between the smooth and smooth aluminum sheath as well as the corrugated aluminum sheath with the example of 220 kV copper cable. Second paper was presented by Adani Electricity, Mumbai, which is on the issues related to the transition joints between PILC and XLPE cable. They have also represented the various difficulties and challenges in the type testing of the transition joints. Third paper was on the failure of 66 kV middle point bonded system cable, which was presented by CPRI. In this, they have presented the failure analysis and also the simulation study also they have presented. Fourth paper was from KEC International, which is on the case based on the case study, and they have represented two case studies. One was on accelerated thermal aging method, and second one on the Arrhenius IPM model method. Finally, last paper was published by the Boruch PTE Limited, presented by the Boruch PTE Limited, and presented by Mr. Zender William Perick, which is basically on the cable jacketing material. So now the floor is open for the question and answer. So let us start from the paper 1, which was presented by Mr. Guru Nani. Is there any question on the paper 1, which was on the smooth aluminum sheath innovative trends?
Yes, sir. Myself, Gautam Sharma from PowerGrid. I have a question. The major focus was on how much change in length means how much we can increase the length by reducing the corrugated to that smooth.
Yeah. Actually, the diameter, if you see, 13 millimeter diameter goes down in case of smooth aluminum sheath. And also, it depends not only the diameter, but it depends upon the weight.
Yeah.
Weight is also go down, and the drum length increase because the bending radius of the barrel also goes down. So, it depends basically upon the length, basically depends upon the weight of the cable.
Mainly transportation weight is restricted.
Yeah, you can say that approximately 50 to 100 meter we can increase.
Actually, I am not getting the right thing, that weight is only reduced by 0.5 kg in 1 meter. So it will be appreciable that 100 meter will be increased in a drum dia of, I think.
It depends upon the road and transportation condition also. If the weight is, first one is the constant of the weight.
Yeah.
If the road and transportation condition is good, then definitely the manufacturing is not an issue. So we can easily increase by 50 to 100 meter length.
My another question is corrugated to smooth, whether it bending radius which we restrict to 20 D plus D, whether it will be increased to 30 or it will be remains the same.
No, same for both, but this overall diameter goes down so that the bending radius will be reduced.
No, that one is total overall dia will be reduced, but bending 20, we are restricting to 20 D, I think so. And whether it 20 D will be increased to 25 D or 30 D, that one will be, I am asking.
No, this is only 20 D.
20 D.
That is for bending. Bending test.
Okay, okay. Actually, we can, in same size of drum, we can roll more length, but the weight restriction will be still be there.
Sheet thickness also, because it gets bonded with the outer sheath. So even lesser thickness, which meets the short circuit test requirement, that can also do. But while corrugation, you need a mechanical strength. Because of corrugation, there should not be any flattening at all.
For calculation purpose, you have maintained the same thing.
Same
Yeah.
thickness. So that apple to apple comparison is there in the current rating, short circuit rating.
Okay, okay. Thank you.
Okay.
Yeah. See, madam, there is no test for strength of aluminum sheath, but there is one impact test we have mentioned. So because since aluminum sheath getting perfectly bonded with the sheath, so outer sheath also act to the strength. So that flexibility comes, and if something falls on that, so that impact is taken. While in corrugated aluminum sheath, while you are producing itself, suppose your thickness is too low, possibly that buckling or flattening effect can come, which is not there in smooth aluminum sheet. But the crux is, it has to be bonded with the PVC.
Bonded with the PVC.
Yes.
Bonded with.
Is there any limitation of the thickness? That
Thick,
one, it can be
no,
for
thickness you can reduce. But in corrugated, you cannot reduce because certain mechanical strength is there. Otherwise, your corrugation gets flattened. Yes.
Due
Okay.
to that, I am just asking.
Yes.
The strength wise, so it is touched to the like.
It will form uniform bonded layer. You cannot separate it. So that is still comes because of
Okay, sir. What we can do, we can have the further discussion during the tea time. Is there any further question on the paper 1, or otherwise we shall move to the paper number 2? Maybe last question for paper 1.
Material, aluminium material itself. The aluminium material as sheet, of course, it has a lot of advantages, but the recent discussions globally, what is happening is the cables which were laid with the corrugated aluminium sheets have started failing. Lots of cracks have appeared, and not only that, the oxidation also is happening, because whatever the care that you take while laying the cable sheet gets damaged, or in some points along the cable outer sheets, the puncture occurs, and then the moisture entry is always there. So therefore, there is a discussion which is going on, and then probably LS cable people, if they are here, they can throw some light on this material. They are coming out with an aluminum alloy, which is going to be a better material, which can be used in the normal case, and as well as even that can be used in oil and gas industries. If you can throw some light on this, the material itself.
Actually, the purity mentioned in the standard is 99.6% of the aluminum. So
yes, it's almost pure aluminum. Yeah. Now, so it's been proved it is not as good as lead sheet. Lead sheet, of course, it is the choice of many utilities.
Sir, our paper was based on comparison of corrugated versus smooth aluminum sheet. But in case of smooth aluminum sheet, your outer PVC gets perfectly bonded. So there are no chances of water seepage between aluminum sheet and PVC. While in corrugated aluminum sheet, these are two different processes. There are separator in between. Here, even if your outer sheet damage, that damage will be restricted to that particular point only. The water will not travel along. For that purpose, this impact test is there.
Yeah. Okay, and we'll have a discussion later.
So there will be one test of peel strength test will be there. So there is not a chance in case of any kind of water or moisture is there.
Okay, sir. Let us move further. Is there any further question on paper number 2, 3, or 4? Paper number 3, okay.
I just
think
wanted
it is
to
for
know.
Madam.
Yeah, I just wanted to know maybe have they done any sheet damage test as per EC 60229? They should have done the sheet damage test. If that is not done, such type of failures will take place, especially in outer sheet. No cable is charged unless the sheet test is clear. The 10 kb for 1 minute.
Sir, actually this particular case is after failure and after some 3-4 years, after installation of 3-4 years it was tested. During the initial stage, during the when the system was charged, that time they have done the sheath integrity, but further to that one they have not done anything.
But always such things can happen unless there is a number of sheet faults. Number of sheet faults, only such type of things can happen.
It has happened within so many places. Actually, that's what we could feel even the tracking of the outer sheath, and there was breakage of the outer sheath.
Because that's why
A lot of failures we could observe on the outer sheath due to the, like in this particular case, what we could have seen is some 2-3 circuit. In one particular circuit, what we have seen is that grounding middle point where it was given, there was the ground resistance was very high, and I think that potential actually developed on the metallic sheath, and along with whatever that contamination available in the water, both together has acted and tracking and the failure of the outer sheath. That's what we could feel it. Sir.
Okay, thank you.
Thank you, sir.
Okay, so I hope there is no further question on paper number 2. Is there any question on paper number 4, which was on the case study of life extension of XLPE material, or otherwise the last paper on the this jacketing material of cable?
First of all, thanks to the authors. They have made a very good attempt about this life expectancy of XLP insulation or XLP cables. I have just one question. You have discussed about two processes, two methods of life estimation. So why this vast difference, and what is your take? I mean, as an author, or maybe you are a manufacturer also, so what is your take? Which one one should follow? Which life estimation process one should follow?
So the vast difference is only because of in the first case, what we are taking, we have considered only the thermal stress. We are just keeping the test sample in the aging oven, and we are just aging it for some temperature. Only the temperature constraint we are taking. But if we go in the second case, we are actually finding out the customer what their load is. We are asking the customer what the temperature is. Like according to the load, we have actually conducting how much temperature that could generate in the conductor. According to that, and also by giving a certain amount of voltage, what is the electric stress which is creating on the cable. And we also consider one more factor, which is a synergism between this electric stress and the thermal stress. So all these factors made this much vast difference. Because in the first thing, we only took up the thermal. In the second thing, we have took these various factors or constraints. So I guess, I hope.
But basically, idea was to find out what is the real life of a cable. So from these two studies, are you able to conclude which one is final or which one should consider? Because
so
again,
basically, we can go with the Arrhenius IPM model itself, which is more close to the practical things. Like even if you go to the site and visit, or if you see about the cable life,
but
you
that,
can.
But that gives very low cable life as compared to 40 years. It is giving around 9 years because
it is 9 years only when 90 degrees is operated. The cable is operated at 90 degrees.
Cable is meant for that temperature.
It is
XLP
not operated.
Cable is meant for.
It's
it
not
is meant for that. And your
it
aging temperature for Arrhenius and all, you are deciding temperature based on that. Your continuous loading is at 90 degrees centigrade. So there is vast difference. I don't know. I'm again saying it was best attempt, but possibly a conclusion was somehow. We could not get that.
Okay.
That was the only point.
So actually, in our real life also, like suppose if I'm taking the example, suppose when we are running, like stress, suppose for an instance. So when we continuously running in the field, that means we can go up to suppose 1 kilometer or 110 meter. But we will run, then stop, then run, then stop. then ultimately we obviously our stamina will be loose, and we are I mean the length, I mean the meter will be reduced at that time. So suppose if you are giving a continuous stress to the insulation, that might be some, I mean like 40 years or, but if you are changing the stress level, like some duration of time you are giving high stress, then again you reduce the stress, that then after, I mean the life of the insulation going down, sir.
Yes, sir. It's a time
Cable is
limitation.
meant
So
for 90 degrees centigrade throughout life. I'm not talking about in overloading. For a continuous loading which is specified. So for that, possibly the lifetime should have been, I mean, if not 40 years, 35 years, 30 years, but these two comparisons are not basically comparable. That was my.
okay, so anyway, we will close the session because of the time limitations and all. If you have any further questions, authors are available here. So during tea time, you can discuss with them. So I thanks all the authors for presenting their paper and timely delivering of the presenting the paper. Finally, I thanks to the IEEMA Cablewire Technical Committee for providing us this opportunity. Thank you. Now the over.
Thank you, sir. And it was indeed a great session by hearing all the authors, and different case studies were presented by either by, we can say, KEC or AEML. So it was a very wonderful session to hear all of you. I would now request Dr. Khopkar to present a memento to all the authors. I also request Mr. Bala Ramachandran sir to please come on stage and hand over a token of gratitude to our session chairman, Dr. Khopkar. Thank you, sir. We may come upon for a group photograph at the front of the stage, please. Thank you. We will take another short tea break and we'll come back for a great panel discussion. So I would request all the members and or authors and session chairs to please go and take a cup of tea and come back with a cup of tea here itself on the table and enjoy the panel discussion. Thank you.
चलता है
यही चलता है बाद में जलता है. Around 25,000 people in our country are killed every year due to fire hazards. Give lot of importance to consider fire safe cable. Ignore the fire safe cables from Ravi. Business is safe if your cable is fire safe. Hello जयंती भाई, केम छो? Super success. आज तो छाए हुए हो आजकल.
अरे थैंक्स वो क्या है अपना एक प्रिंसिपल है नहीं बिकता है
Sir, what about safety from fire? In case of fire hazard, will they send your production? Cable कौन सा लगाया है?
केबल का क्या है क्यों नहीं चलता है
जयंती भाई, यही चलता है बाद में जलता है. 90% of the electrical fires are caused due to short circuit. Cables are a very important part of it. Give lot of importance to consider fire safety. Ignore the fire safe cables from Ravi. Remember, business is safe if your cable is fire safe.
Fires are expensive. They not only destroy the property, but claim invaluable human lives. More lives are claimed during fire breakouts due to the harmful smoke, which hampers visibility and causes choking. Fire survival cables from Ravin therefore serve as a boon during such fire breakout. At Ravin's state-of-the-art facility in Pune, the fire survival cables go through stringent quality tests to ensure that the cables conduct electricity during fire for 2 to 3 hours. That allows the electrical system to run uninterruptedly so as to keep the facility running and help evacuate humans. Make sure that the smoke levels emitted are minimal for clear visibility during fire breakout so that safe evacuation of people is possible. Any direct impact on the cables from falling debris do not affect the electrical transmission. The cable performance is not affected by the water spray in case of pipe bursts, etc. And for this reason, Ravin's fire survival cables are manufactured by low smoke zero halogen compound to allow high level of visibility. Fire survival cables are manufactured with utmost care at Ravin's manufacturing plant, with quality checks at every stage. All cables are tested to make sure every batch is consistent and meets the quality standards.
लीजिए ना लेने में क्या जा आ रहा है
Hi, sir. So, we are just into tea break now, and we'll be starting the session in another 10, maximum 5 to 10 minutes. So, you can relax now. I just wanted to check that everything is visible and we can talk to each other like very properly, right, sir? So, very nice, sir. It's completely audible. You look good, sir. Absolutely, you look great, sir. Better than your profile picture. So, sir, absolutely. Yeah. Thank you so much. So we'll take 10-15 minutes break and maximum 10 to 15, like 20 to 12 minutes. And we'll come back and your screen is, you can watch people, roaming around, right? Sure. ठीक है. Absolutely, sir. So, sir. Thank you, sir. So, what we'll do, sir, you can also relax for another 5-7 minutes, then we can start the video again, sir.
Okay, so I'll just mute and stop the video right now.
Absolutely, sir. Sure. Thank you so much.
Brazil, and Mexico that are equipped with the best-in-class technology to manufacture transmission towers, monopoles, hardware and industrial towers, railway, solar and substation structures. We make mobility easy through our railway projects, be it through overhead electrification, laying of tracks, signaling and telecommunications, or civil works in the most challenging environment. Having successfully executed large and complex rail projects across India, we have electrified 40% of the Indian railways. We build state-of-the-art facilities, focusing on all kinds of civil works, including buildings, factories, infrastructure facilities, and water treatment and management facilities. We leverage leading-edge technologies to ensure superior quality and reduce the time taken to commission projects to deliver the best to our clients. At KEC, through our solar projects, we harness the power of nature to build a sustainable tomorrow. We have end-to-end capabilities to deliver projects over 100 megawatts in fixed tilt, single-axis tracking, rooftop projects for several public and private players. Our cables division, RPG Cables, is well known for its quality and reliability in the market. We manufacture power, control, instrumentation and telecom cables and are one of the leaders in manufacturing and laying of all kinds of EHV cables across the globe. We strive for excellence and innovation through our state-of-the-art design centers in India and the Americas. We leverage the latest in technology, be it drones, LiDAR, or mechanized construction, along with our firm belief in delivering excellence to our customers. A strict adherence to safety and quality is firmly rooted in the ethos of our company. Our skilled resources, robust processes, and exceptional project management capabilities help us build a better tomorrow. Today, we create, we innovate, we dare. Whatever be the challenges, we connect, we build. Welcome to the world of Power, a global conglomerate with over $1.25 billion having presence in more than 90 countries. Welcomes you to its flagship brand, RR Kabel. Spread across 2.7 million square meters. Offers wide range of wires and cables with application ranging from household to industrial to robotics. pack of RR Kabel, you contribute 1 rupee towards a noble cause through Mission Roshni, a CSR initiative of RR Global, committed to creating more smiles through various initiatives towards education, women empowerment, skill development, and sustainable solutions. We are RR Kabel, the name that stands for innovation and trust.
Globally, climate change is necessitating a shift in energy transition, and the world is looking forward to a positive transformation in energy space. In India, the energy transition to renewables is a shining story.
The share of renewable energy in the power generation mix is poised to grow from 14% in FY15 to 35% in fiscal FY25. However, to support the continued RE generation additions, the need for a robust and reliable transmission system is critical. An estimated investment worth ₹3.5 to 4 trillion is expected to be invested in the Indian transmission sector.
Sterlite Power is a leading private sector power transmission infrastructure developer and integrated solutions provider, operating in two of the largest greenfield
concession market in India and Brazil. The company has the highest number of operational projects in the private transmission sector, with a portfolio of 27 projects, including current and solar. Sterlite Power is also one of the largest players among private sector operators, with a significant market share in projects won through value-based property development in India.
Powered with two business verticals and with an integrated presence across the transmission value chain.
It is already playing a major role in India's renewable energy transformation. Its infrastructure presence with greenfield transmission concessions in India and Brazil gives Sterlite Power a significant edge, while its solution business provides bespoke solutions for upgrade and upgrade of greenfield projects. Sterlite Power has a track record of robust financials, economic completion of complex projects, and clipping assets with maintenance. Till date, it has flipped assets to multiple counterparties across India and Brazil. Sterlite Power was also instrumental in creating India's first power sector engine, India.
The seamless integration of technology and innovation in the life cycle of its projects gives Sterlite Power
a competitive advantage
and allows the company to deliver complex and critical projects on time.
Sterlite Power is a purpose-driven organization with a strong focus on ESG. Some of the sustainable practices adopted by the company include creation of a safety-first culture, optimization of transmission routes to minimize the impact on environment and biodiversity, and introducing innovations such as tree translocation and drone stringing to ensure sustainable development. Focusing on the well-being of the community, Sterlite Power has undertaken many noteworthy initiatives to ensure overall development of the communities in which it operates. Sterlite Power is also a certified Great Place to Work and the recipient
role in harnessing energy safely to cater to the growing and insatiable demand of energy for our daily life. Universal Cables Limited delivers power to your doorstep safely, efficiently. Serving the nation since 1962. Products of Universal Cables with the brand name of Unistar are used in various infrastructure sectors and industries like conventional, nuclear and renewable power, steel, heavy engineering, petrochemicals, cement, ship wiring and underwater application, mining, oil rigs, railways, defense, etc. Universal Cables belongs to MP Birla Group and is a leader in the Indian cable and capacitor industry with a wide range of products. Universal Cables manufactures varied spectrum of power cables and capacitors meeting requirements of national and international specifications and also tailor-made to customers' own specifications. Unistar products are approved by various Indian government agencies like IRS for shipping, DGMS for coal mines, DGQA for defense, RTSO for railways and Bureau of Indian Standards. Since inception, Universal Cables has been a benchmark in the industry for quality products. In the year 2007, Universal Cables became the first Indian company to start producing EHV XLPE cables up to 220 kV using vertically continuous vulcanization process. That is, VCV process with proven know-how from Fulukova Electric Company Limited, Japan. EHV plant houses to state-of-the-art VCV lines. The company has the facility to manufacture both segmented as well as milliken conductors. The main cutting-edge feature of VCV technology are true simultaneous triple extrusion with single common crosshead, dry-cure, dry-cooled process, dimensional accuracy for perfect geometry with zero eccentricity and ovality of the insulation, class 1000 cleanliness level with completely closed material handling system, online X-ray monitoring system, direct gravitational feeding of XLPE compound, control and monitoring in production process.
I request all the members to please take their seats. We are starting with the panel discussion. क्या कह रहे हैं? May I call upon Mr. Shashi Amin, who will be the panel chairman. Mr. Shashi Amin is Bachelor in Electrical Engineering from SSGM College of Engineering and Masters in Marketing Management from Wellinger Institute of Management. He is currently Chief Executive Officer, Cable Solutions at Apar Industries Limited. Mr. Amin has 33 years of experience in sales and marketing, business development and PLN management in cable industry in India and abroad. We welcome you, sir. The next panelist for today is Mr. Madan Dayal Gupta. Mr. Madan Dayal Gupta is a postgraduate in rubber and plastic technologies from University of Science and Technology, Calcutta University. Mr. Gupta is currently working as President, Technical and R&D in Didev Plastics Industries Limited. He has more than 32 years of experience of working in R&D of cable compounds and specialty cable development in various capabilities. We welcome you, sir. The next panelist for today's session is Mr. Arnab Majumdar. Mr. Arnab Majumdar is a BTech and MTech in Polymer Technology from University of Calcutta and University of Mumbai respectively. Currently, he is Deputy General Manager in the Dow Chemical Company. He has an experience of more than 2 decades with expertise in application development for elastomers and plastics for electrical and telecommunication industries. He led application development, product qualification and technical services for Dow's wire and cable product in Indian subcontinent. Apart from India, he served Middle East and Africa market in the past from Dow. We welcome you, sir. The other panelist for today is Mr. Suresh Daga. Mr. Suresh Daga, a polymer technologist from ICT Mumbai University. Mr. Daga is working with petrochemical industry for past 32 years for promoting use of polymers in various application development. He has been associated with cable industry from past 15 years in promoting use of quality polymeric compound for better use and longer life, for better performance and longer life of cable. We welcome you, sir. Our final panelist for today is Mr. Ankit Bagheri. He will be joining on online mode. Can we have him on the screen? Mr. Ankit Bagheri is a mechanical engineer with MBA in International Business from Management Development Institute, Singapore. He is a director with Ruby Mica Company Limited. His increased focus on R&D armed with over 400 strong skilled workforce with an exhaustive network of dealers are ready to provide installation solution to industries across the abroad. May I now request Mr. Shashi Amin sir to take the session, to take the panel forward. Thank you.
Thank you. Good evening, everyone. I would request everybody to settle down. They can get their cup of tea and they can have it here. We are almost late by about 90 minutes. And my colleague here says me he's got a flight to catch. So I will try and wrap up as early as possible, but without asking some serious questions to them regards cable. If you look at the topic for today, it is innovation in material for enhanced safety and sustainability. And today morning also when Gopal Kabraji and Vijay Karya spoke, they spoke about safety, they spoke about quality. If I go back to my college days about 33, 34 years back, we had a subject called cables. And what I studied those days, and when I came out and joined a cable company, I started my career in a cable company, nothing of that sort I could hear in the market. Like those days, I think I remember what Gutta Percha cables, NBR, PVC, but going forward, all these compounds have changed and new compounds have come in. XLP came into India, I think 92, 93. Only one company in the world who was making it. XLP compound was very expensive. XLP cables were more expensive as compared to PVC cables. FRLS was introduced in India after fire in Obra Thermal Power Station. Fire survival cables came into India when NPC did a study. They wanted certain cables for reactors. And again, that was around 93, 94 for Kakrapara nuclear power plant and Kaiga power plant. And slowly this fire survival or fire resistant cables from nuclear reactors or nuclear power corporation came into the other thermal plants. And today we are talking about fire resistant or fire survival cables being used in the construction activity, malls, hospitals and high-rise buildings. 2 decades back when I was working for BICC, those days there was a legislation in Middle East and Europe. Any building beyond 14 stories, it's mandatory to use LSH cables. As Gopalji mentioned today, internationally there are only 2 types of wires. Either it is a normal PVC wires or there is a zero halogen wire. There is no other categories of wire which are sold internationally. Today in India we talk about PVC is outdated. We talk about FRPVC, FRLS, HR, HRFR, then zero halogen. Now again the technology which has come in of electron beam. So methodology of insulation, the methodology of curing is getting changed. I mentioned in one of the events sometime back, 70% of the building which are to come or which should be ready by 2030 are yet to be built. So new technology as far as wires related to safety has to be taken care of. Today some of the people are talking of green building, again, but everybody is not serious. I was talking to a couple of consultants on fire survival cables related to commercial malls and hospitals. They were comparing the fire survival cable prices with the FRPVC. Then I tried to convince them, look at the cost of the total project, it is nothing. So going forward today, I would raise some peculiar questions to my friends here from the industry. And they are stalwarts as far as polymer technology is concerned. First question to them is on zero halogen, fire survival cable. My question to Mr. Amit ji is, you are a pioneer into glass mica and glass fiber. Can you throw us some light as far as product and what is the innovation happening as far as your organization is concerned?
Yes, sir. Hello, can you...
Yeah, we can hear you, Amit ji.
Yes. So, sir, thank you so much once again for having me here. And it's a privilege and honor to be here. So, now when we talk about mica, basically, you know, it plays a very pivotal role in the fire survival, fire resistant cable manufacturing. So, mica is basically an aluminum silicate, which is completely halogen free and produces no smoke or, odor when heated up. So, my virtual background, you can see, in fact, lists all the advantages that mica tapes have given the cable application. So fire resistant, low smoke, zero halogen cables use mica tape conductors to ensure circuit integrity in a flaming and unfortunate situation of a fire, giving people in excess of at least 3 hours to evacuate the facility. And we are talking about fire with water sprinklers out there, with the shocks, the mechanical shocks that a building can experience. So, you know, a fun fact to share with you, world's tallest building at a time, that was Taipei 101 in Taiwan, has been electrified in those days, completely using mica tape conductors in its cables. This signifies the importance of mica tape usage for enhancing the fire safety of electrical cables. Because nowadays the buildings that we live in, they barely get any sunlight. So the only exit in case of an unfortunate event of fire is by these emergency lights and, you know, alarm signaling and things like that, which gives people the awareness that the building is not safe and they need to evacuate. And plus make sure that the elevators are in a working condition. So layers of mica tape on a conductor ensures that. And now, since long, mica tapes have been used by the cable industry. However, reliable and consistent test results are hard to replicate. That is where Ruby Mica comes in with its innovation, because mica tapes have been in the industry for a long time now. So now multiple factors, they play a very critical role, like layer bonding, mica content, thickness, mica thickness. But you know, there is one key factor that we recently researched and came up in 2020. That is, mica is a product of nature, basically a mineral crystal that has some fossilized organic impurities embedded within. So almost at all the times, it is very difficult to separate them from the normal mica crystals. So it goes into the pulping, then we make mica paper out of it, and then finally it ends up in the mica tape subsequently. So innovation, what we have done at Ruby Mica, after years of in-house R&D, we have improved the reliability of mica tapes and consistency of the product. So, you know, which is very important in this industry now. And raw mica from the mines, when we get them, so we make them undergo a calcination process at the factory. So, you know, phlogophyte mica, which is never calcined normally, we do that at Ruby Mica, and all the organic impurities, they are burned off at 1000 degrees. So at the atomic level itself, when we look at mica, we vaporize the very water of crystallization that goes into formation of the crystal. So, you know, we make mica pure in every sense. So this makes enriched mica 40% more high performing in terms of dielectric strength. So for example, 120 micron cable tape will give you 1.2 kV. and that will go to 2 kV after the calcination process and once the mica paper has been used to make the mica tape. So high temperature endurance is better than ever. Basically, what is already burned, you cannot burn it further at the same temperature. Hence, this enriched mica paper, what we are making at Ruby Mica, plays a pivotal role in enhancing the insulation reliability and consistency multifold. So, mica tapes have been for long and they have a very critical role in this. And, but here what we are doing is we are enhancing the reliability and consistency. A lot of companies using mica tapes never get the same results. One company may be getting it successful, one company may not be successful in it, but here we are ensuring that you have a success, whatever and be it, wherever cables you are applying it at. So I can conclude by saying that India has the world's largest deposits of mica. Let us all come together in creating a general awareness about the fantastic and most versatile mineral known to mankind and try to implement its usage extensively, making this world a safer place to be in near future. So this is what I had to say, sir. And I hope, you can understand the innovation point of view that how Ruby Mica is trying to differentiate itself from the herd by making changes to the mica in the structure itself, making it more enduring and better in every way.
Thanks, Amitji. The other challenge, what we have, Mr. Amit, is like your glass mica takes care of your 3 hours test. But I've seen specifications coming from some of the consultants where even though they specify mica tape, they specify 750 degrees centigrade or 950, but unfortunately the sheathing material used is PVC. So your basic purpose of emission of low smoke and halogen gases is lost. And my request to my friends sitting here, so when we have this kind of requirements, it's our duty to educate the people who are not aware what cable is. Because we take utmost care in producing the cables, and if they are not suitable for what it is required, they rather use a normal cable than go for a fire survival with PVC sheathing material.
Very true. And sir, at times, one thing I would like to add, that companies a lot of times they fall short of using the adequate amount of mica on the cables, because that is very important. And that is a very fine line, that minimum 3 layers of tapes must be used, minimum 300 grams of mica at a point should be present. So things like these, I can really have a very nice discussion about it, that how we can make these cables more reliable. And these are like airbags. You may necessarily not need them. They may not be in the forefront. They must be always in the background. But when you need them, you need them. They should come out and they should play their part. So that is where I want to, really tell everyone about this.
My question to my friends on the dais is coming to this LSZH material. We have a peculiar problem of tensile strength and elongation. The sheathing material cracks. Like recently there was an IEC standard for EHV cables, IEC 60840 and IEC 62067, where they have specified ST12 compound with a tensile strength of 12.5 and elongation of 300% as against 9 and elongation of 125, which is LSZH type ST8. We would like to know the status of readiness of this material. If one of you can answer this. Is this compound available?
Yes, ST12 compound is available, but this ST12 requirement mainly is for the EHV cables, especially like tunnel type of closed conditions, industrial installation inside where the high heats, etc. is there. Normal application ST7, ST8 is good enough, but for the areas where tunnel type of thing is there and flame retardancy is of important, ST12 is required. And we have developed this compound ST12 which can give you tensile property above 12. In fact, it gives up to 14, 15 and elongation up to 500 to 600% as like your ST7. And this compound we are supplying from, as you know, Borealis has acquired the DYM Korea plant. So this compound we are supplying from DYM Korea plant. The grade name is, if my memory goes correctly, It is DYM 8867 NFR. More detail you can have it from me, whoever is interested, but this compound is available.
Yeah, thank you. Another question is, like, we have different grades of LZH material, and this compound goes into smaller diameter cable, which is normally not applicable or used in higher diameter cables, and we have seen there are issues in these cables. Can you throw some light, Madanji, on this?
You see, this all ZHLS compound, the current technology is using a polymer like EVA of a PA content around 28 to 33, because EVA has got a very low tensile. So to improve the tensile, people are adding LLDP to improve the mechanical property so that we meet at least 10 tensile and elongation of 200. And these materials has got a low propensity to absorb ATH. You know, ATH is a mineral filler, and the polymer which are currently used have got the low propensity to absorb it. So we use some coupling agent which enhances the coupling between polymer like LLDP EVA with ATH, because it's a mineral filler and it's a polymer, so there is no addition between them. So we use coupling agents. So to get this LOI value of 33, people are nowadays asking 35. So more of FR additives. So all these additional ATH reduces the mechanical. And the hidden criteria which we don't measure for small cables is the cracking. And the more filler, it will enhance the cracking of the material. So now to stop this cracking for higher diameter, these combinations are not used because LLDP is not suitable for that. And some special polymers, nowadays coming various copolymers which are being used. So you will find different grade for higher diameter which meets all the property without cracking. Every ZHLS manufacturer is having two different things. So as a user, you have to understand the difference between both, and obviously the special polymers will have impact on the price. Please don't use compounds which are for smaller cables for bigger cables. It will invariably go for cracking. Am I clear?
Yeah, yeah.
For both applications, we have two different types. So we have got crack resistant ZHLS compound.
Any new developments in compound as regards zero halogen?
Yeah. Hello. See, as Mr. Sureshji told you, the ZHLS compound with high tensile, high elongation, meeting all the parameters, and it goes for EHP, that means inherently it is crack resistant. Am I right? So here you will find the density between the grades. This is the all new innovative FR additives, which is not ATH, which is not MDH, that is magnesium dihydrate. You will see the density, like Borealis grade of this solar compound. It is 1.2. Even though it meets all the parameters like LOI of 32 and tensile, better tensile and elongation. So these are all new additives coming into the market. We are also working on those. A time will come when with low filler loading we'll have the high fire rating. So low filler loading, indirectly it is crack resistant.
Yeah, thank you. Yeah, Arnab, in case you want to add.
Mr. Madan Gupta, and he's already covered the HFFR part. Just one addition here. What is the innovation happening into that space? Because Dow being a almost supplier of all the components except the fillers, FR fillers for HFFR part, we have a lot of resin development because we are present in everything. EVA, we are in LLDP, we have the compatibilizer, we have the Elvala copolymers, star polymers, we have every component we are present into that. There is a lot of development happening because there is a challenge because we are going to replace PVC. A lot of talk happened in the morning. One of the limitations still is there with HFFR is a spade, line spade. Yeah, and apart from the cracking. And we have developed many resins, high line speed, that can achieve very high line speed in HFFR compound. This is just one of the things. Many other parts we are working into that to enhance that, the electrical performance of the resins as well for that, except the FR part. Yeah. Just want to add on that. Yeah.
Okay, thank you. Yeah, please.
Yeah.
Can we take the, okay,
I'm just adding this low smoke zero halogen cable, the tension problem and the cracks. So one of the development in the international market is, in India we are hardly using or only using petroleum jelly or grease as a lubricant, whereas there are dozens of different kinds of lubricant, and there are specialty lubricants for low smoke zero halogen cable as well that reduces the tension on the cable by 50%. And there are free softwares like pull planner software. So the tension is caused by the friction as well as the sidewall pressure. So if you are having control on these things, then these are the added things which facilitates the smoother pull. That's what I wanted to add. Thanks.
Thank you. I think in case you have any questions, we will take it at the end. You can make a note of it, and I'll give you an opportunity to speak on once we finish off with our discussion. Other thing like flame retardant material with low heat release and low smoke emission and zero droplet during burning for compliance to CPR fire classes of EU regulations. Now requirements are coming for flame retardant polyethylene, that is FRPE for EHV cables, to have toughness of PE together combining with the flame retardant properties. What is the status on this? Are we having it?
You are talking about FR HDP.
FR.
Am I right?
Yeah.
See, the HDP, I explained you, any polythene has got a low capacity to absorb any FR additive. So if you ask FR HDP exactly the same property like ZHLS, it's not possible because you are asking the hardness also of the same level. Invariably, it has to be HDP. So even Dow and others have achieved LOI of 28 FR HDP. Our DYM is having the grades. I have referred so many people. We are working. We have done some prototype manufacturing and tried 2 places, and we have achieved 29 LOI, but this is possible only in black color. When you remove carbon black, 2.5% carbon black out of it, the LOI drops. I don't know the reason. Maybe Arnab can tell you, this is the fact. So don't ask color for SDP. If you ask black, yes, I am ready with the product. You can try, take 1 ton material, run your machine. Parameters, the running temperature profile, others I will guide because it contains some FR additive. It is not like normal SDP. And it meets LOI up to 29 in black color. We are ready with the product. We have not sold commercially because some special raw materials are required for it. It is not manufactured by many people. 1 or 2 suppliers are there. And same, some polymer like Arnav has told, I told you that EVA, LLDP, this conventional polymer will not give you the special property like crack resistant and hardness. These are all special, innovative, new generation polymers. They are, Dow is the pioneer on that, then another is ExxonMobil. They are coming out with the, every 6 months they are coming out with the new grade of the material. And we are being compounders, we are always trying in our formulations. So FRSDP with LOI of 28, 29 on finished cable is available. Dow is having, Borealis also, we are also having.
Okay, thank you. One pertinent question which came to my mind now. A couple of decades back, there was a lot of study on TR. Today, I find a lot of utilities, the tenders are coming up with TR XLP for medium voltage cables up to 33 kV. Is it really required? What is your take? What are the new developments as far as TR XLP is concerned? Yeah, please.
Yeah. TR really, we started from this forum maybe long years back. Yeah. At that time, we were also quite late in India. TR journey started 1983 from Dow itself. Even I think Borel is also maybe similar time. Both have a different approach for developing the TRXLP. And today, we're not going to talk about what is the advantage of TR, everybody knows part, because it is almost 40 years, it is past reliability, field studies, field performance across the globe, not only in US, many parts in Germany, many Korea, many other parts. TR-XLP cables, even in India, we are working for last 10 plus years here. There is no doubt of the performance part. When moisture comes in contact with the XLP, there is always a chance. Moisture comes in different ways, but in presence of moisture and electrical stress, TR-XLP is the best performance, one of the best performance material giving for longer life. That is already proven from field studies, accelerated studies, that is proven part. Yeah, now the question is that whether it is required for, what we can tell that TR-XLP gives kind of peace of mind. In case cables are not coming in, submerged in water, but coming in contact in some parts, then TR-XLP definitely gives a peace of mind to the cable manufacturer and the utility both to have sustain the life of the cable. Yeah, but may not require when it is a completely dry, it is putting into the ducting, or there is no question of water is coming into that. That is the thing, yeah. But TR performance already proven. Not only that, even there is a lot of offshore cables. Now we are working into that. Offshore cables, I think Mr. Ghansham was mentioning in the morning. Offshore cables, we are working from India. He's mentioned about that. We have some case studies where offshore cables, we use TR-XLP as a weight design instead of the die design to avoid all the metallic barrier tapes and metallic things as well to make it more lighter, floating cables kind of things. I don't mean that TR-XLP have that performance in presence of the water. It is already proven part. Yeah.
Thank you. Would you like to add on?
I just want to add one more point on this TR-XLP requirements being mentioned by utilities in India for all 1133 kV cables. Yes, definitely TR-XLP is a better quality product in terms of insulation, especially in Indian condition where we have no surety the cable will be passing through the sewage line or drainage line or from where it will be passing. So those dangers are there, and for those purpose, if you have a TR-XLP, you have some additional protection in terms of the insulation layer. But the point is, after using TR, like it's like you are buying a diamond ring and packing in a woven sack or a ordinary kagaj ka thaili. What you are using, the sheathing layer, the first protection layer for your cable is your outer sheathing. If the water passes through the outer sheathing, then only it reaches to the XLP layer. So if you are using a PVC sheathing layer, means you are using a storehouse of moisture. Means on one side you are using a TR-XLP which should not get degraded due to the presence of moisture. Another side you are keeping a PVC sheathing layer which will absorb moisture, keep the moisture over there, and over a period of time impact to hona hi hai. So the point is, if you are going for TR-XLP, please go for it, but please change your sheathing layer, because sheathing layer is your first point of protection. If you are changing the sheathing layer from PVC to polyethylene, then TR-XLP will give you the real required result and a longer life. This is the additional point I just want to share.
So that means we need to update the specification of major utilities for better performance of the cables.
Yeah. Just want to add on one point, because TR is a very important point, and Sureshji mentioned the right part. Jacket should be the right one for that part. And similarly, I wanted to mention over here is other components like semicon. Semicon plays very important role, because water tree generates not because of the moisture itself. It is because of the contaminations, defect points present into the cable. Yeah, if your insulation is clean, if your semicons are good enough, smooth enough, and there is no protrusions coming from that, there is no bow ties is forming, we have to ensure that. The TR-XLP is just a simple component of that. But you have to talk about the systems when you are talking about that. You have to ensure that part also. Yeah. Yes.
We are talking on TR. See, don't think Dow's TR is same as Borealis TR, and for that matter, my Kalpana's TR is same. See, the prevailing technology, what we have studied and understood, there are three ways to make TR. One is, you will find all the technical literatures and TDS, additivated water tree retardant grade. Okay? Then another is polymer modified. So, for XLP, if you add any additional additive, you are sacrificing electrical parameters. Please go through the TDS details. Okay? Dissipation factor, dielectric constant. In TDS, compound manufacturers defines even hot set. You will find is higher in tree retardant compared to the conventional XLP. Okay? So, one makes additivated, another makes a polymer modification. The earlier knowledge was these all additional polymer which goes in along with polyethylene are copolymers, polar copolymers. And this addition of polar copolymers makes this stippability of a stippable outer semicon more difficult. So there were research going on whether we can use another non-polar hydrocarbon polymers. So for your information, we are using non-polar copolymers in our system. So we are different. Don't compare with Dow's TR with Borealis and Kalpana's. Third technology we are following, which is latest. This is based on technical studies. Okay? And you know, the cable has to be tested for 1 year time to really verify whether my TR is effective or not. And we have developed a lab scale test procedure like 7097 ISTM method, which gives a relative performance of the material with the conventional XLP with so-called TR XLP. Arnab has clearly told you this carbon black, that is semicon, plays a big role, even bigger role. If you use super smooth, ionic impurity free semicon with conventional XLP will perform better, even under the similar conditions. This ionic impurity which goes along with the carbon black, that's why the carbon black is so costly for making semicon compounds. The best and the pure carbon is coming from acetylene black. Acetylene black, which is produced from burning acetylene gas. And all other carbon blacks, conductive blacks, are made by furnace carbon black technique, where a pure oil, the oil is sulfur free, which gives the minimum ionic impurity. The total ion should be less than 300 ppm. Whatever metallic ions are coming from the system, that is the standard for say carbon black, which goes into semicon application. The best carbon black for semicon application is acetylene black. You know, for 220 and above 400 kV, all you go through the literature, these are all based on acetylene. The reason being, it is free from ionic impurity because it is produced by burning acetylene gas. Rest all are made by burning oil in furnace. So you are burning, then you are cooling down using water for chilling, stopping the burn. So ionic impurities come through this water also. So DM water or deionized water is used for making semicon. That's why these conducting blacks are costlier than conventional blacks. This is just I wanted to add. Use super smooth semiconducting compound with conventional XLP. I don't know. You have to need study. My perception is will give better result because he pointed out that actually tree growth starts from the end, either from the top or from the bottom from the semicon. This ion comes out from the semicon through water and goes into XLP, and then this tree formation starts. This is the mechanism I have understood.
Thank you for enlightening us on TRXLP. Now coming to sustainability, I think this is a buzzword around the industry. We're talking of carbon footprints, we're talking of sustainability. Sustainability is a key element as far as building a smarter and a future requirements are concerned. What are the newer innovation? I think this question is I'm putting forward to all the 4 panelists. What are newer innovations to cater sustainability requirement in cables? What are the solutions for a smarter and a greener future? What are the steps taken by the material fraternity to address issues related to carbon footprint and in turn enhance sustainability in cables? So I would like to begin with Amit ji. If you can throw some light as to what are the steps you are taking in your factory, and at the same time for the raw material what you are producing and selling to all the cable manufacturers. What are your thoughts on that? I think you're mute, Amit ji. I think we can't hear you.
Yes, sir.
Yeah.
Yes, sir. First thing, mica, when you talk about mica, that is perfectly a natural product. It is coming from the ground, it is coming from the mines, and we don't do much to it. We just simply change the form of it. So now what we are talking about, a family of aluminosilicates, mica being a silicate, glass being a silicate, silicon being a silicate. So all these 3 products, they come together, and that is what makes a mica tape. So, our process is absolutely non-polluting. When you come to our factory, you will see greenery, trees, and because everything has to do with water. Because mica also, when we pulp mica, we use almost a huge quantity of water for pulping. So energy-wise, you are on low energy. You don't have, I think the maximum capacity of a motor is 100 HP that is used in my factory. So you don't need a very heavy machinery to process this. So your electricity loads are low. Plus, you're using a lot of water. So there is a steam boiler is required, of course, for processing mica paper because you use heat to dry the final product. But it is very limited. So, you start with a very green element that is mica, which is biodegradable in nature and asbestos free and the best, most versatile electrical and thermal, very balanced material known to mankind. Because mica, when you heat it to red hot degrees, it still maintains its dimension and platy structure. So mica has been known to us since a long time and everyone's life has mica in it. So you start with a natural product, then our factory where you produce it, that uses all sorts of green energy. We do rainwater harvesting. So basically water is the major factor here. And then subsequently we use a low amount of steam to cure our materials and some electrical energy is used. So I think we are very green in terms, of processing, of producing the material, and mica itself says, go green, go mica. Because mica in a lot of places where you use heated platens for insulation, like your rubber presses, for example. So there you have mica to prevent the heat leakage. So mica is used to increase the efficiency of your furnace, your platens, you name it, mica increases the efficiency. So mica, I think, is truly a very green product to begin with. And it helps you save costs on electricity, and it, does away with all the synthetic and asbestos, carcinogenic compounds. So mica is very safe for the workers' health and very green in nature. So I think mica really qualifies as a very green product that I think companies, everyone should look into using. And it gives excellent fire-resistant properties to the cables.
Thank you, Amit. I think you need to educate all our customers here to use more of mica, more of fire survival and fire-resistant cables. I can see the big smile on your face here.
Yes. Yes, thank you, sir.
Sureshji, your take on this?
As far as the sustainability thing is concerned, yes, our raw materials, which are based on basically fossil fuels, whether the gas or the crude or naphtha, etc., which are all extracted from the earth. These are the conventional source of raw material from which we generate our building blocks, monomers, ethylene, propylene, and then from that we make our polymers. So Borealis has already started activity called Bore Renewable, wherein they are now doing R&D to develop alternate source from which we can generate ethylene, propylene monomers. So what they are doing, they are trying to take, let's say, vegetable oils, the used vegetable oils, collect it, and from there do the processing and extract ethylene and propylene monomers, building blocks, and from that use it for our polymerization process. That is one step. Bio-waste, from that extract the methane gas, from methane to make ethylene, propylene, these gases, and use it for our polymer manufacturing. So these type of activities are at R&D level being done. This will not come in direct knowledge of cable industry, because cable industry is concerned with the XLP, the end product. What I am talking about in terms of our sustainability activities behind, which is perhaps generally not known to the people, but this is a side activity which we are doing. And in addition to that, what we are trying to do is to improve on the polymer properties so that you can use less of polymer. Like, how can you reduce your insulation thickness? How can you reduce your jacketing thickness so that your consumption of polymer reduces, source reduction, what we call. So these are alternative methods of improving sustainability. This is how we are working.
Thanks, Surajji. Take from you, Madanji.
See, on this count, we are different than Dow and Borealis. We are not making polymers ourselves. So what we have done at our end is, see, we have upgraded our XLP manufacturing technology in the year 2016. Earlier, Kalpana used to make XLP by a process called injection in molten polythene, and then under controlled temperature condition, and then granulating. With this technique, we can make up to 33 kV. Since we are dependent on the polymer supplier, we buy the cleanest grade, but we don't know it may get contaminated in transit, in storage, and then in handling. So there was a big risk, and we were downgrading a lot of material. And you know, from peroxide XLP, downgraded material has got no use. So we were making a lot of scraps in-house. So we have upgraded our technology. We know contamination may come from anywhere. So we have changed our manufacturing technology in 2 steps. Whatever grade we are buying, we are filtering it at our end. Only simple filtration using 350 wire mesh. It's a 5-pack system. We are filtering, and then we are adding DCP at much reduced temperature where there is no cross reaction. The DCP is inactive at that temperature. It's below 100. In the earlier process, it was at 120 to 125 degree. At that temperature, some DCP, maybe fraction of that, will get decomposed and we'll get some gel. So we have discarded this technology and we have upgraded. We are going for 2-stage process. First stage is filtration and then addition of DCP and antioxidant. So this way we can reduce lot of downgrade material and scrap generation. And consistent quality is the end result. This is exactly the same process what Borealis and Dow is following for their XLP.
Arnab, I would like to hear from you, Arnab.
Yeah. Sustainability is very close to my heart, and because many reasons, and because there is 2 parts. One from corporate policy. We are actively working for last 25 years in sustainability front. Dagaji has already mentioned a couple of things. We are 3 steps. One from the corporate side, one from the cable industry side, what we did. First, I want to do based on the corporate side. On the feedstock, he mentioned that instead of the fossil fuel, we are looking for biofuels, not searching, but we already made polyethylene, supplying polyethylene bio source. Even one of the things, biopaste, we did not use food chains into that. We are using the waste from the vegetable oils or from other sources from the paper industry. We are not touching the food chains part. That is important. Second thing is that we are using A lot of grades we have now in biopolyethylene. We have a bio-engaged grade for different applications for that. It goes in the HFF part. Many footwear applications and many other packaging applications. Second is that we have a target of using 750 megawatt of renewable energy for entire Dow systems, all the plants, by 2025. That is another step. We are taking and decarbonizations and circular plastics. We are trying in all the possible way to ensure that part. And now I'm coming for these things, cable part. There is a very interesting innovative product we launched last year. That is HFDD 4201. It is a low degassing grade. We can reduce degassing by 80%. And this is one of the big steps towards the sustainability. The reason is that we are reducing the degassing. Is one of the cumbersome process and takes a lot of losses into the productivity. By 80%, it is a big achievement. You can save energy. You can save, that is one part. Second is it is excellent scorch redundancy. You can have a longer run, lower scrap kind of things. And third part is that we are reducing low greenhouse gas generations by this process and emissions also. That's why 3OS is helping in the sustainability for the power cables. Another part I want to mention is that TRXLP, I mentioned that we are working from the dry design to wet design. Some of the offshore cables, submarine cables we are working. That is, we are freeing the lead-free metallic shield, and that is successfully launched, installed in some of the applications. That is toward the sustainability part. Even for coming for the telecom side, we are talking of the power. In telecom side, we are working with many AJU-free, RHS compliant materials for high data generation, Cat7, Cat8 grade. That is already there into that. We are working into the compact optical fiber cables with different kind of jackets, with better, that is all are for in the direction of, Surajji mentioned that not only using different material, reducing size or thickness is another part for the sustainability. We are working that angle also, yeah. Just want to.
Thank you, thanks a lot, yeah. One important point which came into my mind is most of the plastics or PVC used can be recycled. There are certain special compounds, UV stabilization or pigments which are used. We find it difficult to recycle those compounds. At the same time, what are the developments as far as disposal of polyethylene or XLP? Like today in cable, aluminum, copper, PVC, steel can be recycled. But how are we going to take care of the XLP? Any thoughts on that? Any new development into that? Where it can be used, how do we need to take care of it?
Should I take?
Yeah, please.
Yeah, people are working for XLP. We know it is one is cross-linked. It cannot be, it can be little bit molten, but it cannot be very difficult to reshape in different form, kind of that. But we are working in different angle into that. One definitely is to reuse that material instead of the incinerations and landfill, what we are presently doing, to the industry is doing globally. We are thinking of reuse the material, different applications, some molded items in different forms, maybe in additives, in kind of any other reshaping kind of things that is one options. We are actively working into the de-cross-linking of the XLPs, but still it is R&D stage kind of things for, we are working into that part. Even for chemical recycling of the XLPs is another path, we are working into that part, but still it is some way to go for that, get a economical way of solutions for that, yeah. That is, yeah.
Any thoughts from you on this? Or
yeah, these activities, yes, it's still at the lab or R&D scale, and these are not going to be in Indian context cost-wise economically viability. So maybe one of the ideas, perhaps industry, many people might be already practicing. I just want to share some of the thoughts on that. The XLP, what scrap every company generates. So yes, this is a common problem for all of us. So how to dispose of? One of the ways which I keep on suggesting to all industry colleagues is crush it at your factory, make it whatever small pieces or powder form you can make it, and offer it to the road manufacturers. They can mix it along with the concrete and tar, and this can be used for road laying, and this improves the road water repellency and the bonding power of the tar with the concrete because of the polymeric nature of the XLP. And this can be one of the good way of disposing of our scrap instead of doing the landfilling. Then another thing you would like to say on that brick clean? Yeah.
I would like to say something. See, in Indian context, you see, every company is generating these scraps. One is LT, and then another is 3 layer. This black layer is there. He has pointed out, reduce the size by reusing crushers, and then go for pulverization. Maybe if you get a customer who buys this in bulk and does this, I don't think any cable people will like to do this. You have to find a people, like in our case we have found one. They get it from us, they pulverize it, make it powder of 40 maize, 40 wire maize. It is very, this is the super fine you can call this XLP. And then even they use it in virgin polymer up to 10%. 90% is virgin, high MFI SGP, and make all thick molded items like plastic floor seats and various things. And it gives a very good color also. I will give you some examples people are doing. Bulk users, they just to reduce the cost, and they take it. They take it, size reduction by crushing, small chips, then they pulverize it in a normal pulverizer. You don't need cryogenic grinder. It is polythene cross-link, easily pulverizable. So it will give you powder. And they mix it with virgin and do various type of injection molding. Extrusion is not possible. Extrusion is not possible, but injection molding, thick body, like road dividers, various applications, it is done, being done. A lot of people are doing, for them it is cost reduction. For us it is a sustainability. All thick items, by injection molding it is possible. We have done, you know, this garden pots, क्या कहते हैं उसको, गमला, वो people are making, उसमें color डालते various ये आता है. So है वैसा use है, आपको ढूंढना पड़ेगा.
Thank you. Next question is, I don't know if you can take it. What are the innovations to reduce losses in cables due to dielectric components?
When you talk of the loss part, there is different ways in different. One definitely we are doing in the industry by higher voltage we are using for reducing the loss and to have the carrying the same power to certain distance kind of things with the lower loss. But there, that is one of the approach. But the contribution of the dielectric losses is very negligible into that part, especially for we talk about the AC cables kind of things. And people are, another approach is differently AC to DC cables, lowering the loss. There maybe the dielectric losses contribution is comparatively higher. One approach already people doing like field compound for normal AC medium voltage cable, EPR or any other things having more losses than people use different kind of XLP, tier XLPs kind of things for that to lower the losses. That is one of the approach from the dielectric point of view people are taking into that. Yeah.
Okay. Next question is, nowadays people are asking for longer guarantee period. Earlier we were saying the cable, life of cable is approximately around 25 years. Now nuclear power plants, where they're doing the load cycle test, they're talking of 40 to 50 years. Your thoughts as a compound manufacturer on this, and what is the strategy?
We are not very actively working into these things. Maybe some people are making compounds of Dow resins for the nuclear power plant, but we don't have any compound for nuclear power plant, honestly. Yeah.
I think your question is more with the life of the cable.
Life of
right?
the cable, yeah.
Right.
Life of the cable.
So it's, again, the life of the cable is depending on what quality XLP you are using, what quality semicon you are using, what quality jacketing you are using. This will decide the life of the cable. So if you are having a XLP compound which is completely cured, no methane gas left out, complete degassing has taken place, there is no foreign particle into it, the life has to be good. If the semicon layer is with the purest form of carbon black, acetylene black, the life has to be good. So, and then in the earlier session we have seen the presentation by KEC wherein they have shown by RNA's graph that the life can be up to 40 years, 43 years. So this is possible. It again depends on what sort of polymers you are using, what sort of manufacturing processing condition you are maintaining so that no external contamination takes place during processing. This will ensure the life of the cable. There is nothing, no further great rocket science into it. That's what I can
Thank you. Yeah, please.
It's okay. See, I was talking to someone during the lunch, like degassing. Many people talked about degassing. There is a wrong conception that this is needed for high voltage cable only. Okay? There is a chemistry. The polymer, peroxide and antioxidant. These are the three components in XLP compound. Any peroxide will give a byproduct, which is at those temperature is gas. At room temperature, some of them are liquid, some are still gas. So it is generated across the thickness, even the thickness is 5 mm, it is generated across the thickness. Under this external nitrogen pressure, it gets compressed and comes at the surface. When the core comes out of the tube, you cut sample, do the silicon oil test, you will see lot of voids. Even if it is 33 kV, you will find a lot of voids. Keep it for 48 hours, you will get it diffuses. Suppose you go for the next process, put a tape on it. आपने देखा सिलिकॉन ऑयल में भाई अभी तो चला गया, चला नहीं गया. It is distributed on the top of insulation below the semicon. It takes time to physically diffuse it. If you give some like the grades which they are talking about, so less amount of gaseous byproduct. This is solution that will give you the life. It is very simple. They are not using the conventional peroxide. It is different peroxide. After degradation, any peroxide will give you the byproduct. Because it's a free radical reaction mechanism under heat and pressure. Pressure is required to diffuse the gas. Pressure is not required to cross-link. Cross-link is required only heat. Pressure is required to diffuse the byproduct. Okay? If you don't allow pressure, it will lead to foam. It will lead to foam. So it will simply set in and the gas will remain entrapped. So invariably, if you want to give this, put in your process, even if it is 33 kV, I will not immediately go for copper taping. I have to wait. Certainly that cable will give better life. Same compound, same process. Am I right?
Yes.
Clear? Any question further?
No, thanks.
Please.
My last question for the day. I want you to educate the...
Please. Pardon? आप हाई वोल्टेज के लिए क्या करते हैं? You have got the experience. आप उसके लिए 4 दिन या 3 दिन रखते, at least for 24 hours तो छोड़िए. It is because thickness के संग proportionate, amount of gas will be less if thickness is less. So 24 घंटे बाद taping करिए.
Last question from me. I want you to educate this August crowd on track-resistant XLP compound. Properties, advantages, where it has to be used. There are requirements coming up now for track-resistant XLP compounds.
track resistant XLP, I know that 50358, the recent specs asking for anti-track Plus or peroxide or HDP, 6 hours test at 3.5 or 3.7, 3.5 kV. I don't know why they are asking it. There is a spec in South America. They are asking 2 kV for 2 hours. Like for Indian OFC cables, the black jacketing, it is 2 kV for 1 hour. ADSS cable. Okay, same application. Why 3.5 for 6? It is not, I'm not saying it is not possible. Borealis has got a grade for HDP. It is meeting all the parameters. But it is very difficult to make these such compounds because it's not only the raw material, the process plays a big role. My experience for working on this project for last 2-3 years is whenever we develop this compound in the lab conditions on a small batch, it beats all the parameters. The moment I go for bulk manufacturing on the production machines, the tracking time reduces. I sell it, you make cable, it becomes worse. So I have done 2-3 trials. 2 hours, 2 kV is different technology. That is easy to meet. I will ask you cable design people why justify why you want 3.5 or 6. 2 kV, 2 hours is easy to make. It is 1 or 2 additive is good enough. Here it is a filled compound. You see the density is 1.2. The Borealis HDP compound 1.25. That means certainly they have added some fillers in it to make it anti-track. And those fillers are very costly, I can tell you. Very, very costly. The compound will not come Indian rupees 250, less than 250 kg. It has got a cost. आप सीडिंग कंपाउंड 300 रुपये किलो का यूज करते हैं बोरियालिस का. आप सी द व्हाट बेनिफिट यू आर गेटिंग आउट ऑफ इट. If it's 2 kV, 2 hours is good enough. It is easy, much cheaper, and performance I don't think will get hampered. Okay?
I had promised you that I'll release you by 6. Now it's 5:52. We have another 7-8 minutes. I think I'm putting this discussion panel open. In case you have any questions, happy to take. Yeah, please. You can name the panelists whom you want to address it.
Yeah, I would ask the question from Gupta sir. So there have been a discussion about the degassing of the XLP core before the copper taping. So even my colleague asked you one question. So we have taken this issue with many vendors, many OEMs, and I would say that we have got contradictory replies. So somebody said that, okay, your 33 kV cable, it is a medium voltage cable, even though the insulation is 8.3 mm or so thick, that doesn't require, and somebody has said, just as you said, at least 24 hours it need to be put for degassing before putting the copper tape. So I should say we are in fix. So what should we do? What should we specify in our specification?
Yeah, you use special compound like Dow is offering, low volatile. Kalpana has also developed this grade, but again it has got cost we are not offering. I told you different peroxide, different antioxidant system, and it has got cost. Whether you will wait for 24 hours using conventional grades or you will special compound go for your current practices. Solution is there, but it is always any XLP after cross-linking will have byproduct in it that needs to be removed from the dielectric material. If it remains there, it will reduce the life of cable. That is for sure.
So this is not only for us, but for the other utilities also, they should specify in the technical specification.
No, it is manufactured. It's up to you. It is up to the cable manufacturer. It is your practice. 24 घंटा में होल्ड करेंगे कि नहीं करेंगे. It needs money ना. अभी तो है कि फास्ट मूव, केबल बनाया निकाला, वो नहीं, आपको 24 घंटा रोकना पड़ेगा, आप 24 घंटे के बाद ही वो कोर को लीजिएगा टेपिंग।
सर हम तो यूटिलिटी वाले हैं, हम तो वेट कर सकते हैं।
सॉरी, मैं क्या ना, मैं सबको केबल मैन्युफैक्चरर यहाँ समझ रहा हूँ क्योंकि मैं तो सप्लायर हूँ सब केबल कंपनी का। अभी आप सोचिए आप कैसे इसको सिस्टम में लाएंगे। जस्ट ये मैंने तो प्रॉब्लम और टेक्नोलॉजी बताया कि ये स्टेटस है, यो कॉन्सेप्शन है कि वो नहीं कुछ होता है, नहीं ऐसा नहीं है, होता है और रहेगा ही, बाई प्रोडक्ट रहेगा ही।
One comment from my side is that normally we don't know whether the cable is really degassed or not, because the reason is that we don't have a very authentic method. Practice is most of the part of the world. Yeah, that is, but still I wanted to mention over here is that there is some practices very precisely, accurately and repeatedly you can check in the cables whether it is degassed or not. For the methane, acetophenone, cuminal alcohol, all can be very accurately, you can measure that. Because we worked in different, even it is part of the security chapters, and there is a method that is possible also. Yeah, but already one of the crude method definitely do by the seeing the bubbles into the hot silicone oil.
This is visual inspection, but if you go for the technique, he is saying that one of them is Orsett analysis, the gases by you can analyze. That is true. But for cable makers, they have to come out with this. ये जो concept है ना कि कुछ नहीं होता, even for 33 के लिए होता है sir, same chemistry है. Say like electron beam. अभी आप बोलेंगे electron beam में कोई by product नहीं होता, होता है? बताइए, होता है कि नहीं होता है? There through होता है. The by product is hydrogen gas. Just because it's very thin layer, it just comes out. So nobody is bothered about. But reaction, chemical reaction board पे जब दिखाएंगे, there is a byproduct called hydrogen gas. जो 8 डॉट निकलेगा, आप केमिस्ट्री किया, फ्री रेडिकल में इलेक्ट्रॉन गिना, एक हाइड्रोजन को प्लग किया, H डॉट निकला, 2 H डॉट मिलके H2 बनेंगे और 2 बेस मॉलिक्यूल आपस में जुड़ जाएंगे. दिस इज द मैकेनिज्म ऑफ इलेक्ट्रॉन बीम. सेम इज द मैकेनिज्म ऑफ पेरोक्साइड क्योरिंग ऑल्सो. सो बाई प्रोडक्ट तो बनेगा ही सर क्रॉस लिंकिंग के बाद. सायोप्लस में क्या होता है? सायोप्लस में क्या होता है? सायोप्लस में आप हाइड्रोलिसिस करते हैं, 2 OH मॉलिक्यूल मिलके लिंक होता है और एक H2 मॉलिक्यूल निकलता है. आप सायोप्लस में क्योरिंग करते हैं, मान लीजिए मैं LT की बात करता हूं, सरफेस पे ही तो वाटर है, बॉडी में कहां से गया? आप 3 mm 4 mm जो भी है, आपने आप तो बोलेंगे ये मॉइस्चर क्यूरेबल. अरे मॉइस्चर तो सरफेस पे है, अंदर थोड़ी डायलेक्ट्रिक के अंदर कहां से आता है? इट इज द बाई प्रोडक्ट H2O which is responsible for curing across the thickness. इस माथे से जाके अंदर तक क्योर हो जाता है. And this is reaction byproduct. Finally, it goes into conductor, and on top it goes on the environment. I am talking about the 1.1 kV. For 11 kV, it goes into semicon. तो वहाँ H2O निकलता है, इलेक्ट्रॉन में हाइड्रोजन गैस निकलता है, बाकी पेरोक्साइड में so many gases, मीथेन, एसिटोफेनॉन जिसका स्मेल आपको मिलता है, बहुत सारी चीजें रिएक्शन बॉय पर 4 डिफरेंट गैसेस बनते हैं उसमें.
So with the permission of chair, I want to ask one more question, if it is
please.
Okay. So just as you discussed about the track resistance XLP also, so whether utilizing these track resistance XLP, we can reduce the joint length, so that my creepage is in order, I can reduce the joint length, I can reduce the joint price, accessories price.
I am not able to answer this. Joint का मेरा experience कुछ नहीं है. I am zero on jointing technique. Have you understood the question? No, I don't. Sir, मेरे को आप बताइएगा. मैं
Okay, I will discuss.
I will try to get the answer. Sure. Even though I don't know, I've got friends in this field. I will get the answer. Exactly. What is your question?
Sir, please. I have one question. I'm from Adani, and we are using a TRXLP cable from 2012 onwards.
Yes, I know.
But we are not able to trace the grade of the material which manufacturer are using for our TRXLP cable, except raw material test report. So is there any method to trace the raw material grade?
It's very relevant questions, and because TRXLP performance is a little bit different, and it is not like a FR, non-FR, you can easily flame and you can test. It is because water tree generates after a long time. Yeah, it is a long duration process, and there is no easy test. One of the STM test, Madhunda mentioned that is 1 month test, but that is also very subjective test onto the materials itself. From the cables, only the thing can be possibly done, means it is already done in the industry, is that to find out the FTIR signature. But for that, you need the signature for different suppliers. Maybe from me, from Borealis, from Kalpana, whoever
Different
else.
IR graphs.
IR
Because I
graphs.
told you, every manufacturer has got their own patented technology
for that.
and all are
Sabka
different.
sabka
But
DNA
end
one
result
bana
is, it will reduce the tree retardant, tree formation. It is only reduction, it will not eliminate. I told you the elimination, use super clean acetylene blessed semicon and use conventional XLP. It will give better result, I am for sure.
No, that is for the identification part, yeah.
Yeah, I will.
For identification, you can do that by FTI. But performance differentiation, other tests are like AWTT, Senelec, 2 years test are there.
Thank you, sir.
Hundreds of papers on these studies. IEEE journals you find, I have done study for last 25 years. Okay, search the library, you will find hundreds of papers on that. Still not understood.
I think Ram Prasad, Bharat Saigal would like to speak first, then I'll take your question.
Good evening, Bharat Saigal from Polycab. I have two different diversified questions from the leaders in the compound fraternity. First one, what we are preparing for the radiation resistance and what level maximum we can achieve? Kilo gray or mega red, whatever.
See, a little bit experience working in Nico R&D, I know 100 megahertz is possible, but it is a special grade of silicon which meets this parameter, not all silicon rubber grades. Okay, and for jacketing, this oil resistance, BAMAC has got a grade which beats this. But I don't know, anybody has tried or that.
So, sir, how
if you ask me, the real radiation resistant polymer is PEEK, polyether ether ketone, which is proven, which is very hard. It meets all the parameter radiation resistant, whatever cable specifies. It is PEEK.
What is the maximum?
Polyether ether.
Yeah.
I have forgotten last 15, 18 years. It is polyether ether ketone. It is inherently flame retardant, which is highly radiation resistant.
So, sir, what is the maximum offering you can offer to the industry? Because see, ITR.
I told you, you have to go through the literature. Garda Chemical is manufacturer in India. Go through their data sheet. They will give you the exact data. I don't have, because we are into XLP only now, semicon. For radiation, I am telling from my experience. Silicon has got a grade which is used as insulation, which beats 100 megarad. It is proven. NICO came out with a product for Nuclear Power Corporation long back, 2004, I think, 4-5. Later on, I have seen this 7-core NPC cable. The insulation is PEEK, and outer jacket is again that silicon.
But sir, the industry requires now 2.5 kilo gray.
I don't know.
It means
I am
50 megarad. No?
I am not the right person to answer your specific question.
Because sir, all the leaders are sitting on the same stage now. I need to ask this. Because after reaching the office, if I call you, then there's a lot of discussion on this.
Yeah, you have to talk to all material scientists. Okay, I am a material scientist, but I have long back I have stopped further studying because of no use, because my company is not using it. आप मेरे को मेल कर सकते हैं, मैं कुछ उस पर खोज के बता सकता हूँ आपको. What I talked about with the experience of NICO Corporation, where I was working in R&D.
Bharatji, what I can suggest that we have a silicon group from Dow itself.
Yes.
I can check with them and we can connect with you. I have your contact details.
So these are the two polymers I know, silicon, specific grade, and PEEK is highly radiation resistant, used for insulation. But it's very rigid. You cannot bend it. You have to lay the cable at a very long lay. A small lay, it will crack. The elongation is 50%. Yeah. After extrusion, the elongation, and very difficult to color also. Na? If you use 7 color, very difficult to color, use any color master batch. So very limited scope for coloring the cores.
So it will be very helpful, sir. I will wait for your
I will.
answer. Sir, one last question, sir.
I will take 2 questions only. After that, in case you have anything, you can get in touch with them or get in touch with IEEMA. We will get the replies from them.
This question is...
Can I ask second one?
Yeah, please.
Sir, for ZHFR, what is the maximum tear resistance the compound companies achieve till date?
With these high elongation grades, I hope it is more than 10, 11. Because see, this elongation percentage is related with the tear also. If you have a long elongation percentage, it will have a better tear property. From the material side, this much I can tell you.
But sir, it is not reflecting in the TCs.
Again, see these properties again, HFFR depends on the process, what machine you are using, what die and core point you are using, what drawdown you are maintaining, lot of things. So that's the compounder will not specify everything because many things is in your hand, are in your hand.
No, this tear strength, tensile and elongation, all these properties for especially that ST12 grade which I mentioned, it is there in our data sheet. Now, data sheet is a standard thing in which all these properties are there. Don't expect these properties to be in TC which comes with every supply. No. Because that is not possible. You cannot keep the batch for 4 to 7 days to do all this testing because these are formulation set, same formulation, same process, consistency is being maintained, so the results has to be consistent.
Thank you so much, sir. It is informative.
A question from Ram Prasad.
Yeah, this is one very common question. It's a burning situation because in solar cables we use normally outer sheet is polyethylene. Okay, it is UV resistance. Whereas for PVC cables, it is not UV resistant but fire resistance. Can we have some fillers to the polyethylene so that making fire resistance? It's a big issue.
I told you, if Borealis is having such grade, they have also developed a grade. I told you Kalpana has developed in-house, not yet commercialized.
That's all, that's more important.
It is FR HDP, outdoor application, black in color, contains 2.5% carbon. The thing is, LOI will be around 28 to 29 on cable. If you draft a specification, mentioned LOI has to be 28 maximum.
Okay, thank you.
Last question from Kapil.
Yeah, so I'm Kapil Vadelkar. I represent Siemens. I represent Technical Council of Cables for Siemens, and thank you for bringing all of you on the same stage. The question is related to sustainability, and the question comes from we got a very big project in Egypt, yeah, for nearly about 6 billion euros of project, where we are supposed to supply metros to the Egypt. Now the problem is here when Egypt government asks us to disclose the CO2 content when we supply our solution to them. And this is where we are backtracking the supply chain now and we are reaching out to cable supplier whether they are able to give us the CO2 content in their cables. So my question to the fraternity here is, we are doing enough on sustainability, but are we there to specify what is the CO2 emission for your product or your grade, and how do we reduce this for the cable manufacturing?
We are not very actively there in HFFR compound itself, but what I can tell you that CO2 emissions can be measured, calculated, kind of.
See, when it comes to cable, there is not one single polymer. There is XLP layer, there is semicon layer, there is jacketing layer, and you may be using some different tapes, etc. So there are different layers. So the Egypt, whoever is your utility buying the cable, he is asking for the CO2 of the cable. So how polymer manufacturer individually can tell you what is the CO2 level? You cannot make any decision out of it. You have to burn your cable and see how much CO2 is coming, which is impossible. So first of all, the question itself is questionable. because CO2, if I burn fully, it will be CO2. Half burn, it will be along with carbon monoxide. So there are many such
CO2,
questionable things.
CO2, not in sense of CO2, but the carbon footprint, what we produce in making or manufacturing of a cable. So for example, when I was in APAR few months back.
Yeah, you are asking if I am understood is CO2 equivalent. If the cable is burned, how much it will generate carbon dioxide.
Exactly. Yes.
See, you have to, simple technique which comes into mind just now. We have got a test method called toxicity index, 713 NES. Everybody is now having toxicity index. There the 1 gram sample is burned. So you take out each samples from each layer of polymer, do this CO2 test, Bragg tubes method. Techniques are available, methods are available, machines are available, made in India now. Earlier we in Nico imported from UK. Now it is made in Delhi. Bragg tubes are locally available. The tubes are made in, it is a colorimetric method, and from the level you decide the ppm level per gram. And then you have to multiply with the total content of the polymer. Each polymer come out with a solution. This is what comes out in my mind immediately.
There is a technique. Exactly. I wanted to mention that even the polymers we do sell, we have the sustainability point of view, you have the CO2 emission data, CO2 equivalent emission data for each polymer we have. And that is very easily can be done. Yeah.
But that is mentioned in your data sheet now?
Nobody will mention. Nobody. It is the cable makers have
but
to
for
do.
our bio,
because you know how much insulation is there per meter, how much semicon is there, how much all other fillers. That is fillers to fill the
Let's say
gaps.
if cable industry, as a cable industry, if someone would like to use more sustainable material for manufacturing of cables, then do we look up to you that which would be more sustainable material than what I am using presently?
See, sustainability is a different thing, and CO2 you are asking is a different thing. Let's not try to mix up the two different issues. Sustainability is with respect to the source, the polymers which we are manufacturing, what base we are using, and what is the end life cycle of that. That is the sustainability part of it. Now, CO2 is something, if you are burning the material, then how much CO2 emission takes place, that is a different thing. So, these are two different subject, and it needs a different treatment. It cannot be answered in this way.
I think I'll have to cut short this year. Yeah. I'm sorry, I'm running short of time.
Now,
you have another 10 seconds, boss.
Yeah, now there is one requirement for a CPR. So, Kapilji asked for a CO2 emission. So, now exactly they are not measuring this COT, but now there is a requirement for HRR. So, if you go through in a detail with for HRR calculation, then there is a parameter for CO2. So, you can check out there.
Yeah. Thank you so much for your patience. I would like to thank Mr. Madan Gupta, Arnab Mazumdar, Suresh Daga, and Ankit Bagaria. Ankit ji, thank you so much. Thanks a lot. I would like to
Thank you, sir. It was indeed a great panel discussion, and in fact, what I can see from the panel discussion that many queries for regarding the business you have solved out. To further Siemens, if I can see, you have given a very good solution. Thank you for that. Now may I request Shashi Amin sir to provide to give a memento to all the panelists, please. May I now request Mr. Imtiaz Siddiqui sir to please come on the stage and provide a token of gratitude to Shashi Amin sir. Can you please align for a group photograph? Sir, a group photograph, please. A group photograph. Thank you, sirs. May I now request Mr. Shailesh Patel from ERDA to please come and summarize today's complete session. Mr. Shailesh Patel is a technical committee member of IEEMA division, and he is going to summarize today's complete sessions for today.
Good evening all. I think your face are looking dull, so have a light your face. So since morning we have started the sessions with lighting the light, correct? And the morning was very warm. If I talk about the today's Miss Charu Mathur has given the details about the IEEMA. So those who have not booked the date, please book the date. It is from 18 to 22 February 2023. Ms. Sonal Gupta has given the games about this 9th international conference, and given the mantra AAA. If I am not making mistake, ma'am, availability, accessibility, and affordability for the electricity, and cable play a major role for any kind of the project. If we call about this metro project of any city, then cable play a important cost parameters in any kind of these projects, and that is why the quality and safety is a prime focus for the while procuring the cable. And one more things that Mr. Kabra has given honest feedback and the weakness of the cable industry. So in morning the sessions, everybody look at the other faces during this feedback, honest feedback. I also appreciate he has given the honest feedbacks about what is the weakness in the cable industry and how to come up. Now the ball is in the court of the utility. Are they interested with the good quality? Because manufacturers are ready to come up with the demands of the utility. So main key focus points in the today's morning session, everybody talk about the safety and the quality. I think everybody require the quality and safety. So quality and the safety come only and only if the utility and the users make the stringent specifications, and they don't compromise with the quality, and then we can come up with the good quality of cables. And manufacturers, being a manufacturers, Mr. Kabra already told that they are ready to come up with a good quality unless until the demands from the utility and fair practice is adopted by the utility. So I request utility to look into the specifications and the stringent requirements. Also, Mr. Vijay Karya has also given the good feedback about the current practices. He has also talked about the standardizations specifications across the country, and government has also taken the good steps, what he has pointed out, and we know that government is really looking for making India concept. So, Mr. Ganesha Prasad also told that they have worked about the policies, and it is our bad luck. I say it's our bad luck. If we recall the Corona periods, the QCO, Quality Control Order of the cables, might be implemented in the August 2020, but somehow due to this corona, it may be delayed. That may be one of the reasons. And in near futures, maybe one of the parameters covered by these CEA team members, as per the Ghanshyam Prasad told that there are many policy will be implemented shortly. So I hope so that it should be the part of that. Then the quality of cable will be more stringent. Also Mr. Vijay Karya told that remove the L1 policy. He rightly told, because the good manufacturers really wanted to manufacture the good quality cables, but because of this L1 policy, they can't come up. They lose the tenders and during the procurement. So what is to be done? We should have a good practice while evaluating the vendors or the manufacturers, correct? So utility role is very, very important while procuring the cable and make the stringent specifications. I also remember the one quote that everybody has seen the Taj Mahal. Taj Mahal is so beautiful and everlasting. Now things, if Shah Jahan would have been decided for the lowest, then what will be the conditions? If in our talk about the Indian country, the mirror image of Taj Mahal is there. Anybody remember? The mirror image of Taj Mahal is there. And we can see the quality difference. It is in the Maharashtra. If you have visited in the Maharashtra, correct? So the mirror image of Taj Mahal is there, but really you will see the difference of quality. So this kind of quality should be there, and we should remove the L1. Our specifications should be so stringent that so that while procuring the products that can be covered, we should not focus only the money part only, because in morning sessions everybody talk about the deaths due to this fire safety and all. So we should avoid this fire and safety. We should worry about the single accident by compromising the quality of cable. So the today's message was very, very clear. We should be quality conscious, and we should have a good quality of cables and zero tolerance. We should have a concept of zero tolerance. Mr. Ghanshyam Prasad also already told to implement the many products, this policy and all. Now coming to our the session, today we have completed 2 sessions, technical sessions, and the first sessions taken by Mr. Rama Prasad. Right now he is the consultant, he is the ex-CPR, I mean, and whenever you discuss with him, he always discuss with this standard name. He memorized all standard. So he is a good quality of him, and he is very knowledgeable about the cables and all. And he has also rightly told, don't give the DC to the cable, because we know that the basic fundamental of the electricals, as soon as we apply the DC, the polarization take place. And the polarization take place, then without depolarize, if we apply the voltage, then definitely the malpractice will be there, or the deterioration of insulation will be there. That is why he rightly told that before charging the cable, properly discharge it. And I also agree, don't apply the high voltage unless until you require. Otherwise, as a high voltage man, I prefer that you do the non-destructive test. Don't apply the high voltage test in field, because by applying the high voltage, we are deteriorating the life of the cable. We should not apply frequently. Let me check the strength of my cables. Let me apply the high voltage. Why should we apply? We all have the cars and bikes. Like, are we testing up to its maximum position, maximum speed, 180 or 200 degree? 200 kilometers? Are we testing? It is not required. Because if you just try with your car, definitely immediately you rush to the service stations. for the car. Same things will happen to not only for the cables, for any kind of the equipment. We should not apply the high voltage frequently. We should use the diagnostic tools available, and we should use the non-destructive methods only. Don't apply the high voltage. And DC is definitely water treeing is also the one factor which affect the cables. So in these first technical sessions, this Rama Prasad rightly told, don't apply the DC to the cables unless and if in worst condition required, use the VLF very low frequency methods. It is nowadays the availables. So using that techniques, we can check the presence insulation conditions of the cable. In the first session, the first lecture paper was published by CPRI and presented by Arun Jyoti, Mish Arun Jyoti, and he has given the glimpse about the smoke emission techniques. So he has also given the review of IEC 61034 and the normalized value of the transmittance. Also, he has suggested to amend the standards and harmonize with the IEC standards. So that was the good glimpse of the smoke emissions requirement, because say when we talk about the safety, these fire related all tests are very, very important. And the second paper given by the Tata Power about the monitoring. This field is diagnostic. One more things I would like to emphasize over here, in the this IEEMA is organizing various divisions for this type of workshop. In every workshop, we normally see that the one kind of sessions having the diagnostic type or the case study types or the some new material, new technology, diagnostic, standardization, like that, the different groups are there. But with the thought process of Ms. Sonal Garibas, she told that let's have a combined group of theme so that everybody can enjoy at the same times, not at it stick to the one place. So hope you all have enjoyed. So this paper is basically related to the diagnostic types, and it is the real-time monitorings. This Tata Power has presented this paper. It is real-time monitorings for the reliability of electricity. We should emphasize on the diagnostic process. So these papers talk about the basic distributed acoustic sensing systems. And the counter question was also raised. Why are you not using the DAT in place of the DAS? So most probably this Tata Power will thought for that, and they will apply the combined method DAT along with the DAS. They have also shown the cost of the project also. Third paper presented by Ashish Nema from Adani Electricity, Mumbai Limited. Design, installation and commissioning experience of 11 kV hybrid. I think they are really worrying about the asset. Many of us have not seen the PILC cables, but this PILC cable is later on the synthesis development. Huh? Yes, they are really think about the fiber optic cables. So in EHV cables, we already using these fiber optic cables along with the power cables, but they have really thought this LV and the MV cables are equally important for the reliability of the power system. So I first thanks to them, they are really worrying about these MV cables with the fiber optic cables. Whatever the cost, capital cost is there, that is the E-materials. Our main focus is the quality of power supply and the safety. So I appreciate the thought process and the presentations by the Ashish Nema. They should think about the MV cable, power cables with this fiber optic cable, so that it is a one-type cost, capital cost is a one-type cost, but the main advantage is the reliability of the electricity. So one should think over it. and definitely it will help a lot for the reliability point of view. And the last paper, Dr. Nitin Shigne has presented on the synthesis and development of XLP nanocomposite for the HV cable. So today we are moving from micro to nano in all aspects. So definitely it will help a lot for the cable manufacturer. And he rightly told that with the nano compositions, material property is definitely improved, but he has also given the one challenges, and more work is required to improve the quality of XLP because the dielectric losses are increasing. And as far as high voltage cable is concerned, the quality of cables will depend on the healthiness of the insulations. If dielectric factor is increasing, that means the current flowing through the insulation is increasing, and we know that the current flowing through that insulating material is increasing, the heat dissipated in the insulation materials will be increasing, thermal deteriorations will be there, and the life will be deteriorated. So some focus he has already given that the dielectric dissipation factor is increasing by increasing the by nanocomposite materials. And he has also emphasized how to improve the life of these XLP cables. Also, he has given the best example with the area of the 3 BHK flats with the 1 gram materials of nanocomposite materials. So, with that, the first session was completed, and good questions from our audience also there, the question answers, and speakers has given the answers during the first session. This is the DTS versus DAS, and what is the advantage of hybrid 11 kV system. So, as I already told that it is a good practice. Forget about the capital cost, but definitely it will give the good feedback to the utility and the real-time output and what is the healthy conditions of the cable, so that preventive actions can be taken and the reliability of power system can be improved. Now coming to the second session, it is chaired by Mr. Anil Khopkar. He is HOD in ERDA. He has given the brief detail about the all papers and the detail. The first paper on smooth aluminum sheath, innovative strands in EHV cables, given presented by Mr. PC Guru Rani. Many debate was there on the this sheath, okay, about the bending strength and all. So of course the concept is good, and the utility, I am already emphasized on the utility only, because unless until utility will not demand, manufacturer will not manufacture. So they should properly analyze what is required for their field, for the reliability, and please consider the person sitting in the small corner of village. Please utility consider about it and increase the reliability of power supply. So they have given the good thought process for considering this type of cables. Almost it reduces the size, diameters of the cables. For bending strength, please refer the standards and follow the requirement whatever it is there. But they have the good glimpse for the new thought for the utility. Then second paper is given by the Ashwini Kumar Jain. He is from Adani Electricity. Evolutions of transition joints using the different techniques. So this Adani, they are still worrying about the PILC cables, paper insulated cables. Very, very old concept of PILC, and we know that the healthiness of this PILC is prime focus for this Adani, and really that's why I thought that they are really thinking about the asset, and they are taking care of this type of joint and all. Even in ERDA we have also taken this project, and it is quite successful by making this type of joint with the PILC and the XLP. No doubt the new setup and the hard working is required. and they are really thinking about this joint and the accessories part for these PILC and XLP materials. So he has highlighted few points how to mitigate the challenges on all while making the joints of XLP with the PILC cables. Third papers given by the Miss KP Meena from CPRI, Bangalore. She is also heading the cable division in CPRI. Effect of improper grounding on integrity of 66 kV cable systems. Everybody knows that this is important, but she emphasized that the lacuna of diagnostic is there. Nobody has taken care about after installing the cables, and the cable resistance, grounding resistance is increased. She rightly told that the divider ratio is there. So if the resistance of grounding part is there, then definitely the main conductor to insulations, one C1 parameter is there or the R1 parameter is there, and the grounding resistance is increasing, then R2 parameter will be there. So definitely the dividing factor is there, and voltage potential will be there. So reverse deteriorations of cable insulation will be there, and it will start from the sheath. So one should be very, very conscious about the earthing systems as far as EHV cable is concerned. For the single core cable, normally non-magnetic metallic material is used, correct? So we can avoid the circulating current from the materials. And that is why it is, she has emphasized to make the earthing at one point, middle point earthing. She has given the one case study, very good case study also. So, and we should periodically monitor what is the earthing, grounding, earthing conditions in the EHV cables, so that ultimately the quality of power supply will be there. And the fourth papers presented by Ms. Mithali from KC, determinations of life expectancy for XLP insulated power cables by different methodology. They have given the good thought process for the life cycle calculations for the insulating materials. They have considered few parameters after accelerating aging at different temperatures. My submission to them is that they should consider these few dielectric aspect in that their analysis, and come up with some new mathematical calculation, so that one can really understand the importance of these dielectric materials, because life expectancy is there with the thermal degradations, and in presence of the thermals, definitely the insulations will be degraded, and they have nicely calculated the methodology. They have compared the two methodology also. But my suggestion is that after accelerating the insulating materials, if they can come up with the measurement of the dielectric dissipation factors, it is one of the quality parameters that can be monitored while accelerating this insulating material, so that we can compare how it deteriorating with the accelerating of the thermal effect, and we can recalculate. This is my thought process. Otherwise, they have nicely covered that points and the mathematical calculation for that. Fifth paper on the improving medium voltage power cable performance through jacketing materials by Mr. Genders from Buruz. He has covered the right points about the jacketings. So since morning we are talking about the quality, so we should not forget about the jacket. So he has rightly covered the requirement and the quality points of the jackets, and jacket, which is the first layer of the protections of the cables. In the first slides, he rightly mentioned that it's the first layers for protecting the power cables. And three important parameters he rightly emphasized. And first one is the installations and what type of characteristic required during the installations, external environmental effect, and the impact on maintenance, particularly in terms of the electricals. And he also talks about the HFFR, PE and PVC cables and talk about the advantage of the pre-compounded materials. So, by this fifth, it's ended the second session headed by Mr. Anil Khopkar. And many debating questions were there about these diameters of bending diameters with the plain smooth aluminum sheath, and on the paper presented by the KEC for the calculation part and all. So after that, the second two sessions were completed. In panel discussions, it was really for a few minutes we thought that we are going to become a manufacturer, good manufacturer. They have given the good detailing about the raw material requirement all, and they have really discussed technical in depth about what is the requirement and all. So hope I emphasize more on the utility sides. They really understand, because the main topics is related to the cable manufacturers, but if the utility knows about this type of features, then definitely demands come from the utility. And as already told, that unless until there is no demand from the utility, cable manufacturers will never manufacture the cables, whatever the required for the person, the layman person sitting at the corner of the small village. So please be serious about the specifications and the quality concepts of the cable specifications. So this panel discussions helped a lot to utility and the manufacturers, and they have given the good answers to all queries by the delegates. So this sort the summary of today's first day of this 9th International Cablewire 2022. Hope you all have enjoyed it. So tomorrow we have the second day, and we have the technical sessions tomorrow. I request IEEMA committee, performance committee, OC and TC team, and today's all authors and chairmen, please come on stage for a group photo. All authors, chairman, organizing committee, technical committee, and IEEMA operational committee. Without operational committee, it's not possible.
Whoever is there, I think everybody.
Yeah, yes, yes.
Shailesh, nicely taken.
Huh?
The dinner is going to serve by 7:15. So I request all the delegates to do a networking sort of a thing and see you at dinner. Thank you.